Good morning, everyone.
They can stand somewhere between the middle of mic is there. That's it. Yeah. Everybody's talking about that question. Coming now. This is our
Yes. Can you hear us? Morning, sir.
Sir, good morning. I hope I'm audible.
Yes, sir. Very audible. Sir.
Thank you.
Thank you for joining, sir.
Yeah.
ये मेरा लैपटॉप है। Are you using this laptop for something? It's giving problem. Your laptop is.
4 minutes behind that. Extend that or start?
Actually, 6 should be there. Have some.
I think we should start.
सर आप गैलरी 3 में आ जाइए।
Like this one? Let's start. Settle everybody. Why was next time?
Okay. Okay. Welcome everybody. Let's settle down. Yeah. And let's we are 5 minutes behind the schedule already. Maybe 7 minutes. What?
A very warm good morning. I, Pooja Curry, and I, Ritvika Pandey. Welcome to all for today's business analytical conclave. Information is the oil in the 21st century, and analytics is the combustion engine. So that is why, in this knowledge-driven world, business analytics is making its own way, which is of immense importance and scope. Business analytics is driving the process of problem solving and decision making. Nowadays, data-driven organizations treat their data as a business asset, and they use them to enhance their competitive advantages. Thus, such knowledge on business analytics in various sectors of business will be shared by various speakers who we have today here. So we have Ms. Padmaja Rajendra from Google India, Dr. Sid Reddy from Google USA, Mr. Joachim Wickler from Arabian Labs USA, Dr. Sarabjit Singh from Tatras India, Mr. Shubhabrata Ghosh, All State India, Dr. Srinivas Padmanabhini from India, Mr. Thomas Vector, ITPS Switzerland, Mr. Sahil Makar from Happiest Mind India, Ms. Renuka from PayPal India, and Mr. Ganesh Mani from Carnegie Mellon USA.
We heartily acknowledge your presence to this grand conclave, embracing a data-driven culture, organized by School of Commerce and Management Studies, Danan Sagar University, Bengaluru, and Innocential AI. Event sponsors, ITPS Switzerland, Araba Labs USA, and academic partners with Data IQ and 365 Data Science.
Shubham Karoti Kalyanam, Arogyam Dhanasampadaha, Chaturbuddhi Vinashaya, Deepu Jyotir Namostute. Life is a symbol of brightness. As sunlight expels the darkness of night, similarly, blessings will bring happiness and prosperity. Now, let us make this occasion blessed by lighting the lamp of wisdom and knowledge. I would like to invite all our dignitaries to light up the lamp.
शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्परब्रह्म दीपज्योतिर्जनार्दनः दीपज्योतिर्परब्रह्म दीपज्योतिर्जनार्दनः दीपो हरतु मे पापं सन्ध्यादीपनमोऽस्तुते ओ दीपब्रह्मरूपस्त्वं ज्योतिषां प्रभुरव्ययः ओ दीपब्रह्मरूपस्त्वं ज्योतिषां प्रभुरव्ययः आरोग्यं देहि पुत्रांश्च मतिं स्वच्छामि मे सदा रवेरस्तं समारभ्य यावत् सूर्योदयो भवेत् रवेरस्तं समारभ्य यावत् सूर्योदयो भवेत् यस्य तिष्ठे गृहे दीपः तस्य नास्ति दरिद्रता शुभं कुरुत्वं कल्याणम्
Thank you, everyone. That was a very warm welcome, actually. So, before we start our event, I would like to call our Dean, Professor Captain Nagbal Subbarao sir, to present the workplace.
Yeah.
Thank you, Pooja.
Speak and
So, thank you, Pooja, for the invitation, and good morning, everybody. Honorable Vice Chancellor, Danan Sagar University, Dr. Murthy, Dr. Sid Reddy, Google, United States, Joachim Wickland, Arable Labs, United States, Dr. Sarbajit Singh Anand, Chief Data Scientist and co-founder, Petras Data India, Subhabrato Ghosh, Head Data Analytics, Allstate India, Dr. Srinivas Padmanabhuri, AI Thought Leader, India, Thomas Vector, CEO, ITPS Switzerland, Sahil Makkar, Principal Data Scientist, Happiest Minds, India, Renuka S, Manager Analytics, PayPal, India, Ganesh Mani, Professor Ganesh Mani, is a faculty at Carnegie Mellon University. Thank you for being here, and of course, a warm welcome to my good friend Siddharth Agarwal, who is the CEO of Innocential AI. We partner with Innocential AI in offering high technology courses to industry, to working professionals. And this is a new initiative which has sort of come to fruition from School of Commerce and Management Studies, Executive Education. We plan to launch our first set of programs in January of 2023. And these are really high technology programs, and I'm really looking forward to it. But why this conclave? And when Professor Alok talked about it, he was talking about a business analytics conclave. But as you know, we are in the management space. And while business analytics is important, what is more important is whether organizations today have a culture of using analytics for, like Pooja said, gaining competitive advantage. Sadly, that does not seem to be the case. 3 out of 5 people, when questioned, said that they do not see analytics percolating down to the last person in their organization. And so, unless we have a culture where analytics is understood and practiced and applied, and it is used to predict problems and solutions, really having analytics per se is of no great use. And that is the ethos of this conclave. We hope our distinguished speakers will touch upon the management aspect of analytics. Analytics is pretty well understood, and what it can do is probably more important. And of course, many congratulations to Professor Alok Chakravarti, who heads our Center for Proficiency Enhancement in Business Analytics, ably supported by our senior most professor, Professor Shankar, who has been a great source of support, and of course, all my faculty colleagues, students, staff, and so on and so forth. So warm welcome to all of you. And with that, I will sort of request Siddharth, in bracket Sid, to tell us a little bit more about what he has planned. Yeah, I must thank Sid for flying down from Delhi for this event. Likewise, I like to thank ITPS Switzerland and Arable Labs in the US, as well as our academic partners, Data IQ, as well as 365 Data Science, who has actually made learning for our students so much more robust by supporting the School of Commerce and Management Studies for almost nothing. So thank you, all of you, for being here.
So good morning, everybody. Thanks a lot, Captain, for setting up the tone of the day. And Essential is really delighted to partner with the School of Management Studies at the Sagar University and launch these programs for executives, for working professionals, for graduates at the intersection of AI, data science, analytics, and their application to the industry, right? And we are absolutely delighted to start our partnership with this first conclave, the analytics conclave that Professor Alok architected. And we are really delighted that we have representation from all over the industry. And we have speakers from Google and CMU and other places today sharing their knowledge in this forum, basically. So we basically are really, looking forward to host such more programs and events in which always lies at the intersection of industry and academia, so that we can understand what are the real business value which can come out of such programs, and how analytics basically can help an organization move forward, do new things. And since we are in 2022, it is very important to understand that what form of analytics is basically making inroads into our industry, into our day-to-day lives. Now, analytics has existed in the world for like many decades, but now because of the advent of all the new kind of processing power and different, GPUs, etc., the new forms of analytics like prescriptive analytics and analytics without data and all fancy form of analytics which exists around the corner. And by virtue of that, there are many, miracles which have been possible. This year, 2022 and 2023, is basically called as text to anything in the world of analytics, because last year we saw, researchers doing text to video, text to voice. So everything which can be produced from text has been exhausted. So we are positioning this year as, text to anything. So this is a very exciting time for analytics, AI, and all. And we are excited to, kick off our partnership with Dayanand Sagar University with this conclave. And we look forward to contribute to this region, institute and the field through the programs that we have. And now I would like to hand over to our Honorable Vice Chancellor to do the welcome note. Thank you.
Good morning. I hope I am audible.
Yes, sir.
Yes, sir.
Yeah. Respected Dean, distinguished speakers, my faculty colleagues, students and others who have joined this particular meeting, the conclave. I'm extremely happy that the School of Commerce and Management Studies has taken an initiative to organize a conclave on embracing a data-driven culture. This is timely for a variety of reasons. Most importantly, it's possible to make a transition to data-driven culture in the future in view of the enabling components that are existing. If we look at the kind of decisions that have been taken in the past by the organizations who are purely on the gut feeling, where it was based on the intuition that decisions were taken, quite often the intuitions may go wrong, our intuitions may be incorrect. Therefore, the decision making in the past was not considered to be backed up by any scientific evidence. With the data-driven culture, it's possible to make decisions based on the data, which is being analyzed and has scientific evidence to arrive at the decisions. Whenever we talk of culture, culture is all about bringing an environment and ambience in an organization where the use of data is being discussed, being encouraged, and also supported. That's what we mean by culture. Once the culture is established, I'm sure the process would start in terms of collecting the data, in terms of ensuring that everything is going to be based on the data-driven approaches. Once the data-driven approach is being embraced in an organization, the decision-making will be on the data, most importantly, analyzing the data and deriving some conclusions based on the data. Whenever we embrace the data-driven culture, two things become extremely important. One is building a data model, means how exactly the data is being collected and what is the purpose for which this data is being collected. That's going to be critical. The data modeling is the most difficult part. The second important aspect is processing is standard techniques are available to process it. However, the interpretation of the results are arriving at a conclusion based on the analytics that's being carried out is another difficult part. In my understanding, these two are the most difficult ones. The data modeling is extremely difficult. Similarly, the data interpretation, in other words, or making a decision based on the solution that we arrive at, based on the analytics that we arrive at, is the most difficult part. Because anything that can go wrong in the data collection process, similarly the interpretation process. is as difficult as the topic itself. Therefore, it's extremely important for us to understand whenever the data-driven approach is being used in an organization, we need to be sure that we are using the right data model and we are also having the right data interpretation or the data decision model, the decision model. And what is the advantage of using the data-driven approach? The data-driven approach will give lots of advantages. One of the advantages, it helps us to formulate new products, helps us to improve the services, helps us to take few workplace initiatives. It's also even help us to identify the trends. Thereby, it gives lots of, I should say, inputs or the power for an organization to venture on multiple things. Therefore, it's extremely important for us to understand the power of data-driven approach. And you also know that the power has been enhanced with the digital technologies being available. Be it in terms of collecting the data, be it in terms of processing the data, be it in terms of finding the graphical analytics of the same. Therefore, the digital technologies or the digital revolution has also helped the data-driven approach being used for multiple purposes. And is also equally important for us to understand the limitations of the data-driven approach also. Let me take a simple example to make it evident in terms of the power of data-driven approach. It can be understood in either way. This service, which is being provided by service provider, was used by the customers. This service has been rated by the customers across the various places. Maybe if you take India as a unit, in India, the service has been rated. Let's say the service has been rated based on certain rating mechanism, maybe 5-star, 4-star, 3-star, 2-star, and maybe 1-star. Let's say for a particular service, about 12,729 reviews were taken. The data has been collected from various people. 3,100 people have rated as 5-star. About 3% of them have rated it as about 382 of them rated as 4-star. About 3%, that's 382 of them have rated it as 3-star. And 3% of them have rated as 2-star. About 66% of them have rated it as 1-star. If you look at the average works out to be about 43%. 25% 5-star, 3% 4-star, 3% 3-star, 3% 2-star, and 66% 1-star. How does it work out for a new customer? The new customer would look at the rating, would understand it differently. One way of understanding is about majority of people is 1-star. It means the service may not be good. Therefore, let's not go for that. That's one way of interpretation. Or an intelligent customer would probe further to find out where this particular data is being collected from. Is it collected from a single city, across the cities, or the data pertaining to that particular city, that particular service? If you start looking at that kind of a thing, possibly there may be 5-star for the person who has using the service in that locality at that particular place. Therefore, the data-driven approach gives us the power to drill down to the level that can be used for making a decision. Means a new customer will decide to go for that service or not. One way of broad way of looking at this, the average is 43. 66% of the people are rated as 1 star. Therefore, it may not be a good service. Let's not go for it. That's one way of making a decision. The other way of making decision is to drill down further and find out where this particular reviews were taken or the feedback has been taken. Look at the feedback for the area in which the customer is staying, then decide to go for the service. Therefore, both the things are possible as far as the data-driven approach is concerned. And in the absence of data-driven approach, what normally being done, they ask their neighbor or somebody, whomsoever they know, find out whether which service is really good, they go for that particular vendor for providing the service. And one important thing that all of us need to remember is that how this data is being collected is also equally important, because the data reliability, the data integrity becomes very, very important, because in the data-driven approach, that's one of the important things. The other thing that's also needs to be looked into the data-driven approaches is to ensure that the data redundancy is being taken out. Meaning, there's a possibility that the same person would have given 2 feedbacks. The same person would have given 3 feedbacks. Or the service provider might have gathered all good feedback and put it over there. How do we look at the data consistency or data integrity? That's also very, very important for a data-driven approach. Eventually, when the data-driven approach, in my understanding, 3 things become extremely important. One, the data to be collected and processed ethically, securely, and transparently. Extremely important for this to be done, because the entire decision making based on this particular fact. You are also aware that a lot of organizations have made a transition from the approach that was there to a data-driven approach. One such example I can give you is the NAC, National Assessment and Accreditation Council, has made a transition from the approach of the visit, where the data is being collected, against a data-driven approach. They have used a 70-30 model. Now they have started evaluating how effective the data-driven thing is. Again, the entire efficiency or the overall efficacy depends on the integrity of data. The other thing that also we need to understand is, in terms of data-driven approach, lot of data pre-processing to be done. Means whenever we collect the data, is equally important for us to pre-process it. What do I pre-process? Pre-processing is basically to remove the redundancies, to ensure that the consistent data is being captured from various customers. Let me give an example. For example, there's a person who has, these days the data is being collected through the mobile phones, through the digital techniques. Let's say the same person, a person has 2 or 3 mobile phones. Provide the data from all the 3 mobile phones with the same name. How do we process? How do we take that particular data? For sake of argument, let me say the same person has given 2 different data or 2 different feedbacks on 2 different mobiles. How do you process it? How do you check the overall the data quality? for data quality becomes very, very, very important. The second thing that's extremely important in the data-driven approach is to ensure that an organization adopts this data-driven approach to be reflective and credible. What about reflective and credible? Reflective and credible basically means the quality of service is reflective of the rating. Once the quality of service is reflective of the quality of service reflective of the rating, immediately people started taking it as credible one. Means any organization that would adopt the data-driven approach or data-driven culture has to ensure that the decisions or the kind of support or the kind of feedback, the kind of service that's being given is reflective and credible. Credible means what? They don't check anything further. There's no need for any endorsements. They are going to adopt it directly. They trust the organization in terms of the quality of service and the rating that's being given. That is going to be very, very critical in terms of the data-driven approach being adopted by the organization. The last thing that also needs to be looked into is data validation. Data validation is basically the removing the redundancy, ensuring that the right feedback and right kind of audience are being collected. For example, I collect the feedback from the person who is not using the service at all. Then it may not give the true reflection of the kind of that those points have to be taken up. The other thing that also needs to data-driven cultures, the data-driven approach that can be done is with regard to automation, where some of these manual things can be automated. And the pre-processing can be automated completely by using AI and machine learning techniques. By using AI and machine learning techniques, it's possible to automate some of these components so that the biases can be removed. Because one of the critical difficulties or the most difficult thing that normally happens in a data-driven approach is to look at the quality of the data, is to ensure that the data is being consistent, that data is being very well taken from the various sources. I'm sure this particular conclave will deliberate on various aspects, the kind of results the organizations have obtained by using this, and they also talk about the process of getting a better interpretation or better decision making using the data. And it's also possible that with data-driven culture, we can use what is called as 360-degree view graph. It means it's possible to look at the decisions based on the kind of question that we can ask. Because of the automation, the digital techniques that are possible are using AI and machine learning, it's possible to ask more questions. I'm sure this workshop would deliberate, or the conclave would deliberate on that. At the end of this particular thing, we understand the advantages, the limitations, and also the right approach to be adopted for using data-driven culture in an organization. I thank the organizers for inviting me to be a part of this conclave and also share some of my thoughts, and wish this conclave all the success. Thank you. Thank you very much.
Thank you so much, KNB sir, for your valuable insights. And now we know, according to his speech, that how important data-driven decision and importance of automation is in today's business world. And nowadays, business analytics is used in various industries for more growth in short duration of time to gain more profit than usual. This is why I think our DSU comes with a vision to inbuild knowledge of analytics in all of us. We all belong to different study backgrounds, and for some of us, analytics subjects is very new. But thanks to our professors that for making it comprehensive for us and letting us understand the importance of business analytics for us.
real world application to give more insight about, we have with us here Ms. Padmaja Raghavendra from Google India. Ma'am is a seasoned software professional in end-to-end management of enterprise and consumer software products. Ma'am has a passion for technology and worked at various companies like Yahoo, Walmart, and Google, where she was leading a large horizontal programs like holiday readiness at Walmart site, Yahoo Cricket, and now with Android TV, where data was a key and prominent of agile methodologies. We welcome you, ma'am. Thank you.
Start with key dates. Add a little time.
No, that's fine. Perfectly fine now. Be cognizant of that. So good morning all, and thanks for the opportunity here to be presenting some of my experiences and sharing my experiences here today. It's a privilege to be here with so many and listen to so many speakers and also interact with students and learn today. So thanks for organizing this and inviting me here. I'm a technical program manager at Google Android for Android TV, program management there. So I thought that, as a program manager, as we were talking today just now, I heard a lot of them say, how do we build in the culture of getting data and analyze it at a grassroots level, right? I interact with a lot of engineers and every day I'm in and out with them, with product and, designers designing products. So I thought I would share some of these experiences at a grassroots levels. They are not, ML heavy or artificial. They're very basic data that we take and interpret it and build that culture. So that's what I'm going to kind of focus on. There are I'm going to talk about 3 use cases that I've had in my various organizations. One is how to upload system designs using that with Yahoo Cricket. With personalized, this is an NGO effort schools. Get personalized learning for every student in all the rural government schools in Karnataka. And of course, as we talked about, how's the process and methodology being used to drive data culture. That's the third piece. So diving deep into, I think we have a lot of, India's religion of cricket. And I was fortunate enough to work on Yahoo Cricket. We at one point in time, we were just building the site and everything, and then at one point in time, we got a contract with ICC saying that Yahoo Cricket will be the World Cup site. That's a huge thing for us. It was a huge thing for us. It was very innovative, inspiring to be recognized as being somebody where we can showcase our ability to provide this the sports side to the world. Things that we talked about as a team was, what would be the best thing for us to do? One of the items was being available. Availability should be 100%. That means that every sports fan who goes to the site has the site available. You don't see the loading screen. You don't see server not available, 503, or too many people are in. So that was the goal. And how do we approach this, right? If you think about it, this has to be data driven. Otherwise, you cannot. So one of the problems that we had was server capacity. How many people would come to a site during a World Cup? How would it change if India was in the semifinals? How would it change if some people India is getting closer to a real exciting finish? These were the problems that we kind of were looking at, and how do we provide for the server capacity? Usually, server capacities are done like how many requests, how many people are coming on the site, and how does the server at the back end handle that? So that was the problem that we were looking at. So we took the first approach of, okay, let's go look at all the old data that we have, our old ODIs, and figure out what that comes to. So we looked at past data, we looked at, put some forecasting models based on, how much growth we have, because it's a world event, and, and we kind of came up with a model, and we said, okay, this is, we took the peak capacity at any match and then added some buffer. And I said, okay, this is what will be, and this is the request that we get on the server. So now let's calculate back to how many servers we need, how much capacity we need, and the amount that we needed. The budget was huge. There's no way we could have, gotten through, or would have, our leadership would have agreed to give us that budget to these servers. So we went back again, looked at data. This is a hot trends Hotstar pattern that I couldn't get the original one to share, but this is like typically a batch would be like this. There would be average leak, there would be average number of people looking at it. Something happens where, especially if it depends on where you're being playing, or where the match is being held, what time it is, or if it's a semi-final match, or if it's a match where it's crucial to get into different, like from an A to a semi-final, and then you would start seeing like the peak go up. Right. And the other very particular thing that we observe about any match that the peaks are at very short duration, as you can see in this particular data. So if we looking at these patterns and data, we realize that it's not needed that we go to the peak capacity and allocate data. If we do the average, we are good enough. Now we need to think about how do we solve for that 20% when there's actually a peak. So that's how these patterns and data help us at least arrive at options and solutions for this. So what we did was we took average capacity, we took the average rate, said we're going to go with that, put our servers, and now what happens now? Now looking at it, we calculated based on what's the peak, what's the difference that we have, and then the way we're going to do is this is how we arrived at the figure. But there are different solutions, but this is what we came up with. We forecasted for a bit capacity for average, and then when we hit peak, which was for a very short duration, maybe 1 or 2 minutes, we decided to do static pages. It's like a delayed match kind of policy, and stats and videos, and our servers were always available. Ours was the only site during that time of the World Cup that was up running. Always available to the user. So that is kind of how we approach our data driven, save budget on money at the same time make the customer or the user happy. So this is a very simple example, but very powerful, because there were so many million people arriving at the site.
And did you have problems?
There were problems in the sense not about capacity, but other problems. We did have incoming data issues, streaming issues, where it's from the provider into the system rather than from outside, like the users being not able to use the system. So
I have a question on the forecasting model. Was it a dynamic model?
it was like a very simple model that we did at that time. Yeah, but it was not dynamic at all. It was because later on we started doing that. This was our first stint at it, so it was, we didn't have the knowledge and the ability to do it. But then later on, when we started looking at it, we said, okay. Also, like the other thing is also this is where we had everything was not on cloud; it was on-prem, and now with cloud, it's much more easier to do dynamic modeling and forecasting it so that holding. So
This is for a past event.
yeah.
What was the peak for that event?
So this was the peak was around. I think this one, the Hotstar one was higher, but for cricket it was at 25 minutes.
Is that the reason sometimes when you refresh at peak time, you will see
Yes, yes, because there are models. The thing is nowadays cloud at least it's better because they, there is elasticity, so they keep pulling more servers and building servers and VMs. But earlier, like this is a fast body and that.
If you have predictive forecasting model, can backed by responsive cloud.
Yeah.
This could be handled better.
Yes, yes, and that's the way forward, right? Like, yeah, we were looking at more dynamic and responsive. We also started putting in places where we started looking at once we had this, then we could do more analysis. And that time we didn't have the cloud capability. So now with cloud also it's kind of come down where these kind of we're not so much putting so much effort into trying actually the cloud. Because the cloud we are asking to spin up servers in we have to give minutes. So
What was the difference between the average and the peak in percentages?
it was about, I would say between 30%. Yeah, 31%. It was pretty good because you could save a lot of money.
Yeah.
Yeah, otherwise it wouldn't have worked. And initially we were, when we started doing, we said, okay, let's do the 80-20 rule where we would just do 80%, but even 80% was considered higher. And the other thing was also, if you do 80%, because we were not in cloud, there was no elasticity. So we literally had to, those servers would sit post the World Cup just lying there, right? Like nobody would use it.
Did it contribute to revenue increase for?
The revenue model was not, at that time, was not advertisement based, it was more sponsorship based, so that was a given. Yeah, so.
Thank you.
On to the next one. So, this is something that I worked with an NGO to personalize learning in government schools. This is solving for the community and solving for each student. The goal was to provide quality education to all students in government schools in Karnataka. I just want to see how in this field, you can use data and do a very unique kind of a solution to students. Karnataka State Education Department manages about 48K schools, 3 million students, and 34 schools. This is the scale, and this is the problem that we had to solve for every student who's there. Typical approach to quality education would be, you conduct exam, you teach, you have a textbook, you teach, you conduct a year-end exam across all schools. You calculate like unit test, midterm, whatever, and then you calculate all the get all the results. You rank schools, you rank districts based on student performance, and then you see, oh, these are the bottom districts, these are the bottom schools. And the typical solution would be to go to teachers and say, hey, you need some more training because you need to get your school rankings up. So that's a typical approach that we do. Work with an NGO called Shikshana, which is working into the education field and trying to up-level the learning outcomes in government schools. And what we did was, this is how we use data and technology to kind of assess. So we assessed each student's efforts in learning through OMR technologies. Like we gave them like what you would say, what are the competencies that we want to measure? There are 6 subjects in Karnataka schools, and for each of them we measured, like we said, that like in math it could be 4th grade should have they should know 2-number division, right? So these kind of competencies, we developed these competencies, we decided what these competencies are, and we gave them workbooks. Everybody, from I think it was grade 2nd to 7th. Gave them workbooks, asking them to do these problems, or it was Kannada, then write certain things or recognize and things like that. The workbook was designed so that we could assess their competencies, and then we graded them with not like marks, but with yes and a no. So that would give us a very good way of understanding if they are competent or not in that. And so we went through all these schools, every student who got a workbook and did this, right? And then we measured, we got a lot of data based on this, right? Every student's data was available. And then based on that, and we did like this yes or no also, because that was the only way we could assess fast. These are OMR sheets which would, go through, like we were doing like some 1,000 sheets per hour, and we had like n number, right? Because 6 subjects and so many students. So you to get that, it took us a month to just do the data analysis, just calculate that. And the only way we could scale was OMR if we had done manual correction, not possible. So and the other thing was we also added this was like a 6 month actually we should kind of do the data analysis and get the data as like if we are attending then on the mobile the teacher in the school would should have a class, he or she would have a class list and they would do the attendance, they would do they're attending school, they're staying for the whole day, are they taking care, how do they come to school, are they dressed properly, like those kinds of hygiene things and everything that we kind of, there were a lot of competencies, a lot of things that we assessed during that time. Then based on this, we were actually able to process all this data. Now we have data of every student with a name, with an ID. And the next time, so we did this in 2017, 18 and 19, where we, of course, this got implemented statewide, but the result we got out of this was awesome. Data was generated for 3 million students across 6 subjects, 10 competencies. So there were 180 million data points that we did. But because of this, now the state of Karnataka actually has, we could provide customized workbooks were issued for every student in 2 years, at least 2 years, where they actually did the competency and they were able to understand and we could actually figure out which student is good at something or not and how we can help them rather than just doing it. This was a very long process. But I think it had a very good solution, and this is still continuing with the government. It's more free. Now the government itself has adopted this program, and Shikshana is just a provider. But there are a lot of schools. I don't know if you have heard of this program called Nali Kali also, which is like similarly where based on your competency, the student moves forward. So that was the outcome. Just wanted to like this is a very unique solution which is provided using data to students. I think
fantastic, but the challenges look quite large. Right?
It is large. But it's actually I can provide more data on this as well. If you go to Shikshana.org, you can see all the data. They are trying to scale. So yeah.
It sounds very interesting. The numbers, is it possible to come up with something that can be taken by other states or at a national level from the positives from this?
There has been an effort right now to look at it from like the government department has asked organization to come and present in various forums where they are looking at different states. There are a couple of other programs that this particular NGO is doing, which is actually being adopted by other states.
Do you support researchers to get access to this kind of data? Because researchers find it very hard to get hold of it.
The NGO data is definitely available. Yeah, that's not.
But even otherwise, if somebody is looking at a research and if you have the data or if you collect, you actually support this model.
So usually companies like Google will not provide that data. There will be some data that's public and some data that they will keep it within the company. But the learning part of it, I think, is probably available. And definitely, if you can, there are some data sets that are provided sometimes, which which are like it can't be identifiable and it's not something that they have a contract with the user. So there are some sets that are available to the company, and we can definitely talk more.
These data points more focus on the behavioral aspects of the student.
No, there were some not behavioral, mostly like a competency in the particular subject, very like whether they are able to do certain things or not. It was not about attitude or teamwork or things.
Yeah, data is gathered from the process directly, then human intervention comes.
Directly as in, so there was some human intervention, like the teacher had to put in, like, use a mobile to do the attendance. So there was some human intervention.
The reason why I asked is sometimes data quality suffers when human judgment comes into play.
Yeah.
So directly if you gather from the process, metrics come from the process, likely to be better.
Yeah, yes, I agree. So that's the reason why actually the competencies were there was no human intervention. Like the students clicked on certain things and the sheets were generated and the sheets were processed. So there was no human, but like the behavioral or certain of these aspects where the not behavioral, I should say, like are they coming to school? Because one of the things in government rural especially is like they won't even come to school, right? So that becomes.
Was there a data point on whether the teacher is coming to school?
The teacher was actually had to ask and was trying to put in all these data, so I was assuming no, we didn't have that, but yeah, but
That would have been an
yeah.
interesting.
So there was some
revelation.
of it because there were two kinds of things. One is where we had some not many, but some people would go and check, right, if the teachers entering data. So there were some points, not like.
My question is related to both of them, and I think my colleague Sanjeev may point it out. We work with an organization called XSTEP.
Okay.
And one of the challenges on the quality of the data is that many of these schools are in rural areas, right? So one is not only getting people to enter the data, but also they don't have access to enter the data. So how did you manage that quality?
So there was a team of people, like we call them as mentors. They're not, but they basically are in charge of like 30 schools or 40 schools. And they have a schedule that they go and visit every school. And we had that kind of, and some of them are even community based, like there would be women in that area or village who had like a degree, but because they are in that rural area, were not working, and so we kind of incentivize them to go check on these and get that data.
Involved in this entire initiative.
What is that?
How many people were involved in the initiative?
There was a lot. I think we had for this one initially when we started, we were at about 150 people. But these are including everybody, right? Like even the community people who are intervening.
Very impressive if it really succeeds.
So, sorry to interrupt. This will be the last question that ma'am will be taking. Out of the time. Yeah, thank you. You may continue.
I think if you are out of here, thank you so much. Thank you.
So much, ma'am, and it was indeed very knowledgeable session. Like you told that approaching system design, that how actually you focus like cricket models, and we really appreciate the initiative you are taking for this Shikshana Foundation, and I hope that it will go to a great level. Thank you.
Thank you. Now I would request. Now I would request Ruchita to hand over this.
Thanks, it was a great pleasure talking to all of you.
Thank you for coming.
Thank you.
So we'll hold our session for a few minutes for the break time, and we'll gather back here at 10:45 sharp. Sir, we will be seated. Lobby.
Store was
We can sort of look for tea, all those interested in some tea. So the entrance please.
Lot of things. He can guide you to where to get this.
No, she only said when I'm coming, she said invite them. She only said, but this way. When I'm coming, come Bill.
She said call them here inside.
She should clearly see. Call them. What should I do? Call them. I just found the phone.
ये होया 4 इसके बाद है 4 के बाद लंच है फिर 3 4 आधा घंटा एक इंसान का ना ये तो मीटिंग में जा रहा है आगे भी इसका मीटिंग 4 वाला प्लेसमेंट What is the package? 6.5% or 7? Not sure. 6.5. Okay. I'll come for 6. 6 or 8. No, it's a half high expectations. Oh, internship period. They're like, they first thing that is even reading. They are posting for that. We can also observe this. We just internship to observers. Background. Sciences, pretty average way.
Almost 80%. Only that sound because of it. Not this one. That door.
You guys
Everything is fine. Only people are entering and going. Not that noise is coming. Keep disturbing.
What are you wearing? He's very sorry, comedy piece you are. Like, गधे को हंसी गधे को सीधा बोल एक गधे पे ना ये आजा
Just sitting here to type. No, I don't know. Yes, it
Oh. Take a confirmation hat.
I mean, yeah, he said he'll join 5 minutes before the meeting.
What is the time of his speech?
Yeah.
Confirm हो गया ना?
But he'll join now, some college class.
He will join in 5 minutes right now.
Now,
Or
7:45. He is speaking at 10.
Yeah. Just say ready को भेजा था, he's ready. अभी join हो रहा है.
He'll join now, calling class.
Okay, he will join. I'll call him, yes, sir. He is ready to come, right?
Yeah.
Okay.
The break है ना? Resume में 11 o'clock है. 10:45.
We can log in. No need a password. Direct access to log in. You can see it here. You can talk here also. Right. Password to log in.
Very lengthy debate was also a lot of articles. A lot of their focus on,
No, actually, sir, see, you could take it. Luckily, I didn't have any.
Sit. Sit. Your esteemed guest is from Abhi Kakkar.
They finally got the link.
Hello, sir. How are you?
कुछ मिठाई बांट रहे हैं
I've been with this concept since I have an open team. They are also 30, 40 kilometers. It's not much to just this is new area that
Excuse me, everyone. Everyone, please settle down. We'll start in a while.
Hello everyone, welcome you all again. Text analysis is a process of using computer system to read and understand human written text for business insights. Text analysis software can independently classify, sort, and extract information from text to identify patterns, relationships, other actionable knowledge. Such knowledge on text analysis will be now shared by Dr. Sid Reddy sir, who is from Google, USA. Dr. Sid's primary interests are in conversational AI, NLP, and deep learning. He has served at Microsoft as a principal applied scientist and served as a chief science officer as Conversation Seeker. His research is featured in over 110 plus publications and submitted patents in AI, machine learning, deep learning, reinforcement learning, and etc. We heartily welcome you, sir. You may take over the session.
A very good morning to everyone. Am I audible?
Yes.
Yes.
So I'll just give like a quick tour of natural language processing or text analytics, text mining. They are all the same things. I'll start with some basic definitions of NLP, some basics of neural networks, the very beginning of NLP, which is how do you classify the text, and an example for classification, which is sentiment analysis. I'll get in a bit into part-of-speech tagging and parsing, which is the syntax of text. I'll then again take a detour to deep learning, get deeper into deep learning by explaining a bit about what convolutional neural networks are, and then get into language models using recurrent neural networks, and then talk about machine translation. And through machine translation, also introduce a bit about transformers and transfer learning. And then finally get into summarization and end with information extraction and information retrieval. So this is more like a packed lecture to just introduce you to the different concepts in natural language processing. So as I said, natural language processing involves a variety of tasks. Some of the tasks are question answering, machine translation, summarization, natural language inference, sentiment analysis, semantic role labeling, relation extraction, goal-directed dialogue, semantic parsing, common sense reasoning, language modeling, entity recognition, word sense disambiguation, part of speech tagging, phrase extraction, fact extraction. So if you read a typical natural language processing or text analytics conference such as ACL, Association of Computational Linguistics, is one of the premier venues for publication in text analytics. These are the different tasks that you would read about. But if you fundamentally look at what are the different problem structures, there are primarily 4 problem structures. One is language modeling, which is given what has been said so far, what is likely the next word. So you predict probability distribution over all words and vocabulary. The other problem structure is machine translation, which is given the source language and what was translated so far, what is the most likely next target language word. So in this case, you predict the probability distribution over all the words in the vocabulary again. The next 2 ones are a bit different. The third one is text classification. A sentiment analysis is a good example, which is, hey, given my text, what is the most likely class label? Over here, unlike the previous 2, you're predicting the probability distribution over all sentiment classes. So named entity recognition is given my text, what is the most likely label for each word or token? So in this case, you're predicting the probability distribution over the labels. So these are like 4 problem structures, but they can also translate to several other tasks. Other not so common problem structures are span detection, which is identifying the beginning and end of a span, text pair matching, which is when the 2 words or sentences are semantically similar, text meaning, which is to represent words in a semantic space, dialogue, which is input is a statement and output is a natural language response. Sentence parsing, where the input is a sequence of words and you generate a parse tree. So these are different problem structures. And for every NLP problem structure, there is a corresponding neural network. So those 2 things go hand in hand. So these days, NLP and deep learning are very intertwined with each other. So the different neural network architectures are multi-layered perceptron. That's the most basic one. When people say deep neural network, that's also multi-layered perceptron. And then there's a thing called deep averaging network, which is just like multi-layered perceptron, with the first layer being a bag of words. And then you have convolutional neural network that came from imaging, actually. So if in the early days in 2014, 2015 of deep learning, and even before that in the 1990s, for detecting handwriting and MNIST tasks, convolutional neural networks were used. They were all originally used in imaging, and they made their way into NLP. And after CNNs came recurrent neural networks. So the most famous recurrent neural network is LSTM. You also have gated recurrent unit, but LSTM, which stands for long short-term memory, was pretty popular until like 2016, 2017. And transformers really transformed, no pun intended, the field of NLP. Transformers themselves actually came after sequence to sequence encoder decoder. So the encoder decoder can be built using LSTMs also. And transformers, the idea is that, hey, you don't need LSTMs, you can just use attention. So attention is all you need. It's a seminal paper for that. And then you have other different networks that are more researchy, such as GANs, Generative Adversarial Network, and CMS networks. So now that you have a list of problems and tasks, NLP is about applying machine learning and linguistics and all sorts of algorithms and data. And just as a recap, the different types of problems, in green means they're relatively easy, orange means that's somewhat tough, and red means like really hard problems. So the different types of problems are, again, text classification or regression, text similarity, sequence labeling, information retrieval or information extraction, question answering, semantics, natural language inference, summarization, machine translation, and dialogue. So for these different kinds of problems, you basically apply the corresponding problem structure, and each problem structure has a corresponding neural network architecture. So just to give an example, for question answering, the idea is that you have the question and you have the answer as input to a neural network, and you're supposed to detect the span in the entire document that represents the answer. So I'm sorry, the question and the document that contains the answer is the input, and you need to find the answer, which is somewhere in between. So some good architectures for that are transformers or sequence labeling networks. Similarly, for machine translation, you start with a sequence and end with a sequence. So that's the problem structure for a machine translation. Machine translation is translating from English to French, for example. So you could do transformers or encoder decoder. Summarization, specifically speaking, abstract to summarization is also sequence to sequence. The input is a very long document and the output is a short summary of it. You can use transformers and encoder decoder. Natural language inference is like you have two text inputs. So you have statement 1 and statement 2, and you're supposed to say whether statement 2 follows statement 1 or contradicts or vice versa. So that's natural language inference. There are different networks for that. Sentiment analysis is a classification problem. You can use transformers or CNNs. Semantic role labeling is a sequence labeling problem. You can use LSTMs. Relation extraction is a classification problem. Various architectures apply. Goal-directed dialogue is sequence-to-sequence network. You can use encoder-decoder architectures. So when you're trying to solve this problem, solve any NLP problem, the main thing is to find data. So most tasks in the async have lots of data available, and the different data sources include labeled corpora, large corpora, news articles, social media, and then websites that you could see. So the canonical approach for NLP in general is to understand the problem structure, define the exact task, and then you decide on which model you would use, and then you basically apply machine learning. The various resources for NLP tasks, this nlpprogress.com. It's run by Sebastian Ruder from DeepMind. And then the NLP Decathlon project, Glue and Superglue, they're all pretty popular resources if you want to like keep track of what's going on. So let's just now, you have to kind of, I would beg your forgiveness to kind of like now switch to like a fast gear. I'll just introduce you to a range of terminology, and I'll go very fast because there's a lot to cover. This is something you typically cover over an entire graduate course. So If you're not familiar with deep learning at all, there's a good website called TensorFlow Playground that lets you understand some of the intuition behind deep learning. At the end of the day, deep learning is you have an affine transformation. So you have an input X, you multiply it with a weight, and you add a bias, and then you add non-linearities. It's like ReLU is a very popular nonlinear transformation. And then you do another affine transformation again. And at the end, you do either sigmoid or softmax. That's your multi-layer perceptron. And this is the another visualization of the same thing. So multi-layer perceptron is like something that can be used for many text classification tasks. It's pretty basic. You could use it for paraphrase detection, entailment, part-of-speech tagging, and parsing. So to make it work, you should convert the words into vectors. So in NLP, they've used a terminology called word embedding. So they're pretty much like semantic vector representations of the words. So what happens is every word gets an embedding. And if you want to use the deep neural network or multi-layer perceptron, what you do is you add up the embeddings and then you pass it through an affine transformation. So you basically send it through your deep neural network like that. So the different parameters that you need to understand to tune the neural network, those are all important. So that's just a gist of how to build a simple NLP system for classification or similar tasks. So and then you have syntax. So there's a popular system called Parsimate Parseways, and what it does is it does these are all your part-of-speech tags. So there are 15 universal dependencies. You can do your part-of-speech tagging, and then there's also parsing, which is deeper. So in addition to like token level labels, you can also just construct the whole dependency tree or constituency tree using different techniques, whether it's transition-based parsing or graph-based parsing or chart-based parsing. Many of you might be familiar with context-free grammars from your engineering, etc. So context-free grammars are related to parsing. So let's now take a detour again into deep neural networks. We discussed about NLP. The next level of complexity for deep neural networks is CNNs. CNNs were very popular with image classification, and you can also use CNNs for text classification. So essentially the idea is that you basically go through sliding windows of the text in multiple different ways and multiple different times, and that way you capture the local context well. So that's essentially the idea of CNNs. And then comes language models. There are different kinds of language models. You could build a simple neural language model using basic deep neural network. You can build them using recurrent neural networks. You can also make them context aware. That's when the Elmo paper came, and you can then add attention or transformers. That's where the BERT, OpenAI, GPT, GPT-2, GPT-3, and all the more recent language models came. You can also create sentence embeddings like sentence T5 or GTR. So this is Elmo. Elmo uses LSTM. It's a recurrent neural network-based language model. And then came BERT. BERT uses like the encoder part of the transformer, and GPT uses a decoder part of the transformer. So as you can see, BERT is bidirectional. So that's the B of the BERT. It's a bidirectional encoder representation. Whereas GPT, G stands for generative. So it's like autoregressive. You start with one word, generate the second word, and so on. That's the essence of the difference between BERT and GPT. And then comes transfer learning. So now you have these language models, which are trained on like trillions of data points. And how do you now fine tune the models for your specific task? So that's the jargon related to transfer learning. And transfer learning is like really what made the field very fast forward. And also can do sentence embedding similar to word embeddings. Universal sentence encoder is a really good example of that. So now let's go back to like, okay, now that we have learned about language models, like let's talk about machine translation a bit. So in the classic machine translation, the idea is that you transfer word by word, grammar rule by grammar rule, or like really go very deep into representing exactly what the source text means, and then get into target text, and then build some rules like blue, kind of see if you have done a good job. All of that is good. But what really changed the field is that around 2015 or so, the idea is that you can actually represent the whole source language as an LSTM sequence. And then you can actually represent the generation part as a decoder LSTM. And then came this idea that, okay, so all of that information is going into through this one arrow. So we probably could do a little bit of attention. And the whole idea is like also very much borrowed from this classical approaches. In the classical approaches, you do some kind of joint alignment. The whole idea of attention actually came with machine translation. And they started doing attention between the decoder cell and the encoder cells. So that's like the whole idea is to look back. And then they also do beam search to basically make sure that you don't do just greedy translation, but you have multiple options in your sleeve and you pick the best option possible. So that's how the machine translation evolved. And then came this seminal idea called attention is all you need, which is like, hey, why do I need two RNNs? Can't I just replace the RNNs, and can't every word in the input attend to every other word? And can't every word in the decoder attend at least to the words to the left? So that's how you got the encoder self-attention and the mass decoder self-attention. This is what changed the field. So I'm not going into the math and all the details, but that's really the attention mechanism got created as part of how do we translate machine, how do we solve machine translation efficiently. And from that came transfer learning. So, okay, I solved machine translation, that's cool, but how do you apply it for other tasks? There are different ways of approaching it: multitask learning, transfer learning, zero shot, few shot. The most popular approach is like GPT-3, which is few shot learning. That's a trend these days. It's called, you basically give a prompt and you can basically solve everything even without seeing anything. And on a practical level, we discussed pre-training and fine-tuning. Pre-training is you basically create a foundation model using language modeling or some task where you have a bunch of data. And then you do fine-tuning by adding a layer on the top and you perform your specific task. So that's fine-tuning. The BERT is like what really popularized fine-tuning. For about 2 years from when it was released, the whole NLP was about BERT. So using BERT, you can do pretty much all NLP tasks. So if you learn BERT, you pretty much learn all of NLP tasks. So as an example for classification, you feed a CLS label and you feed a single sentence with the different tokens. And the class label is at the very leftmost thing, and you basically add a feed-forward neural network to this, and you fine-tune just that feed-forward neural network, for example, to learn the classification labels. NER can be done in a similar way. Question answering can be done in a similar way. That's the same thing that is possible with BERT is also possible with GPT. It's not just BERT with BERT that you could do fine-tuning. And then came this, like I said, the GPT-3 paper, which basically said, okay, forget fine-tuning. I just give some examples on the spot and it will just give me very good results immediately. And then came T5. T5 is like, okay, this is a good, I want to create a good balance where you already have so much training data. So let's just create a good architecture for multitask learning. So you basically train the model at the same time for machine translation, for inference, for sentiment analysis, and for summarizations. Basically, all the NLP tasks you train at one go, and the single model can pretty much do everything. So that's the idea of T5. And there's this company called Hugging Face that you could check out, huggingface.co. They made it quite easy to get into transformers and so NLP. So just to kind of wrap up, information extraction is like one of the downstream tasks. It includes named entity recognition, co-reference resolution, entity linking, and relation extraction. So this is more like the bread and butter of text extraction or text retrieval, or like text mining or text analytics. So you could use all the technologies that we discussed to do these things. So that way you're basically converting all your unstructured data into structured data. So that way you can then do your analysis. So again, it's actually BERT made things quite easy. You can just do information extraction using BERT or like similar transformer models. The same thing with co-reference resolution, BERT, just to kind of prove that you can actually do everything with BERT. So with extracting relationships also, like different approaches, a rule-based approach, supervised approach, semi-supervised approach, unsupervised approach. So we can also do this using transformer technology. Summarization, it's either abstractive or extractive. So abstractive summarization is like the system basically generates things entirely on your own. Extractive summarization is where the system actually extracts key named entities and relationships and synthesizes the text together. So I'm kind of wrapping up quickly and skipping some slides, but there are some popular systems like Pegasus that's like very focused on summarization that you can check out, but you can also do it using T5, like I said before. And question answering is just a special case of summarization. So summarization with respect to query. So summarization is like, given all the documents, provide me a summary. Question answering is, given all the documents, I have this question. And so based on the documents and question, give me an answer. The different variants of question answering, I'll probably not go in detail. The span annotation is the most popular one. And again, that could be solved using BERT. There's retrieval-based question answering, and there's a lot of data sets. And finally, there is information retrieval. That's more traditional, but you can also do information retrieval using transformer networks. Anyways, I hope I at least was able to give you some flavor of what text analytics is, at least for those who have not heard about this before. Thank you so much for the opportunity to just introduce you to text analytics and NLP. I'm not sure if I haven't attended the previous things. I don't know if this is it, and it's goodbye, or if there are any questions, happy to answer.
There are some questions. I have a question.
Sure.
One or two questions we can
Only one.
Yes.
Only one. See, different people articulate their needs in different way. Is NLP mature enough to grasp what one is seeking? And in case there is any doubt, would it get into dialoguing mode to resolve it?
It is a hard problem. NLP is easy for things like text classification, sentiment analysis. So it's like very good with, hey, this person means something positive, this person means something negative. But to really get into dialogue, like I said, red is hard. I mean, you can, the way to go about that is like implement it for like a very specific domain. Like say, you can implement it for food ordering. You can implement it for Uber. You can implement it for sales. You can implement it for customer service. But you can't have like a generic assistant that just understands everything. That technology isn't there yet.
Sid, paraphrasing would fall under what? Which type of algo?
So
is that an easy problem, or I mean, is it a medium or hard problem?
Paraphrasing, if you're just looking for paraphrasing in itself, it's relatively easy. It uses the same architecture as machine translation, but paraphrasing is simpler compared to like translating from English to French, just translating from English to another language. Having said that, if the goal is to generate all possible paraphrases, in English language, so that you can just do data augmentation, that you can then do, that you can then use it for training data, that is difficult. So if you just want one or two paraphrases, so that way, like you just don't want to copy paste and like just rephrase it, that's relatively easy. But if you want to generate all possible paraphrases, that's like super tough.
Just a simple follow-up question. If we give keywords and want to have a, let's say, an abstract generated pertaining to that particular context of the topic, how easy is that?
It really depends on the domain. To some extent, we showed that there is papers on like really large language models, like on Lambda and GPT-3. You actually give some keywords and it starts generating a story. There's a whole field called creative writing. So the problem with that is it sometimes generates like very good text, and it's sometimes not so good. So you have to ask it to regenerate or give different keywords or write some part of it yourself and then ask it to complete it. So that technology is already there. There are some companies who are already doing creative writing.
Thank you so much, sir, for detailing us about NLP. And we also got to know about architecture as well as resources, implementation process, language models, and etc. So thank you so much, sir. Moving forward, data analytics can help farmers monitor the health of crops in real time, create predictive analytics related to future yields, and help farmers make resources management decisions based on proven trends. More insights on analytics in agriculture will be now shared by Joachim Wickler from Arable Labs, USA. Joachim has created groundbreaking technology solutions for 25 plus years and built global organization to accelerate the development and global delivery of software, hardware, and solutions to worldwide customers. We welcome you, sir.
Hey, can you hear me?
Yeah.
Yes. Excellent. Well, thank you so much for having me here today. I am CTO of Arable Labs. We are trying to help farmers make better use of resources and create better yields for them. And what I wanted to talk about today is, how we use data, how we use analysis and machine learning to create a better solution, lower cost, easier to use, and better information for the farmers. See if I can share my screen here. Put this here in presentation mode. Right, seems to be working. Can you see?
Yes.
Perfect. So what are we doing, right? What is farmers doing? the most important things for them is, you need water for something to grow. You need sort of nutrients, so fertilizer is really important. And you need to fight diseases, thus the use of pesticides. And what Arable really trying to do is to see how we can help farmers use less of all three of these things while still maintaining the same yield, right? So why is this important? Why care? Well, 70% of the world water is used by agriculture. And many parts of the world, for instance, here in California, where I'm living, we have a lack of water. So many farmers here in California can't use all of their land because they don't have enough water. So if they can reduce the water usage, they can use more of their land, of course, will increase how much money they can earn. Fertilizer and pesticides are both expensive for farmers to buy, and in general, it's not a good thing to use for the environment. So if we can reduce the use of fertilizers and reduce the use of pesticides and receive the same results, it's a good thing as well. So that sort of was the goal for Arable. How can we achieve and do this? The first step is to use data. We need some sort of data that we can analyze, use to make that happen. So how do we get data? Well, we have a field, so we need to build something that we can have in the field to collect data. So we build this contraption, and we call the MARC, which is basically a sensor array. It measures, weather, so it measures rainfall and it measures wind and pressure and humidity, as you can expect. But it also has a huge amount of spectral data. Turns out, if you look at agricultural research, what has been done, that if you can measure sort of the light coming in or coming down on the crop, and you measure the reflective lights coming back, and you can compare it to, you can learn a lot about the health and status of the crop. So that's what we're doing, right? We're measuring these things, and so that's sort of our main data input. Some of these measurements are hard to do. So when we sort of set out to do it, the idea we had is, hey, let's use the latest sensor technology. Let's try to make this as cost efficient as possible. And we already had, the thought that we should use machine learning to extract more advanced measurements for our customers. But what happened was, when we did this, we realized that we can use machine learning much earlier. It turns out that, take one thing, take measuring air temperature, which this is an example of, right? Why is that hard? Why is it hard to measure air temperature? Well, if you have a temperature sensors out in the field, that temperature sensor will absorb the radiation from the sun, and it will get hot, much hotter than the air. So now you're measuring not the air temperature, but you're measuring the temperature of the temperature sensor, which is not useful. The traditional way of stopping this is what you can see to the right side here. You build a radiation shield. That radiation shield is there to reflect the light away. And then you put in the middle of that radiation shield, you put the temperature sensor. Some of the more advanced radiation shield also have a fan that blows air continuously over the temperature sensor to make this better. This device is typically something like 50 centimeters tall and 25 centimeters wide. So pretty big device that sort of sits independently, as you can see here. So what did we do instead? The sort of radiation shield that we have is probably 5 centimeters tall and 2.5 centimeters wide, so significantly smaller. Yet, as I will show you later, we actually achieve better results. So what's interesting here is and how do we do that? Well, we are actually using all the data we have. So we know, how much sunlight is coming down because we're measuring it. We know what time of day it is. We know what location we're in because we have a GPS in our device. All that together, and we also know the compass direction of the device. We can calculate where the sun is. Put all the data together, we can figure out how much the radiation from the sun probably is absorbed by our radiation shield, and we can get a great result. And we can do it we get actually better accuracy on our solution on the right side. It's smaller, it's lower cost and less power. So we concluded we can actually use this to lower costs, get better accuracy already for basic measurements. And we continue to do this for air temperature. We do it for canopy temperature, which is, how hot is the crop, which is an important parameter when you want to understand the health and what's happening with the crop. Evapotranspiration, we'll talk more about that later, but it's fundamentally also very important thing. It's basically the plants are sweating, right? So the water that plants are using, most of it comes from the plant sweating. When it's hot, the plants sweat that humans do to lower its temperature. So you somehow can figure out how much it sweats. You also understand how much water is being used. And that's important to understand, if you want to do irrigation or other things to understand how you better can treat your plants, right? So we figured out then how to use machine learning to improve our measurement accuracy. But to do that, of course, we need to have data. So we set out to design what we call a calibration and validation network. So we have a network spread in 5 continents around the world. I think we have 52, 53 sites around the world at the moment. What we basically have done is through our own investments, insights, or we partner with others, we have mark devices out, and co-located with these mark devices are a very expensive reference instrument that measures all these things we want to measure. That way we can continuously collect data as we do it in many places around the world. We get a good input to training models, right? So not only you have different geographical areas that might be different, but also, the whole world is classified by agronomists in agroclimate zones, and we are in the majority of the ones where they actually are something growing. So we make sure we are in all the different zones and in all the important agricultural markets of the world. So is it working? Well, here is one example of data, right? So what this shows is basically we took our device, we took other devices that are commercially available and compared, right? And we compare that to very expensive reference instruments that are in the cost range of $15,000 to $20,000 each to sort of have as a reference data for see what's good. And as you can see, the Mark II is doing well, right? They are doing better than the peer devices, right? Even if the Mark is about half the price of the other devices, and even though the Mark actually do more things like the spectral data for evapotranspiration that the other don't do. So we set out with this goal to make it possible to use data, use machine learning to create something that was cheaper for our customers, that was easier to use and had higher accuracy, right? And I think at least for rain, for precipitation, this is an example of it actually worked. Temperature. We talked about how hard it is to measure temperature. So here is real data from, this is actually a couple of years old, but I still think it's interesting. So when we started out, we needed to create the initial data set, and we built the first model, that we really used commercially when we had about 300,000 data points, which is what I call the old model here. And you can see, the values here is basically showing the average error in temperature measurements. And the new model is about twice that, about 600,000 data points, and you can see so much better. That was another theory we have. And hey, it's obvious probably to you guys that more data give better results, right? But here's a clear examples of it, that, getting more data give us much better result in real life. And how good is this? How good is this result compared to sort of the other device I showed you, the traditional shield? Well, the old model are in line with the shield without having a fan that blows air all the time. And the new model is about the same as one that blows air over all the time, right? So we are able to do something that is very, very accurate, comparably so to something that's much more expensive. And of course, we can continue to improve this. What we have done to sort of continuously take advantage of this is we build a pipeline where, as we continuously collect more data, makes it very easy to retrain the models. So we continuously can get improvements. You know, we can update our models continuously, add that into our environment, and our customers can take advantage of it. And our customer likes it, right? Customer likes the fact that they buy a product that has one specification, and over time it actually gets better, more useful for them, without them having to pay any more money and changing any hardware. It's become a very powerful model for us. I talked about ET, evapotranspiration, something that's very hard to measure. The way you measure it is with rather big and expensive measurement devices. They normally cost something in the range of $50,000 to $100,000. And they're hard to, because they're big and heavy, they're hard to set up, right? So we have done the same thing there. We have worked with a bunch of research institutes that has these expensive devices out. We have put marks alongside with them and collected data. And now we have a system that actually, you know, it's not matching perfectly, as you can see, but pretty good. Something here that makes us make this work as, you know, again, much lower cost, higher accuracy, and easier for our farmers to use practically than before. So this methodology of using modern sensors, using machine learning both to improve the simple data like temperature, as well as, you know, finding more complex information like this evapotranspiration I have here, works well. I talked much, and I saw the previous speaker was talking a lot about models. So you know, what are we actually using in terms of machine learning here? So we're using a lot of tree-based model like random forest or gradient boost and other things. Turns out when you use time series data compare, that is pretty useful for us, right? So that's been a lot of the model we have used for temperature and even for rain. By the way, I didn't talk about how rain works. The way rain works is that the top of the mark works as a drum, and we're recording audio from that drum, and we're using that audio signal with the machine learning model to figure out how much it rains. Again, there's no moving parts, nothing that can break. It's a pretty simple way of doing it, but using machine learning, it becomes very accurate. We're also starting to use some more, you know, more deep learning, you know, neural network type models to kind of push further to find more complex relationships. Because that's what we want to do. We want to continue here on the base we have built and go to more and more advanced data, going into predictive analytics. It's great that we can report what's happening and give accurate data, which will help our customers to take actions. But what they really want, of course, is to know what's going to happen. A great example is growth stages. So plants go through 15 to 25 growth stages, you know, as it sort of goes from coming up from the ground until it's time to harvest. And depending on growth stages, you're supposed to do different things. You're supposed to fertilize at some growth stages. You're supposed to maybe plants are more susceptible to diseases, so maybe spraying is better for some growth stages, et cetera, et cetera, et cetera. So of course, if you know when it happens, it's great, but it's even better if you know before it happens, so you can take corrective action and plan it from a real operational point of view, how to do this earlier, right? So that's something we're starting to do as well. The traditional way of calculating growth stages, sort of predicting, is just using the temperature. And for every crop, there's a temperature span. and depending on temperature, it goes faster or slower. So you can use that sort of as a good rule of thumb, and that's sort of the traditional way it's being used. But what we have found now by using more of this data and having a much more complex model, how much sunshine versus how much, even if it's warm, is it direct sunshine or is it overcast? How much humidity you have, what other things are happening around, also impacts this. And that's another way we're starting to create a much better predictive model than what has been done before. So rather than, having an accuracy or maybe plus minus a week for growth stages, I think we can cut it down to plus minus a couple of days, which significantly increase what our customers can do. So that's the next stage, more advanced models, more advanced system to move forward sort of in this endeavor to help our customers to do better. What have I learned doing this? I've done a lot of data-based solutions before collecting data, but I've never really worked with agriculture other than the last 4 years when I worked with Arable. So one thing that I think is interesting is, when you build machine learning models of something that represents physical or biological events, it's kind of important to understand what's happening. Yes, you can build machine learning models if you have lots and lots of data. You can build them anyway, and eventually it will work. But one learning here is that if you really understand it, you can do much better feature design, and you can get much better result earlier. So that's why Arable has both agronomists and metrologists on staff, because they can help us understand this better and help us build better features. That helps us immensely to get better results faster with less data. So important to understand what it is you're doing and what you try to model. The previous speaker said the same thing. It's all about the data, right? You need to have data. Sometimes it's easy to get data because there might be a lot available already. In my case, it's not, right? So that's why we went through all this work of creating the sensor array, creating the Calval network to make sure we have good data to do this. So really important, whatever you're doing, make sure you have the data and make sure you have good quality data. So my experience in general of doing machine learning analytics is that, good quality data might be the hardest part of the whole project. Yes, it's more exciting to build the models. It's more exciting to see the result of that. But at the end of the day, if you don't have the data, it will not work. So getting good quality data is really important. And then continuous improvements. And of course, it's kind of obvious, okay? It's kind of obvious that if you have more data, it will be better. And if you work with this kind of stuff, it's kind of, yeah, whatever. But I think that taking advantage of that from a product point of view, and by that I mean build a system that sort of makes it easy to take advantage of this. Don't make it a big deal to retrain a model and put it out as a product, right? Build it so it can be done pretty easily. You do it continuously. You continuously feed your customer a better solution than before. And that is positive both for them and for your reputation as a product. So that's something to think about that and do it. And the last thing I think is, what else can you have? So you have a data set, you have build models, that's great. But if you would add another sensor, can you do much better? And if so, what sensor would that be? All right. We already have a number of sensors, but what can we add to do this better? Right. There's always something more you can do, something better. And you see, I call this one Mark III. Mark I was a small prototype we did. Mark II has been out for quite some time, and Mark III is an improvement there. So we're trying to do exactly that, add more sensors based on our experience. Something that's very exciting from that point of view is the camera. We decided that adding a camera and adding the ability to do image recognition, image analysis on the edge was important. So the new device has a camera, and it has the ability to do machine learning or image recognition on the edge. So we're starting to sort of explore that and see what we can do. And I think there's many things we can do to this new data source combined with all other data we have. There's lots of new things we can do. So that gives us exciting new opportunities to continue to build here. So summary then, yes, we can use machine learning to design more accurate and lower cost measurement devices, right? I've shown that here for precipitation, for air temperature, for other things. It works well. We can achieve higher accuracy and lower cost, simplicity of use, which is great. Data is really important. If you don't have the right data, this will not work. That's why we build our data collection network. And the last question, does it work? I mean, the customer doesn't really care about my air temperature. They doesn't really care maybe about, my data collection. Yes, we have worked with customers and we have shown and realized with many customers 40% reduction in water use, 20% reduction in use of pesticides, and 20% reduction in use of fertilizers, right? So yes, this works, and we have proof that it works. Any questions? I think I'll run out of time here, but if there are any questions, I'm more than happy to try to answer.
Walking, I have just one question here. Your last slide shows you monitor the disease of the plant. Do you do that using multispectral images, satellite gathered, and also drones, from drones and satellites? How do you gather data?
No, we don't. In our current product, we use multispectral, but not images. Currently, a multispectral camera is rather expensive. So we have multispectral sensors. So we have 25 or 22 band sensors in our device. So we can measure reflectance in 22 bands. And that's good enough for us to detect some of these things you're talking about. So it actually does work interesting enough, right? At some point, and what you're pointing out is good, I've been looking at it, and I hope at some point technology will advance so we can get the cost-efficient multispectral camera too that will do this even better. We have also been working, we have looked into drones, we have looked into satellite vendors, and we actually have a close cooperation with one of the bigger satellite imaging companies in the world. They work with us for two reasons, really. One reason is we want to see if we can use them and integrate this as data source, as you're alluding to. We haven't done that yet, but we're working on that. The other one is they have a challenge. If you take images, multispectral or as normal images from space, it's very hard to compare one day to another. The problem is that you don't know what it is in the way, how much humidity, how much dust is it in the atmosphere. You take the image. So it's hard to get sort of close cooperation. What we are doing with these companies, as we know where we are through the GPS, and we measure the same spectral bands that they do, we can calibrate their images. So we can make the comparison from day to day and actually increase the value of the imaging, right? And that's something we're working on. We haven't made a product out of it yet, but something that is on the roadmap for sure. So that was a very insightful question, by the way. Thank you.
Is it a part of your, as part of your offering, identifying the peak potency of the crop?
Say again, identifying the
peak potency of the crop. Is it a part of a solution?
Is it
that is to say, for example, let's say you are growing, I don't know what is that, maybe corn or let's say mango, or so
yeah.
What is the right time to harvest?
Yes, I think that we're trying to predict when it's time to harvest, right? And why do that? And what's happening in farming around the world today is becomes a big business. There are fewer and fewer people and more machines. So being able to predict when something is happening is important for a specific field, because they have to schedule machines, have to schedule labor. And in the field today, it might not be anyone, might be go a week and no one is actually physically in the field, right? So yes, we're trying to do that as well, right? We're trying to figure out, that's why these growth stages I'm talking about is so important, because that kind of dictate a lot how farmers need to manage the field and how they have to plan, right? So growth state becomes really important because of that, right? But in general, I think the point here is that if we can determine the stage, what is the city, basically, are the crop healthy? Does it have enough water? Does it have enough fertilizer? Is there risk for disease, or maybe disease has already happened, right? But again, disease is a great example. If you already had a disease attack, spraying might not help. It's much more powerful if we can predict when disease might happen, right? That's part of the reason I'm so excited about the camera, because I will get a unique data set. I will get a data set that shows me when disease happens through my images. And then I have all the data before that happens, right? Which will allow me, hopefully, to build a powerful machine learning model that better can predict under what conditions the risk for disease sort of increases. So we can use tools like spraying or other things at the right point in time to stop this. This is also how we can sort of convince farmers to spray less. Because right now, many farmers, they just spray on a cycle. They just do, they have no idea if it's high risk or they just spray out of almost like an insurance. If we can show them that we know when risk is high and when it's low, you can reduce the number of sprays. You use the use of pesticide, and still, the risk for the farmers is low.
Right?
Yes.
Yeah. See, we live in a country where the size of farm holdings are very, very small compared to what they are in the United States. Now, how would we have an effective, cost-effective machine learning model here?
So I think there are models around this. I'm aware of China, or sorry, that India is different in this way, right? And one model that's starting to develop is that a village, for instance, comes together, either get sponsored of someone or themselves can invest. So many farmers can use the information together. The way we spread the information is that, you get the information. I didn't talk about it here. They have a mobile app, both for Android and iOS. There's a web app. And if you're a more advanced customer, you can pull the data over an API and do your own presentation of it. But the mobile app and phone app, so for instance, if a village would have this data, we could present, and many users can use their mobile phone app to look at the same data, right? There's a way to use this thing together for many farmers in a practical way. We are working on a project together with a partner, trying to set up a couple of thousand of these devices in India based on this idea that many farmers can use it. And that would make the investment manageable for each farmer. But I know that India is special when it comes to sort of how farmland is managed. And as you point out, there are many small farmers compared to many other places in the world. But that's one way we can help, I think, and one way we're trying to help. We're doing that too. We're trying to work with India. We have a big project with the World Bank where we are actually working with Africa in a similar model, right? Where the World Bank is sponsoring the initiative, and we're setting up these devices in villages so that many villages can use it, the farmers in there, to help them get better information. So that's also another initiative we have been working with the World Bank of doing. So another great question. So thank you. Thank you.
Thank you so much, sir, for detailing us about reducing usage of water, fertilizers, and pesticides, and giving us more insights about complete crop intelligence from using a machine learning. We heartily thank you, sir.
Thank you so much for having me. I appreciate it. Thank you, guys.
Modern recommender system, a deep dive into AI algorithm that companies like Facebook and Google have built their business around. More information on such modern recommender system now will be shared by Dr. Sarabjot Singh Anand, who is a co-founder and chief data scientist at Tatras Data India. Dr. Sarabjot is a founder and chief data scientist at Tatras Data. He has been involved in the field of data mining since the early of 1990s and has developed algorithms applying them to real-world problems and training a host of data analysts in the capacity of being an academic and data analytic consultant. I welcome you, sir, and request you to take over the session.
Thank you very much for the introduction and the invite to be part of this wonderful program today. I hope I'm audible.
Yes.
I'm going to talk about recommender systems. This is a technology that is very dear to my heart and I've been very lucky to be involved with the very early days of recommender systems since the late 1990s. And the basic idea behind these recommender systems is the fact that essentially we live in a world of plenty in some ways for those who can afford it. So we have access to more options than we've ever had, whether it is for consuming content online or purchasing even a dress or a shirt. There are so many options out there that it is impossible for us to manually consume all the options and make a choice of what would be best fit for our requirements. And so back in the mid 1990s, people had started thinking about, we do have a lot of information retrieval type work happening, which is a search through large complex corpora. Can we come up with an alternative where rather than having to search by generating queries, can we actually filter items so that those items that are interesting to us can be presented to us without us necessarily having to explicitly ask for it? So from a problem statement, the idea here is that we have a lot of items that can be consumed. We have a very small interface through which we are accessing these items. And that interface tends to become smaller and smaller, in terms of the fact that we are using mobile devices now to consume a lot of the content that we do. And so, people try to look at algorithms that could be developed to solve this particular problem. And when we think about recommender systems, typically we think of two types of recommender systems. There's content-based filtering, where we track what the user consumes, and based on their own individual consumption patterns, we recommend items that are very similar. And one of the problems with these kinds of recommender systems is that they have a very narrow vision. If I consume a particular kind of content, say in cricket, given that we are a cricket crazy nation, the assumption made by these recommender systems is that that's all that we are interested in. So there is no diversity within the recommendations that are being presented. And to try to solve this problem, back in 1994, an algorithm was developed by a group based out of the University of Minnesota. Professor John Riddle was the head of that group, for recommending based on what we could think of as being wisdom of the crowd. So the idea here is that you have a user that has to be recommended to. That user is known as the active user. And we track what this user has consumed and identify out of all of the other users on the system, those users that have similar consumption patterns, right? So we might identify these 3 users here in our overall group of users that have very similar consumption patterns as this user that I had said is the active user that we want to make recommendations for. And we recommend to this active user items that have been consumed by these folks here that have not currently been consumed already by the active user. Now, the advantage of these kinds of collaborative filtering mechanisms is the fact that you don't depend on any item descriptions, and we'll look at how they work in a minute. But also the fact that there's diversity in the recommendations that are being made. And typically when we get into the industry and try and build these recommender systems, we build what are called hybrid recommender systems that consume content descriptions of items, but also use some form of collaboration within the recommendation process. So from a mathematical perspective, recommender systems are like any other machine learning algorithm. You have data, and the data is actually rather simple. When we think about collaborative filtering, we have a user ID, we have certain items that they have consumed, and that user is assumed to either implicitly or explicitly rate those items. And what we are trying to do from that, again, just as we do in all machine learning, is to learn an approximation, a function that given a user and item pair, we are trying to predict a numeric value, which is our predicted rating for that item by this user. And of course, the third cornerstone of any machine learning is to have a cost function that measures as to how accurate that current set of parameters is that has been learned by the machine learning algorithm. And that cost function, because this is really a regression problem, the obvious one for us to use, and which was the original kind of thought process within recommender systems, is to use the mean squared error. So look at what is the difference between the actual rating given by a user and the predicted rating that is predicted by this function that we have learned. So that's kind of setting the tone of what is the problem and how does it translate into a machine learning problem. Now, of course, it's a regression problem, and we have essentially two categorical input variables. So the obvious way that we could think of solving this problem is to do a one-hot encoding of both the user and the item, and to have this as our output variable that we are looking to predict. Now we have the data in a form that we can actually do linear regression with, right? So we could learn a function using standard linear regression. And what we would end up with is one parameter here, which we could think of as an average rating that any user gives to any item. And then we have a component that is contributing to the rating that takes into account who the user is. So we can think of that as a user bias. So if a user is typically a very lenient rater, we would actually add a positive value to the average. And then we would have another component which we could call an item bias that essentially would add some components to the rating based on the item that is being recommended. Right? Now, the problem, of course, with this model is the fact that it completely ignores a lot of underlying factors that drive the recommendations, right? So preferences that a person may have for the items that they're consuming. So if you take the domain, which was the original domain in recommender systems of movie recommendation, this user here may have preferences with regard to special effects or a production house, a particular genre, or indeed a particular actor. And given all of these preferences, we are producing, this user here is producing a set of ratings that are biased in some way by these preferences. Now, what makes life even more interesting is the fact that unknown to the recommender system, we may have a set of contexts within which these movies are being consumed. And so you add a couple of children to this same user UK, and suddenly the preferences have changed to animation and Disney and action heroes and comedy. And all of that is kind of latent or hidden data that is not available to us explicitly, right? So while we may look at data which looks like this, and we often refer to that as the user item rating matrix, where for every item that has been rated by a user, we have the rating at the cross section of the row and column associated with the item and the user. And this matrix itself, by its very nature, is going to be very sparse because you have lots, tens of thousands of items that can be consumed, and any user, no matter how avid a consumer of items they might be, has only rated a very small number of items, right? So we've got to deal with the sparsity within the recommendation algorithm that has been created. Now, at a very simple level, the first algorithm that was developed by the group length folks did a very simple thing, right? So it took the vector that represents the user, which is this whole row here, and it took that to be an m-dimensional, right? So if m is the number of items, it took that whole set of ratings that may have been given. Most of them are 0, if you remember. And it uses that as a user profile, and it looks for other users by a simple metric that can allow us to compare two vectors. And once it's found similar users, then what it does is it comes up with a predicted rating by taking an average, a weighted average of the ratings that have been given to items that have not been consumed by this active user. Now, after they developed this mechanism of what is called user-based collaborative filtering, what they realized is they can invert the problem and say, if I want to predict this rating here, rather than looking at the user and picking the most similar users to this user and use that in making our prediction, instead we could take the target item that we are hoping to predict, and we can find, define the item instead now as a vector of ratings given across the user base. And so we have now an n-dimensional vector representing the item, and we can find similar items and follow the same process, then look at the ratings that have been given by this active user to these items and compute this rating here as the weighted average of the ratings that have been provided to these similar items instead. And for a long time, this was the basic methodology that was used in recommender systems. So hopefully that has set the context of what is the first approach and why linear regression seemed to fail the basic test, right, that we needed of being able to take into account preferences of a user, albeit those preferences being latent within the data itself. Now, one of the big problems with collaborative filtering that was well understood in research early on was the fact that we have what is called a cold start problem. We can only recommend items that have been consumed by somebody. And from a retailer's perspective, their whole lifeblood is to introduce new items. And so if you introduce a new item, you can't recommend it because nobody has consumed it. And so one way that we would think of, not as researchers, but more as people who are implementing recommender systems within the real world, is to measure the goodness of a recommender system based on the item latency. And what we mean by that is the time between the item being added to the item catalog and the first time that it actually gets recommended to a user. And we want to reduce that, right? Because new items that are being introduced should actually start to get recommended because we want to attract users to consume this new item that we've made available. Also, of course, one big problem is that with the sparsity of ratings that is available within the recommender system data set, when we look to use those very high dimensional vectors that are primarily filled with zeros or missing values, calculating similarity either at an item level or a user level is actually prone to error because we have very little overlap in the data in the items that are consumed by a user or the users that consume the item. And other than that, there are other issues too, right? And one of the issues there is that it treats all items as equal, even though there are certain items, for example, in the movie domain, maybe Spider-Man, that has to be loved by everyone. There's almost kind of pressure on you as an individual to say, oh, I love Spider-Man, right? And so the information content of individual items is actually limited. So what transpired was that a new algorithmic approach was developed, which was based around matrix factorization, where essentially the idea is that if you have your item rating matrix like is provided here, and you can see there are a lot of missing values, and in a way we can think of the whole recommendation process as being one of predicting what are these missing values out here, right? And so the idea was that if we can think of this item, user item rating matrix as being a product of two matrices, one that consisted of all the users, like Tim and Tom and Peter, and the other that is representing all of the items. And the columns here are actually what are the latent preferences, right? And so if magically we can actually firstly determine how many preferences there are across users, and we can associate values with each of these preferences. So here I'm showing an example where we only have two preferences, and we basically want to know how important is preference H1 to Tim and how important is preference H2 to Tim. And similarly, for the items, we want to look at how good is an item at being able to satiate somebody that has a high preference of H1 or H2, right? So how well does it fulfill somebody that actually has these preferences? So the idea here is that these are our unknowns, these are our parameters of our model, and from a machine learning perspective, somehow magically we want to fill these values in. And if we can do that magic and generate numbers in here, then by essentially multiplying these two matrices, right? So if we call this the matrix P and this the matrix Q, we have an M by 2 matrix here and we have an N by 2 matrix. So if we take the transpose of that and we then multiply these two matrices, magically we get our recreation of the user item matrix, and each of these missing values are now filled in. So the matrix is not sparse anymore, right? And these are our predicted rating values that have emerged out of our latent variable model, which is being developed using matrix factorization. And from, again, a machine learning perspective, essentially what we have here is, we've modeled our rating, user item rating matrix as the product of two matrices. The number of hidden variables or latent preferences is a hyperparameter that we have to choose. We're still using a cost function, which is based around mean squared error. And the rating, the predicted rating is now the dot product of two vectors, one of which is the user preference vector, and the other is an item preference vector, right? And because this is a, well set up as a machine learning problem, essentially the parameters being the values in P and Q, we can use standard algorithms for optimization and learn these. Now, interestingly, as a mathematician, you may want to think about the same problem in a different way. So you might want to think of it as a bipartite graph, where you have nodes that are users and nodes that are items. And those items that have been weighted by a user can actually have an edge between the user node and the item node, and the rating can actually be a weight associated with these. And the nice thing about representing stuff as a graph is that there are well-researched algorithms out there based on random walks, where you can now say, okay, if I want to recommend something for a user, I can move randomly along edges that exist in this graph. And I can transition from user 1 to an item 1, and then transition to user 3. And maybe user 3 has an edge to item 5, where I transition to item 5, and I can recommend item 5 now, if that's a destination that I end up visiting very often in these random walks, right? And Google's algorithm, PageRank, could actually be used to actually make recommendations instead as well. But this is on an aside, to carry on with the story. So what we are saying now is that in an ideal model for predicting ratings, we already in linear regression had these three components. We had the average rating that we then biased based on which item we were looking to rate and which user was going to be consuming that item. So these three components were already there in linear regression, but what we said was there was a missing piece to our model, which was the bias created by the interaction between the user and the item. And so if there is a way that we can actually make this prediction of this bias, then we have a more complete model, right? So what we are saying is that, say the average rating in our database for any movie by any user was a 3.4, then if we were doing a recommendation for Star Wars, and everybody loves Star Wars, so it has a positive impact on the rating. And if the user that we are recommending to is Derek, that is a harsh rater, so it is going to actually get a negative impact on the rating, we can actually add these up and add in a bias now, which is based on Derek's preference for movies like Star Wars. And we already know how to make this prediction now using matrix factorization, right? And so now what we are doing here is we are tweaking our cost function essentially, And we are saying that our prediction now is a mixture of all of these components, the mean and the biases for the user and item. And now using matrix factorization, we are also adding into this the interaction bias, right? And this piece here, I won't go into in great detail, but this is basically a regularization term that is used very often in machine learning to ensure that we don't overfit when we are learning the parameters. And what we are using here is essentially gradient descent, which would be used in most neural networks as well. And so coming back to that whole user item rating matrix, we're basically saying that we are adding in now into our data these interaction terms, right? And we are now wanting to predict this rating still, but based on these interaction terms as well. But what we have done is something interesting. What we have done here is to say that our coefficients that we have in linear regression, we are actually factorizing those, right? And so we now have out here, interestingly, a product of parameters within this model. So it's not a linear model anymore, which of course causes problems from an optimization perspective, but it gives a better model. And that's very often what we as machine learning folks in the industry are trying to do, is to balance out complexity of the model that we are trying to build and ensuring that the cost function is such that we can get to a more optimal solution despite having a more complex non-linear function that we are trying to optimize. And so a number of approaches have been proposed. One is what is called stochastic gradient descent, where you are essentially adding some noise to your choice of direction in which you're optimizing. And the other is where your alternative is to use something called the alternating least squares, where we try and almost factorize the search in the search space that we are optimizing the parameters in by fixing the P vectors and then fixing the Q vectors at different times and creating a pseudo convex function that we optimize. Okay, and so people have worked, and because of paucity of time, I'm not going to go into details on these, but people have worked on how we can reduce the number of parameters further, especially in scenarios in the real world like Netflix, where we have a very large number of items that is being consumed and an ever increasing number of users that are adding to these systems, right? But I won't go into this for now. I'll move on to some of the applications that we use all of this kind of mathematical constructs that I've been discussing up until now. And so what we did here was one of our first recommender systems in India was to build a news recommender. And out here, it's obvious that we can't just use a content-based filtering approach because we'll get holed into one area. From a collaborative filtering perspective, well, because we have the problem with the poll start where there's going to be lots of news that is being released. How do we actually recommend news stories that are being released, which is the lifeblood of a news paper? What we did here was to take the philosophy of collaborative filtering and incorporate that with content-based filtering approaches and make recommendations, right? So the content-based filtering approach was not going to work here, as I said, because we want to widen the horizons, ideally, of people, but also to make sure that we can leverage the content to still solve the poll start problem. And so what we did here, instead of using that very mathematical algorithmic approach to collaborative filtering, what we did was we took the news stories, we extracted features from each of these stories, and we represented the user that had consumed these stories in the same space that news stories are recommended in by taking a weighted average based on consumption metrics that we calculated for each of these stories. So, this here is an n-dimensional vector in which we are representing news stories. We are basically taking this user and representing them in the same n-dimensional space. Now that we have represented every user in this space, in this n-dimensional space, we can now compare a user based on what stories they have consumed, not the individual stories, but the actual topics within those news stories, and compare that with other users and create a enriched user profile that takes into account not only the stories that have been consumed by this user, but also shows dimensions of interest in topics that this user hasn't consumed, because these folks have actually consumed those topics as well. And of course, this enriched user profile is also in the same vector space that news stories are in. So we can simply take that and treat it as a pseudo news story and compare it with other news stories and create a set of recommendations. And just as we thought that we were, winning this whole process of building recommender systems, we got challenged with other opportunities. So we built this platform for learning, where peer-to-peer teaching happened through asking of questions. And so we used the same technology that we had used in the news stories to recommend to the right user that is capable of answering questions that were asked by their peers, and routing those questions so that we can get quicker answers to peer-to-peer learning. Now, interestingly, at the same time as we were doing this work, there was a whole change in the way recommender systems were looked at. And this was partly driven by Yahoo's research, where they had actually looked at the fact that the ratings that are typically collected by recommender systems are biased by the fact that people have a selection bias in choosing items that they're going to rate. And so typically the kind of data that we have for training our recommenders have a distribution like this, where there is a large bias towards positive recommendations, whereas in reality, where they actually gave a random set of items to users to consume and then rate, what was found was that the majority of items are actually not liked. So most human beings are eclectic in their taste. And so, one of the basic principles behind machine learning was questioned here, because essentially this becomes the training data that is used by the recommender model building system. And then it has to be applied to a very different distribution, which is skewed towards low ratings, right? And so, the basic principle that the underlying probability distribution doesn't change from when we build a model to when we apply the model, it was found to not hold within the recommender system community. And so what people decided to do instead was to think of recommendation as subset selection or ranking of items, right? And so a lot of the hard work that had been done in rating prediction was put aside in some ways, or tweaked to actually change the focus from being a regression problem to one of subset selection from the set of items that are available. The details of these algorithms, but another dimension that we found emerging when we were developing these recommender systems was the fact that this whole idea of having just user IDs and item IDs and ratings associated with them was a very incomplete model to what we were being challenged with. So one of our customers in the US came to us and said, can you actually create an app for us where we get home from a busy day of work, we open the fridge and take a photograph of our fridge, you identify what ingredients we have and start to recommend recipes that we can actually prepare based on what we have inside the house. So, we had to start doing some image analysis, identifying objects from images, whether they were images of the fridge or images of their vegetable basket, and use that in creating recommendations. And this was actually a very interesting problem, because not only were we looking at getting much richer information about what can be built, what can be recommended or cooked here, but also we had to take into account user preferences or user, there were folks that had a peanut allergy. So how do we bring those all into account? And of course, also the cooking and eating is a very social practice. And so how do we recommend things that are going to satisfy groups of people rather than individuals? And really sad as it might sound, but we found our solution more in deep learning, where neural networks allow us to expand the volume of data and the variety of data that can be used. Another example was in the fashion industry, where again, a customer of ours from the United Kingdom wanted us to take into account not just items that are purchased, but items that are browsed, product features into account, even customer registration data. And so what we did was we looked at, time series of sales. We looked at classifying items based on whether they are ephemeral here, where, an item becomes very popular and then just basically disappears. Other items that are eclectic in taste. These are, people who are buying items that are not popular in general. But we also started to look at whether we can classify users based on fashionistas who pick up on trends early and can therefore buy items that are going to be popular, early on, compared to followers of price-sensitive folks that are actually picking up the item when they have a second wind, and incorporating that into the recommendation technology as well, right? And so in addition to that, they had a lot of images. We were looking at how can we use those images to reduce the human effort of tagging these images across multiple dimensions, and using image analysis to actually look at what kind of fit a dress has, what kind of sleeve style, sleeve length, and so on. Can we actually replace the human effort by using machine learning and developing these recommender systems? But now that we've extracted all these features, how do we incorporate them into the model becomes the next challenge. And the way we actually incorporated them was to use neural collaborative filtering. We don't have time to go into the details of the neural collaborative filtering algorithms, but essentially what we have found is that by, one of the great advantages of these neural architectures is, if you look at it, we are still inputting a user vector and an item vector in here. So it's not that different from the data that we were using initially, but we can start to add a lot more features in here and input it into this computational graph. And even incorporate some of the ideas that have been developed prior to the use of deep learning. Things like architectures that incorporate even matrix factorization into the whole recommendation process. So the neural networks give a very extensible framework for us to actually develop these recommender systems, right? So I'll stop here. I know this has been a bit of a whirlwind tour, but I've tried to incorporate as much as I could. Needless to say, in addition to the recommenders that I have touched upon in news or education or the recipe recommendation and the fashion recommendation, we've also built recommender systems for bond traders, right? Where if you're trying to buy a particular bond, given a particular portfolio of bonds that you hold currently, how do you actually pick an alternative bond because the bond of interest is not available within the market at the current time? We've also built recommenders around human resources, where we are trying to match, given particular job descriptions, what kind of people would actually fit the job description, or indeed built recommenders around matching government procurement offices with suppliers that can meet their requirements. But looking at all of these problems from a recommender systems angle. So, my personal view is that having gone on this journey of 25 years building recommender systems, we've got to think of recommender systems just as any other machine learning algorithm with certain machine learning problem with certain peculiarities of the data that can be utilized and is made available. But essentially, you've got to kind of go right across the various types of machine learning and deep learning technologies that have been developed here. to create these recommenders if you want success within the industry with these recommendation systems. So I'll stop here and take questions if there are any.
Thank you so much, sir. Thank you for giving us deeper insights about recommender system and how it will be used in different areas. So moving forward, analytics can be used in so many different domains. Analytics is being used in so many different sectors and so many different domains, as we didn't knew earlier, like in human resource, insurance, and finance. To give us deeper knowledge of how it works in insurance domain, today we have Mr. Shubhabrata Ghosh, Head of Data and Analytics, Allstate India. Seasoned business leader with a rich experience in building capabilities and delivering solutions and services in the areas of analytics and big data, AI and intelligent automation, outsourcing, business consulting, solution design, IT application, and functional asset development. His experience is a good mix of client engagement, sales enablement, solution design and delivery, and practice building. We welcome you, sir, and over to you.
Thank you so much. Am I audible?
Yes, sir.
Thank you. It's really lovely to see so many students, the faculties, and other presenters and visitors. Very delighted and honored to be here amongst all of you. So after a highly technical and very interesting session by Dr. Sarabjot Singh, I will try to keep things a little lighter, and I hope the students and others will equally like it. So without further ado, let me start with the presentation. Howsoever we hate PowerPoints, but it comes to our rescue in these scenarios, especially. I personally wanted to be there and unfortunately, since I was in this post, I couldn't travel to your campus, but maybe sometime soon. Thanks to Dr. Alok, for inviting me for this. So let me know when you see my presentation, when I share it.
It's visible, sir.
Okay, thank you so much. Okay, so while I know the topic was more like analytics in insurance, but honestly speaking, we have come a long way from the simple and straightforward analytics piece to larger over-encompassing AI, and there is a reason, right? All of you know that analytics, many of you are on analytics students, I believe, and analytics is about, in a very simple way, if I have to talk or define it, it's about processing, analyzing data to bring out insights which are meaningful for business, for our lives, for our decision making, essentially. But what has happened over the last few years is that in the decade or so, earlier we were limited by our ability to handle data. And as we were limited by our ability to handle large size data, the size and volume of data kept on increasing, right, in our lives. What came to our rescue, although this AI term was coined in the 50s, but it became popular and started riding the hype cycle when the computing power became so much available with us. Today, we know, all of us, that we are talking of not just CPUs, we are talking of GPUs, and even a mobile phone that we hold in our hands has many, many times more computing power than the initial PCs, the days of PCs, right? So with that, no discussion of analytics is going to be complete without the intervention of the computing-led analytics, which is in a broader sense can be called as AI. So that is why it's analytics and AI in insurance. Okay, so let me start with a very simple story for all of you. So it's a kind of a reflection, because I head up data and analytics for an insurance company, one of the largest in the US. Now, the question is, did data science begin here? So let me tell you a story. A long time ago, a village had 100 households, and each household had one bicycle, and each bicycle cost about 1,000 rupees. Every year, 10 bicycles used to get stolen or damaged. Now, obviously, those 10 households have to bear 1,000 rupees each to buy a new one. And for a village household, it's a big sum. Now, what do we do? There were problems. The problems of financial loss, of course, 1,000 rupees gone. Second is uncertainty, because you don't know whether your bicycle is going to be damaged or stolen, and suddenly you have to, that means you have to save 1,000 rupees every time and keep it in your kitty to buy in case there is a loss. And of course, there's retention according to around that. So there came a wise man in the village, and what he did, he kept a pot and said that, what if every household puts 100 rupees in the pot? The pot will have 10,000 rupees. Every time a bicycle gets stolen or damaged, the owner gets 1,000 rupees from that pot. So by paying just 100, everybody bought peace and certainty, and of course, the reduced financial burden. In a very simple way, this is how insurance works. I know it is oversimplified, but nevertheless, you get the point, I guess. The question is, did data science begin here? In a way, yes, because insurance is the industry which used data as at the core of its business many, many years ago, actually centuries, almost 300 years ago, when the actuaries started. The whole concept of insurance is about looking at the past data, understanding it, building a model to predict the loss which would happen in the future, just like this example, and come up with a pricing model so that everyone gets a little, has to part with a little money to save the bigger financial loss and cover that uncertainty in each of our lives. So that is how pretty much the insurance and this science was called actuarial science. So today we see data science is the most popular thing, and I will show you in the next slide. But actuarial science is where the data crunching for an industry, for a real business began. When you talk of actuarial science and data science, many of my students and community and youngsters, they keep asking me that those are two different streams, but very popular career choice, high-paying career choice as well. How do they differ? So obviously, I've listed it here. I'm not going to drain the slide, but very importantly, actuarial science is a licensed profession. It's a centuries-old discipline. You need a lot of years of study and qualifying exams, typically regulated by a central body. For example, we have Indian Institute of Actuaries, and yet to penetrate a wider field. It's focused on insurance, pricing, risk, regulations, investment. Some of the banking and financial world also use actuaries. Whereas data science is not a licensed profession. I mean, we are seeing people trying to become a data scientist going through online courses, or MBA in data science, MS in data science, MS in business analytics. Multitude of courses are available. Obviously, it is not regulated. And most importantly, it's multidisciplinary. It can be applied in many things. I have done a simple Google trend search, this morning, and it was very interesting that if I look at the science, people searching for actuarial science and data science over the year, I've started somewhere in 2010, about a decade or 12 years back, and if you see that data science search in Google has gone up and up and up. Obviously, actuarial science is still relegated to the core insurance professional and all, although it is also kind of the math and statistics and the whole of data crunching. And the reason I wanted to bring this out is that insurance, at the core of insurance, there is data. However, there is a problem. Traditional insurance data was not big. What I mean by that, I am sure that all of you know that the 5 V's of big data, which are typically associated with the big data. What has happened is the most important thing is the volume. That how large is your data? Now, insurance data in the actuarial science field was primarily aggregated data from the insurance company's loss, pricing, premium for the industry, and that's all. The second big problem was that there was no velocity. Let me give you a simple example. Many of you might be having credit cards. You would definitely have bank accounts, or you are buying on Amazon, you're on Flipkart or any of these online retailers, you are making purchases. Now, each of these sectors, if you see, or making phone calls every day, and sometimes you have billing problem and all those things. So in each of these sectors, be it retail, banking, credit card, telecom, you will see a very interesting thing, which is so different from insurance. There is a constant customer touch point. There is a constant usage, and every interaction generates data, right? So you get a lot of volume as well as the velocity. Whereas in insurance, if you see, if you understand even the basics of insurance, somebody buys a life insurance, annually the person pays premium. And as you know, there can be only one claim in a life insurance when the person dies. So that means the touch point with the customer for a life insurance company is pretty less. Compared to a credit card company or a telecom company or a retailer, it's minuscule. Similar is with for auto insurance, which is called motor insurance in India. Unless your vehicle meets with an accident, you just pay the premium and sit back. There's no problem. So the velocity is there. The third piece is the variety, because it's typically related to only one function, the pricing and the data related to the subject matter of the insurance, which is the asset or the life. And that also is very limited, because typically for a life insurance company, as I buy a life insurance policy for at the age of say 25, a medical report is taken and all of that is done. So that data is there and that remains static. And there is no other data from my side is collected till I am paying the premium for a long time. And whenever I die, right? So there is not much of a variety as well. So those were the typical challenges. And that's why the traditionally insurance, while it started all there, but it did not evolve in an analytics space as the other sectors, as I explained, the banking, retail, telecom, and other sectors. Now, as days passed by, slowly insurance became much more competitive, and some of the pioneering insurance companies took steps. They started touching the other aspects of insurance business apart from just the core pricing piece, which the actuaries were looking at. They looked at the whole insurance value chain, and that's what we have today. If you look at the insurance value chain, just like any other business organization, typically you will have a marketing department, a sales department, somebody will do the product pricing, something which is pretty typical of insurance company, not really seen in other industries, is the underwriting and claims. This is where the risk is assessed. That means whether your car is damaged, how old it is, what is your driving pattern, how many people use it, all those kind of things, and then you decide the pricing. And of course the claims, when there is a damage, you come back and claim that, and the whole operations of the company. And this is still there. The actuarial piece is still there. But what is happening across these functional pillars, today you see a whole lot of analytics happening. For example, in marketing, so campaign design for a bank and tracking is no different than a bank or a retail company or any other business organization. We do our prospect analysis, we do customer segmentation, customer acquisition, we try to cross-sell and upsell. So for example, if somebody has a motor insurance policy and the insurance company also sells life insurance or has a life insurance partner, they would go and try to sell a life insurance plan. I'm sure many of you would be having accounts with some of these banks like ICICI or HDFC who have life insurance subsidiaries like ICICI Prudential or HDFC Life. Many times your banker would call you and say that we have a beautiful policy for you. So that's a cross-selling. Upselling is of course going for a bigger product or better product and saying that take a higher value policy and things like that. And then of course trying to retain and customers and predict or reduce the churn. So those kind of things. And I will go for some of the interesting things in my future slides. I don't know if I'm keeping the time intact, but I'll try to do that in 25 minutes. So similarly, in case of sales, in pricing, underwriting, claims, operations, everywhere, there is analytics at play today. Because what we started doing as an insurance sector is that we also changed over time. So let me talk a little bit about the marketing side, which will explain it better. So you must have heard from your parents or even in your current, your ecosystem, something called insurance agent, right? So traditionally insurance was sold, not bought. So people would not be interested in buying insurance because very simply put, I'm driving a car and if I don't meet with an accident, so there is, my money goes down the drain, right? If I look at it in a very simplistic way. But as I explained earlier with that example of the story that I'm buying my peace of mind. But in a way, insurance is a regrettable necessity. Now, I typically would buy insurance through an agent traditionally, and the agent would come once a year, explain to me, sell the policy, and once a year he would or she would drop by and collect my premium check and go. That's how it would be. But over a period of time, insurance started getting sold digitally as well on web and other things. We started targeting our customers when they started watching TV. So today we would be presenting or talking about how easy it is to take. I'm sure you must be already seeing a lot of insurance ads all across in print, in digital media, in television, and all of that. Now, for that, we need to figure out that whether we are spending the money in a right way. Now, earlier, we would not bother about these things. We were all focused around these three pillars. And of course, some degree in the sales, that which agent is bringing what kind of policies, whether the book, as we call it, the book of the agent, that means the portfolio that the agent is handling is profitable or not and all. But later on, other things started coming. And here also, we started bringing in analytics in a much different way. And then that is where I'm talking about the volume, velocity, and variety. So let's move on and see what do we mean by that with some of the very interesting examples from insurance industry. Telematics and insurance. This is a very, very interesting and it's a very intelligent use of technology in the insurance world. Telematics is nothing but the bringing in the concept of movement and the devices and capturing that center data to price insurance. So essentially, in a very simplistic way, the vehicles are fitted with telematics devices that capture the data and it measures and transmits driver behavior. The insurer captures that in their database. They do run insurance analytics, they do driver scoring, and that way driver can save money on their policy. How does it happen? Let me ask you a very simple question. Now, I am selling a car insurance. So person A comes to me, I say that, what car do you drive? They said, okay, I drive a Maruti Ertiga. Fair enough. So this is your insurance policy and this is the premium. Similarly, another person B comes with who drives the same car and pays the same premium and goes back. Now, if I tell you that person A is at age of 32 and person B is of age, say, 65, who do you think would be a safer driver? No prizes for guessing. I'm sure you would have already guessed it correct. The person at the age of 65 can be safely, if the person is healthy and doesn't have any eyesight problem or hearing problem, can be assumed to be a safer person because of few things. Maybe because of his age, more cautious driving. Secondly, the driving itself is limited to maybe going to a bank or to the grocery, a retired life, not commuting to work every day, not going out on hill stations and outside trip. Because I'm again talking in general. I mean, don't come back to me with an example that my uncle does that every evening. I know there are exceptions, but typically that. Now, does it make sense to charge the same premium for both the persons? When the person who is at 32 may be rushing for an office meeting for which the person is delayed and driving fast. Maybe the person is a rash driver. So typical is that what we call as hard braking, faster acceleration, all of these are driver behaviors or jumping signals. Now, all of that through the sensors fixed. So typically most American cars and now all the Indian cars also, all the latest Indian cars, they are fitted typically with what we call as OBD, onboard devices. And those onboard devices can capture the movement data, the vehicle movement, the geolocation, then where and how you are braking and all of your driving habits and all. And therefore, the insurance company is able to charge appropriate premium for those drivers, or the different drivers groups or different drivers as per their driving behavior. So it is essentially called usage-based insurance or pay as you drive and things like that. It started long back, maybe somewhere around 2005, 4-5, when an insurance company, Progressive, it started with a very interesting thing called, they came up with this plan called Autograph. Auto means, of course, the automobile here, Autograph. Today, the company I work for, Allstate, use mobile devices because everybody carries a mobile, right? So our apps and programs like DriveWise, so this Wise is, of course, is in a wisdom as well as the usual suffix here. It can detect crash detection, it can detect speedy driving and all of that. And that way, it constantly measures that whether the driver is a safe driver or not. So basically, we are not only using analytics for insurance, but we are also using it for promoting safer driving. So that was one example. Secondly, all of us know that many of us are already wearing smartwatches. There are smart glasses. There are so many other things that we are wearing. Now, all of these are nothing but sensors which are measuring our lifestyle, our movement, our active life, when we sleep, when we get up, all of that, right? Now, for a life insurance company, that is an asset. This data, which I talked about that earlier insurance did not have, I gave that example of life insurance, right? Once you do the medical report for the whole life, you don't do anything and you can pay the premium as long as you're paying the premium. But today, life insurance companies are encouraging. The first program about with this vault, with these wearables came out from a South African company, and their program is called Vitality, which is now subscribed by many of the leading insurance companies in the world. They promote healthy living. So if you are active, you are doing your 10,000 steps every day and all of that. So what you get is Amazon vouchers or gifts and things like that. Of course, they can't return the premium, but you get benefited by those rewards. And it is reducing their risk, because every time there is a death, the life insurance company has to pay claim. And claims is a loss for the insurance company. So they would rather not have a death claim or an accident, right? Similar to the example we took earlier in the auto insurance, here we are talking about a life where we are saying that if we can analyze that data, predict the lifestyle, predict the pricing correctly, then we are returning back or giving the user a benefit. At the same time, we are managing our business in a better way. So wearables and sensor data has become a huge data source for both life insurance and non-life, or the motor property casualty as it's called in the West. That has become. Let me take another example. In the insurance industry, in the automobile, especially in the US, there is a concept of colludial frauds. That means few people join together and they create a scene of accident so that the old vehicle which had to be replaced and all of that, and they can claim they can go back to their insurance and claim that. Now, to catch that, there are graph databases like Neo4j and all that can be used to find those interrelationships between the different participants in that crime. I mean, it's not a crime scene, it's an accident scene. So there are so many accidents, typically in group accidents, etc. These are the cars, who are the participants, drivers, passengers, witnesses, etc. Then doctor, lawyer, all of that. That analysis helps unearth very interesting patterns and many times very interesting discoveries that these people seems like they have colluded and had done this fraud. Let me give you a very simple example, which I have seen in the Indian market as well. An Indian insurance company who used to be my client earlier, they found that a lot of claims are coming from a particular area. And when the analytics is constantly running, and what flag did the analytics raise? That we are finding a common trend that it is coming from all these vehicles are getting repaired at a common garage. Obviously, they put their special investigative unit at task, and they found out that there is a collusion between the claimant and the garage to bump up the claim the claim amount, and then the replacement and pricing and all of that. And they are getting maybe side work done for the older damage or a part fixed in the car and then putting it in the claim. So all those kind of things can come out when we analyze the claims data. Very interesting change has happened over the last, couple of decades, maybe, or less than that, actually. Earlier, it was all about tabular data, the structured data, right? You fill up the forms, your customer name, customer age, customer address, and all of that would be filled up, and that would be stored in databases. But with the advent of technology, a lot of things have come within the insurance sector as well. Very simple example, or very interesting example on the left-hand side, as you can see, we are using drones today. So as you know, that in the US, there are a lot of hurricanes and tornadoes and all of that. Even now as we speak, we are handling a lot of claims in the Florida side. And almost every year there is, I think one of the hurricane you will always remember because of the Bollywood connection, Hurricane Katrina. So we have had a lot of losses for that. Now, what we do is that it takes a lot of time to inspect those in detail, and we don't get an aerial view. Is always what we call as a bird's eye view, right? It gives a good picture and all. So today we are using drones for our risk assessment as well as damage assessment. So those images, so what do we do with that? Then we have contact center data. So it is not just the voice calls, but today we that you can chat with the contact center. You have even installed chatbots where the text we can be analyzed. So that is again unstructured data. And then of course the document data, that means the claims form, the medical reports, all of that come in a scanned way, and somebody has to process it. So today my team is doing a very interesting project where we are looking at the medical reports, and which run up to almost 800,000 pages. How do we use the power of AI to convert those images into searchable text and analyze those texts and help in automating a lot of the processes that the medical professionals who are working within the insurance company are doing on that to settle those claims. So these type of data are all about unstructured data, right? Now, how do we use that? So today the insurance companies are doing it in many ways. So what we are doing today, and I will give you some examples, looking at the images and all. So our what we call as data labelers, it's a kind of a role in the data analytics world. Data labelers they are helping in text redaction by using by labeling those PDF or scanned PDF documents and all of that. Similarly, from the drone images, they are identifying, okay, this is the tree, this is the car parking, this is the house, like that. Similarly, in vehicle, they are doing that. This is the vehicle damage, this is the vehicle and all of that. We are also looking at similar images and matching them using, again, computer vision and AI and machine learning to see that, okay, this is a fraud, this is a duplicate, this is a second claim file, or with the images of same vehicle and all. And finally, we are also looking at the audio reduction, which is essentially the customer service calls. When they are converted into voice to text, we try to find out the sentiment. So giving again a live example, suppose somebody says, "Oh God." Now, "Oh God" could be an expression of happiness. "Oh God, you settled my claim. That's great." Or, "Oh God, I still have to wait for 2 months." So that could be it. So our labelers not only label that, but they go back to the audio, listen, and contextualize it. So with that, what we are doing by these activities, we are bringing a structure to that unstructured data so that the machine learning algorithms can learn and can be used for solving real world business problems. And I will give you an example quickly. This is a very simple image, and you can see one common parameter here, that every one of them are using mobile phone, right? And this slide I keep using, and I have not changed this slide since 2017, and I use it even within my company, because it doesn't matter what the data is, but data is itself already scary. That means 425,000 injuries and 3,000 killed every year in the US. We are a US insurance company, so I've taken that. And I'm sure it will be much, much more in the Indian context, because people are distracted by their mobile usage. What do we do about that? We have a company subsidiary called Arity. We process all all data, and which we talked about, the telematics and all, using the dash cams. If the dash cam detects that the user, the driver, is using mobile phone and all, it can warn the driver. And that is where, so these images that you see, these persons are essentially my company's employees who volunteered to get themselves captured by the dash cam. That became our data set for the machine learning algorithm to learn, and then we deploy it back to the dash cams and the car software. Today we do not use this, of course, so aggressively, because we have moved from there to mobile sensor based, because the mobile phones itself have so much of good sensors that if you lift it, if you open it, unlock it, everything is captured. And our app, and it's what you can call it like an edge computing, it is actually analyzing that mobile usage behavior and constantly predicting and suggesting safer driving behavior to the driver. Because if you are driving and watching a text or doing a WhatsApp or anything, it will pop up and say that and it will also go into your driving behavior that you text while driving. So that makes you unsafe driver, and therefore calls for a higher premium for you. So that is how we are doing it today. Let me take a quick example of a real thing. Somewhere around 2016-17, my company Allstate launched a new service called Quick Photo Claims. Typically, there is an auto accident, the person takes it to the garage, then calls the insurance company comes and an insurance company assigns a loss assessor or a surveyor, as it's called in India, and the person comes, takes the photograph, does the estimate and all of that. So what we did is that, okay, can we fasten it? Can we make it much faster? Can we make it, more customer friendly? So what we did is given an option of a new option called Quick Photo Claim in our mobile app. So you click that, what you get is that you have to click photos and submit. So you have to take the photos of the damaged area, as the lady is doing here, and the entire vehicle, and the VIN and odometer. VIN essentially stands for vehicle identification number, so that we can assess it for the same one vehicle. Odometer, of course, is the mileage counter. And then take the photos and upload. Now you might be wondering, where is the machine learning or analytics or AI in this? Because this is just a mobile technology, and somebody sitting at the contact center is going to look at the images and do the processing of claims. Faster, may not be the complete accuracy, but definitely faster, and the claimant gets, or the passenger or the owner of the car gets money quicker. Whereas I talked about unstructured data. So this is unstructured data in action. So our labelers have created thousands and thousands of data, or large data sets, by looking at various vehicles, various models, various damaged vehicles, and and marking them by using data labeling applications like Labelbox and Heartex, saying that this is the left rear bumper damage. This is a tail light broken. This is the number plate. Like that, we have labeled, and those data, that huge number of images, millions of images that they have built, is used for machine learning. And what we implemented last December is that when these images come from these quick photo claims, now they can go through that algorithm, and we can get quickly an assessment of the claims value. And so it's like the benefits are just-in-time claims processing, lower cost, higher customer satisfaction, of course, and better pricing and risk management, because that same data can be used back when you are next year pricing the car, right? So that is another example I thought I would share with you. Of course, there is a big scientific application which is used in insurance as well, because many of you know that many parts of the US, similar to our Indian geography as well, some places are low-lying areas that get flooded, and how can we forget the recent flooding of Bangalore itself? So the people who stay near the water bodies, obviously they are at risk. So using the geospatial images and details, we do geospatial analytics to predict the losses and the size and the frequency of losses, and accordingly price our policies. So that's another area of analytics and AI for our risk management, because insurance is as much as a product for financial safety, it is also about managing the risk of losing our money, right? So we talked about that. Yep. So I think I'm good with time. If I'm, I don't know, but I'm ready to take any questions. And I hope you got a glimpse of the power of analytics and AI in insurance, and happy to take any questions.
I have one question.
Sir, we are actually
only one
question.
If you permit.
Sure.
If you permit. Data companies collect.
Sorry, I'm not able to hear. Can you be louder?
The amount of data, the quality of data that you are collecting, like putting dashboard cam and all that, this could go for policy framing by the government agencies and the car manufacturers, which make certain devices mandatory. Like for example, seat belt became mandatory because of Ralph Nader, episode. Now, getting this data might also help framing policies. Do you agree to that? Is my question clear?
No, I think the audio is still a little weak. I got that, the seatbelt part I understood, and the data that we are collecting, but what is the question?
The rich data you collect, including your geospatial data.
Yeah.
You have enough of information to provide that, from the data gathered, analyzed, you can give input to automobile manufacturers and
Yes.
also governments to frame policy, that way you can cut your losses also.
Absolutely,
By making
absolutely.
certain things mandatory.
Absolutely, and that is happening. That is pretty much happening all the time. And when we say I talked about these onboard devices, that data is not only used by us. That is actually mostly used by the automobile manufacturers to improve their safety features within their vehicles. That is one. Secondly, I would mention, and with pride, that when seat belts came in the US, obviously the automobile industry revolution was more in the US first. And the seat belts came in, Allstate, my company was one of the primary, or rather the primary partner with the automobile industry to promote seat belts. And we were the first one to use analytics to bring in segmented pricing for different type of customers way back in 1930s. And which is very amazing even to think of it, that at that time data science analytics was not even a term to be used. So we did that. So we definitely use this data for betterment of the society, as well as helping the government also to bring in the regulations and safety features.
Thank you. Thank you.
Thank you. Thank you so much for this opportunity. All the best for the rest of the sessions.
Thank you very much, sir. That was really a very knowledgeable session. We actually got the knowledge on how analytics made the difference and played its role in insurance and its value chain. So now it's that we have came to a half end of our conclave. I would like to thank all the audience present over here for their patience hearing. So now we'll take a break for a lunch, and it is served at second floor debris. And I request all the students to visit there for 15 minutes later. That's it.
What time do we have to come back here?
Yes, we'll get back here at 1:45 p.m. sharp.
The students will come after 15.
Yes.
It's not debris, it's
Sorry.
लंच की पिक्चर्स के लिए भी आता है।
कौन से एक तो पीछे एकेडमिक एडिटिंग के लिए मार्केटिंग
गोरे आने चाहिए थे।
वो पोस्टर आना चाहिए। हम दोनों का थोड़ा तो सब मोबाइल में भी
ये टॉर्च किसने डाला है? जैसे क्या बोले तुमने?
रिफ्लेक्शन वहाँ पे चल रहा है। She is selfie for and provide picture. And see, it is some new.
बस कर यार, हो गया।
Very interesting session. So while walking, it is called hands, right?
Yeah, we had students, we had
LINGs instead of NING.
I think.
So we use, we actually scripted.
So it was perfect, I think, for the, we needed somebody like you to. Keep it related. And I have Sahil Makkar again from OTS Minds. He's also one of the speakers. I've been receiving. So now I just want We have
Virtual.
after analytics in which one you have? Analytics in finance. Renuka. After the commerce, let me give you this schedule. Are you not in the analytics conclave too? So please refer to this schedule. So Renuka, after lunch is Renuka, analytics in finance.
Sorry for the confusion. So now we have a topic analytics in finance. Analytics has made to look finance sector in a different ways. With the help of financial analytics, we can predict various aspects of finances. To know more in depth that how analytics is really helping in finance sector, today we have with us Ms. Renuka Yes, Manager Analytics from PayPal India. Ma'am is also a passionate analytics enthusiast who helps unearth insights from big data by developing analytics and visualization tools to make data ready for quick decision making. Ma'am, I would like to request you to take over the session.
So, thank you.
Good afternoon, everyone. So, just before we started, Sahil was asking me if I can manage the crowd, given that all of you just had lunch and all that, and I challenged him that I dare any of you to sleep in my presentation, given my loud voice. Right?
Oh, you're daring us?
Yes, I'm daring you to sleep in my presentation.
I love this.
So we are not going to be driven by data, we'll be driven by you.
By my voice, by my me, by my confident personality, by etc. and my presentation. Okay, so without any further ado, let's get started. So today I'm going to be presenting to you some of the use cases that I've been exposed to in the last 10 years, not entirely in the last 10 years, because I have very minimal exposure to finance. Since Alok requested me to make a presentation on analytics in finance, I tweaked my presentation to make it fit the framework. But yes, all the use cases that you see here, I've been exposed to in some form or the other, in some parts in the last 10 years of my analytics experience. So the agenda for today is going to be, I'm going to give you a background of how I used to think analytics is, to how it actually is in finance, by giving you examples from payments and pricing industry. These are the two financial projects that I've been exposed to, and that's what we will be focusing. So in the last 10 years, I worked in multiple industries. I've solved analytics problems in many industries, like there is retail and supply chain, technology. Sorry guys, this remote is slow, it's not me. Oil and gas, manufacturing, healthcare, and yes, even a little bit on finance as well. While I was working on these industries, and even before that, when I started my analytics journey by reading a lot of books and by exposing myself as a consultant in multiple industries, because I've always been fascinated by data. And I've self-taught myself on tools like R and Tableau, and even today, like it's been like 2010 was when I started working. It's been 12 years. Even today, I can tell proudly that I'm very good in Excel, and I'm not humble at all about the Excel that I know, because that is something that I learned intensely and passionately. And despite being exposed to these multiple tools and multiple industries in analytics, for a long time, I used to think solving analytics problem is straightforward. You just pick data from different sources, put then through statistics or black box models, and then you get the inferences and relationships out of it. Then you derive business rules, and that would lead to really good decision making. Congratulations, we are all analytics experts, right? For a long time, let me admit, I used to think analytics is as straightforward as it is here. This kind of assumption went into, like I used to have this assumption even when I was working, when I was in the industry, and it was only in the last few years I started having new perspectives on how analytics really is. So I'll go to the next slide. Sorry. So let me skip the animations here, just give me a moment. Right. So, yeah. Okay. So today I work in a product-based organization. And to implement any analytics solution, we need to go through multiple stakeholders. Sorry, did I do something? Okay.
So part of the screen was blank.
Okay. Then now it's coming. Yes. Okay. So we're good. So today as a product analytics manager, I work with multiple stakeholders. And analytics is as least straightforward as it can get. When I was a consultant, I was able to get help from a lot of people working in the firm that I used to consult with, and all I had to do was analyze the data that was given to me. But today, I know that it's much more complicated than that. At PayPal, we need to work with multiple teams, collaborate with multiple teams before we deploy any analytics solution. First, you have the data engineers who we need to convince to give us the right data in the right format that we need. And then you make submodels, and then you do feature engineering, and only after passing multiple steps can data science models be implemented. And it's not just about the models, and you need to have the vetting of the product managers as well before we do anything with the models. And once the product manager sees the results, there will be multiple iterations and reiterations. We need to go back to the data engineers, we need to go back to the product managers, and we need to convince a lot of people. And finally, when we have a model which is convincing everyone, then only then it goes to the business stakeholders. Again, it goes there, and then it goes with the understanding that there will be multiple reiterations, of course. So this is how analytics is, and it's very nuanced, it's very specific to industry, and especially in finance, it is very important that we get the vetting of all the stakeholders in picture, and hence this is very, very relevant to today. Like this is a framework that is applicable in all product-based companies, in finance companies, and something that we all should make note of. With that in mind, let me now move to the couple of projects that I would like to talk to you about in the payments workspace that I right now belong to. So the first use case is intelligent transaction routing. So all of us use some form of payments, right? We all have some apps. We are all subscribers to Netflix and YouTube and whatnot, and we use credit cards and UPIs. And for people living in India, using payments online is not foreign. It's not a foreign concept at all. And we take it for granted. We take technology for granted. We don't really think more about how the backend system works. We know that when we pay something, we get the things. But what happens in the backend is a lot of complicated process. There is once you swipe a card, it needs to be approved by the bank that had given you the card. And then the money has to flow from your bank to the merchant, to the Amazon or the YouTube or the Netflix, from whomsoever you're getting the service. And this needs to flow through the networks, Visa or MasterCard. Now, given this complicated process, and in any of these steps, there could be some system outage or disruption, because of which the payment only could be cancelled. Then you may have to repeat your payment. Like so many times you would have gotten mails from Amazon telling, you know what, your last payment was cancelled. Can you please go ahead and retry? That happens because one of these steps or multiple of these steps would have gotten disrupted. So not all of us would go and retry. We'll just forget that, we needed that product. So losing a transaction is very expensive. And it's very important that the payments companies help the merchants to not lose any of their transactions. And that's where this intelligent transaction routing helps. It helps. Yes, sir. You have a question?
No.
Okay. So what it does is, based on how your transaction is, where it is coming from, what card it is coming from, it is going to decide which route the transaction should take, so that there is a likelihood of success in the transaction, and Amazon need not come back to you and ask you to make the payment again. This is done with the help of machine learning models, with the help of analytics. And this is something you can read up about. I've given the links to this on the notes as well. I'll share the presentation. And this is very helpful, especially when you're working on a lot of cross-border transactions. Like you're sitting in India and you're buying something on Amazon.com to give to your friend sitting in the US. When it comes to cross-border, the likelihood of failure, given that you are not actually present in the geography for which you're buying the product, it's very high. So intelligent transaction routing, if it is enabled, if the payment system has enabled it, it's going to be very helpful and make sure that your payment is not going to get declined, or no system outage is going to stop the receiver from getting that product. Likewise, another use case that's very important for payments industry is knowing if a certain transaction is a genuine transaction or a fraudulent transaction. There are different types of fraud. Given that we are dealing with something as sensitive as credit cards and financial instruments, the likelihood of fraudulent transactions happening is much higher than average in payments industry. Like so many news articles we read about our credit card information getting stolen, and that we need to be very careful about where we store our credit cards. It's not as unsafe in India because RBI has rules of OTP and other things. But even then, if your credit card information is stolen, people living abroad, or you can buy things from Amazon.com or any of the other non-Indian sites. So it's still not a good place to be losing the information that's very sensitive. So we have risk models which will help us know beforehand by just looking at the transaction, where it is coming from, the time it is happening, the amount that is being transacted, if that is at risk to being a fraud or not. And these are the different kinds of frauds. Like there is identity theft. Someone could steal your credit card and use it to buy something. There is an unauthorized chargeback. Like you can actually, in expensive countries like US and in the Western world, when you return a product, to come and pick that up is more expensive than the price of the product. So they'll just refund the money to you. You can still claim, you can still ask for that refund despite the product being good. So that is one fraud, and that is the unauthorized chargeback. And bin attacks is somebody knowing what are the first few numbers of your credit card based on your bank and the credit card type and everything, and deriving the rest of the numbers through logic. And the triangulation fraud, someone can claim to be a genuine e-commerce site and selling you iPhone 14 at like 10,000 rupees, and you fall for it and you share your credit card number, and they can use a credit card number to buy something from somewhere else. And then account takeover. Someone can actually take over your account by stealing your password or something, right? So we have risk models in place to identify all of these fraud practices, and that is enabled through ML models like convoluted neural network combined with deep learning, which is traditionally not used for identifying fraud. It's not used for numerical data at all, convolution neural network. But still we are in the position today to tweak models that are traditionally used for image processing to help us identify fraud. Having said that, let's move to another industry I'm familiar with, the pricing industry. So here, analytics is used to help determine the right prices for the right target audience. And The two use cases that I've been exposed to is our transactional pricing analytics, wherein at the individual transaction level, you can allocate the costs so that you know what is the true cost of your product. Like there is some cost that is incurred at an organization level, and you need to allocate it to all the transactions. Think about it, right? Like on a day, Amazon would get millions of transactions, and a manufacturing plant will produce millions of products. How do they make sure that they price the products appropriately so that they don't incur any loss? All the costs that they incurred should be allocated to the product at its right level. And they can do that with transactional pricing analytics. And another use case in pricing is elasticity and demand modeling. A 1 cent change in price.
Ma'am, should
how
I
much?
ask you questions now or should I?
We'll come to it later, but okay, sure. We'll come to questions in the end. So just 1 cent or 1 paisa change in your price, how much of that is going to impact the demand, combined with other variables like competitor behavior and the place where you're positioning your product, and all of that can be used to help you understand the price impact of your product, and that also is enabled through analytics. And like we spoke about the nuances, importance of nuances in the industry before we implement any analytics solution, pricing also is very nuanced. So it starts with data collection, of course, which you feed into the demand models, and then you use that to determine your own strategy and rules for how you price. And then you run optimizations and scenarios by different markets. And once you're convinced with all the rules, only then you enter it into the system. It's as complicated as it can get. And that will help you set prices at the granular level possible, most granular level possible. And it just doesn't end there, right? You need to keep monitoring it and make sure that your prices are, that you're not losing customers because of your change in prices, and you keep checking if there are any fraudulent practices. It's as nuanced as it can get, even in pricing, is the point that I'm trying to make. So as a conclusion, I would like you to think about a few things before you deploy any analytics solution. Think of the nuances in the industry that you're in. In one of the presentations earlier, I forgot the name of that person. He was talking about analytics in agriculture. He was saying before you build any models which models the behavior of an object, you need to know about that object. Before you build a model which will predict if it's going to rain, you need to know about the weather. Likewise, before you go ahead and build any analytics solution for a pricing or a finance or healthcare, you need to know that industry first. No, it's more important to know the nuances than the analytics technology. And then I'm sure many of you are aware, given the confidential information finance companies gather about all of this, it's very important that as analytics professionals, we are aware of what are the restrictions that we need to work around with, because it is the sensitive customer credit cards that we are dealing with. And the personal information data reveals much more than what we should be using for deploying our analytics solution. So we need to be cognizant of all these nuances in it. Yet, analytics is going to be helpful. Despite the nuances, despite the restrictions, when we deploy the model at the right way, it is going to be helpful. Thank you. Time for questions. Pricing model. Yes.
How secure is your?
How secure? It depends on where, like, how you implement it.
For example, I'm searching on within a very time, I get an alert from Uber that that means somebody is tracking my data, right?
Absolutely.
Similarly,
So you've willingly given away your data when you downloaded the app.
How it is going to other like competitors, how it is going to same project or the competitor where the competitor is blocking the customer?
Given you're in the same ecosystem, they share the data with each other. So within the ecosystem, it is secure.
You mean competitors share data with each other?
You're in the Android ecosystem. So
it's
you don't
Android
have
is
control.
sharing the data with the competitor.
Yes, absolutely.
Isn't that illegal?
Not Android is not sharing with the competitor. Within the Android ecosystem, whatever apps you're using, they are getting the same information. They know when you're opening your phone, when they know what your battery level of your phone is. They know that you are searching for a restaurant now, and they know that you're going to sleep at this time. So it is the data that is willingly given away, right? Like we download apps after reading everything and agreeing to something. Just that we don't read. Yeah. We just agree to it because we are all busy people. But yeah, we willingly give away the information. So it is secure within that ecosystem, but
It's like marriage.
I don't know about that, but sure. Yeah. Yes.
Regarding transactional pricing, there it is a very robust, rugged, well thought of system. I don't know how ML can help that, because product pricing of even majority of the SKUs, it's a very old system that has worked very well. I don't know how ML can help in that.
So think about some unknown aspect like exchange rate fluctuation, right? So you are expecting the exchange rate to fluctuate, and that is going to lead to a lot of losses for your organization as a whole. And how do you allocate that loss as a cost to every one of your individual SKU unit?
Even this very well-known theory,
You can't do peanut butter spread. You need to make sure that you know how much the impact of each of the cost heads are, and then so ML models will help you estimate how much that impact is.
My question is, you don't need to estimate. You would know that, and you would know how much of forex component is there.
But you don't know how much the exchange rate fluctuation is going to be.
You don't know that, but you know if I have a component, how much of them will be impacted by exchange rate fluctuation, and if the dollar goes up by 2 rupees, how much will my cost
Perhaps,
go up?
but you need to know how much dollar is going to go up. ML model is going to help you predict that. Right?
Can we predict?
No.
Why not?
Can I just
predict exchange rates? I don't think so.
You can't predict with 100% accuracy, but you still can. Why not?
No, ma'am, there are standard models for forex thing. So, I'm not trying to.
I'm sorry, but we are
Okay.
behind
We can
schedule.
take it offline. Sure. Thank you so much.
But yeah, thank you. And thank you, Renika. Yeah. So, yeah, but before you leave, just 1 minute.
I would like to call Nisha ma'am to give away the.
Thank you so much.
Thank you.
Once again, thank you very much, ma'am, for your valuable insights about how analytics is rolled up with finance and the projects which you explained regarding the intelligent transaction routing and the risk models and other pricing models were informative. So we thank you once again. So moving on, now we have an opportunity to know more about BA, how it has spread its wings globally. So especially in Europe. So our next speaker, Thomas Vector, CEO ITPS Switzerland, will be sharing more details on the same. Sir has studied electrical engineering at University of Stuttgart. Sir is ISS ECO certified professional in secure software engineering. Sir is also certified project management professional. So I would like to welcome you, sir, and over to you. So can you hear us?
Okay, so you hear me? I'm quite far away. I'm sitting here at the moment in Austria, so I hope the connection is well. And
we are able to hear you, sir.
Okay. I just want to start my presentation. So I don't know, I have to, you see my screen or you see only me? Sorry for this silly. You see me, so I need to find out how I can now bring it online. Bildschirm freigeben. Okay, good. Emergency trends in. Sorry that I'm not so fast. Okay.
Yes.
Okay. And if I now start the presentation, then I hope that you see it too. What do you see now? The presentation? Okay, I hope so. Yeah, so yeah, dear college students and audience, and on behalf of ITPS, I would like to thank you that I have the opportunity to speak to you. I have made me a lot of thoughts about what I shall tell you about Europe, and therefore I created different topics in my presentation. And the first is that I would like to give an impression of this arc of tensions between big data, the usage of big data, and very important about the data privacy, which is a very important topic here in Europe. And perhaps you have heard that bigger companies have problems with European law, and that there are a lot of things that need to be followed that are perhaps unknown to you. So this is so one part I would like to discuss. Then in general, I have made in my life a lot of things with big data, and therefore I want to paint with you a picture in your mind. So this is something that I have summarized in the topic of big data. And then, of course, if we have big data, then we shall discuss what we can do with this data. And based on today's times, I see an important topic to discuss what we shall learn out of these times. In crisis, we have with, unfortunately, war and a lot of problems also here in Europe. And of course, I would like to discuss and present our ideas that we have in this collaboration with the DSU. And yeah, then at the end, perhaps a short summary or conclusion. I hope that I can give you a few minutes of an interesting presentation. I normally don't follow so exactly my foils, so I hope that you anyway can understand what I mean. If not, please step in and give me direct feedbacks. So in my opinion is that I'm a guy that is always using pictures. And pictures are for me something, how can, if I have a lot of data, how can I make a picture? And my picture is that I have data rivers. In these data rivers, they are running to a data lake. They are running my near-time, real-time data. This is what I define as a data river. And these data rivers are coming from a lot of sources. And here are some examples, like there are a lot of private and personal data stored in this world. For example, at the moment, to work out and have it implemented a smart home concept for Bavaria, perhaps known Oktoberfest, Munich. This is the capital of Bavaria. And for these 10 million inhabitants, we have created a concept how we can monitor smart home. And of course, you have a lot of information and you need to react sometimes more or less in real time. Sometimes you use the data of the data lake, because the data lake, this is for me something in my picture, all information over the whole time running through the data river, coming in the data lake. And here you have more or less old or outdated data, but you have also the history of the data here. And of course, you can only make an analysis of the future, what could happen if you know the past. So therefore, data lake and data river are both very important if you want to do something like preemptive RCAs and preemptive analysis of a status of a system, what may happen in the future with electricity power. It's in today's time in Europe. On each topic, you can read in each newspaper that we have not enough energy, that, and I think you know it, that always created amount of energy needs to be the same as the used amount. So these are things you can't say, I do it in a calculation of 2 days old data. For such topics, you need more or less actual data. So this is a difference I would like to work out. And this data river also of course contain a lot of information out of the industry. It's also very important. Computer integrated manufacturing and Internet of Things. We have experience, for example, with airport automatization. So here you have a lot of data you need at the moment there. So on a unit load device, this is this big thing on which the goods are stored, and then they are coming in the airplanes and are flight from here to India, and then they are distributed all over the world in India, for example. Then you need to know where my parts are, because if you are a manufacturer, then you need to know when my parts are coming. And this is Internet of Things, computer integrated manufacturing all together. And here you have a mix of data also you need, from actual data down to historical data. And topic in which I have not so much experience, because we as ITBS do not work with cloud-based data, but of course everyone knows about the possibility of these mobile data apps in which milliards of people insert their information. That's of course an extreme big data source, but it's unfortunately nothing I can deal with. The most interesting part for us as ITBS, in the collaboration also with DSU, these are the monitoring data. Monitoring data, this is in today's time, in my opinion, the most relevant information if you want to have a picture, or if you want to understand the status of your system. And this means with status of the system, with monitoring, you can monitor at today's time nearly everything. You have devices which can monitor from air pressure to temperature, from of course the status of an IT system, up to if a door is closed or not. And all this information, this is very important to have the possibility to create create ideas for the future, how to improve it. And this is what I mean with the data river. So in these parts, private, industry, cloud, monitoring, you can, I think, imagine much more. These are for me data rivers. Then we have the data lakes. This data lake is for me something like historical thing. We use it, of course, if you want to go to the future, you need to know the past. You need to know how the system behaved before you can do an analysis and tell there might be a problem. You need to be more or less safe that this will be a problem. If you create for a customer 100 alarms, and then 99 are more or less not interesting, then you have made something wrong. So you should have this past to understand the future. Now we come to the topic that is data protection. I have also created in the next presentation slide more information about it, but it's really very important, and that's my personal opinion. So please don't see this as a general opinion here in Europe. I have here perhaps a different one, that in the data that someone gives to us as company, to a bigger company having this company like Google, Facebook, and what else. My private opinion is that these are my private data. It should not belong to this company. I would like to have the control about it. And if I'm okay, I don't know, I have a message that I'm broken. It's you still hear me? Because I'm here connected with my mobile phone. Oh, okay, let's hope the best. I go on. So this data should belong to the person or the company providing them. And I think this is at minimum here in Europe, this is a big point. If you come to a customer and tell them, I use your monitoring data, I can analyze them, but these are your data. Everything that we are doing with it, we make it transparent. We show the algorithm in behind. We show you the logic. You are not here really that you give this data away and then this data are out of your control. This is something that I see as a very important topic. At minimum, if you go to the European market, this we should follow, because this is here really a topic that is on high level, and each CEO here is on this topic very, very interested in. And this means that we have to deal with the data in a form that they are very securely stored. For this purpose, it's only an example. I don't know if you know a lot about Europe, but there was a lot of, I would say, problems with taxes. The Germans, for example, give a lot of money to Switzerland companies, banks especially, and they did not pay taxes in Germany for it. So therefore, the German government bought CDs with the data of these guys, and they wanted a lot of money back, and even some went to prison. Okay, it was perhaps not the right way from the moral point, but one of these big banks come to us and asked me to develop a concept how we can make data more safe. And we developed a concept that I named NoSQL with SQL. This means that we structure the data in a complete, I would say, file-oriented way, and only with a very secured logic you can put this data again together. We have meanwhile developed this part to a data collection tool, and we are able to collect all this information, and we can mask them directly at the points they are collected. So this is the first security. And the second is even that someone could copy this information without the logic in behind. This data are completely senseless. This is only some examples about things we should keep in mind if we go to the European market together. And I believe that nearly everyone who has data in the cloud or gives data to a third party should have some questions to this company. The data of your company, but also the data of each individual need to remain your property. And this is a very important topic. And this means I believe that in the future, more and more such customer will ask, who owns my data? Who benefits from this data? And who is liable in case of an abuse? Because here it's really millions of possible euros you have to pay in case of this. And I think these are topics which we all need to keep in mind. I don't want to go on with this because the topic is I could discuss about this, I think, 1 hour, and it would not have an end. And of course, this kind of thinking is my private position. There are different positions also in Europe, of course. But if you want to go to the market, and this is one of the winning points that we as ITPS do have on the European market, is that we give this transparency. So that we tell exactly which data we export, which data we store at which place, and the customer can tell us, okay, I want that you mask my data so that you can do the analysis for us, but you don't know the real system names or name of actors or what else in behind. Then customers also will ask and do ask, who do I have access to my raw data? So if a contract ends, where will my data remain? Is it for 100% safe that we as ITPS or another company will delete it? How this can be guaranteed? And a last topic, which is very important. I worked a long time via IBM. We have with IBM good contracts, and I was a long time working with Watson. Okay, I learned a lot about it. It was very impressive how this tool works. But at the end, what you have to see is that the outcome that you created with that, this is based by human beings. Human beings can create errors. So it's, for me, this is what is said. Okay, I don't want to tell it. I can get problems with it. But for me, it's not like that each kind of analysis is for 100% secure and correct. So you need to make transparent how you analyze information, and you need to be able to show it to the customer so that the customer can agree with this. This is, in my opinion, very important to have a trustful relationship. A last question, of course, is always the costs. And we have a lot of companies, for example, with Leica, perhaps known also in India, I think so. They are now going to the cloud, and they ask us how we can support them. I name our things, what we are doing, I name it microservices, because we step in these parts in where the big cloud providers and also want to have extreme high amount of money to come perhaps to a similar result. So therefore, it's also a topic of costs, how the costs are fair and are they planable. So in today's time, there are increasing costs by energy in Europe. So it's really interesting how this will influence the market if now more European companies would like to go more to US because their energy is much more cheaper, but they have some problems, for example, with GDPR and other things. This is an interesting thing for the future. And a question that also each customer should ask and should have a good answer for it: how dependent I am on this analysis, and which power then this provider has over me. So this means if I fully give everything to let's say to a big company and they do all the analytics for me, even in worst case, you don't know the rules really in behind. You have lost the know-how about it. You have lost the control about it because you fully trust in this company. Then you are at the end, you have no chance to step out, or you have a chance to step out, but this then will be extreme painful and with costs. We have here such a customer here in Austria. That's the reason why I'm here. It's a real big company and we are struggling here. We have invested here tons of resources and we don't see the end at the moment. And this is if you do something and at the end you have no own know-how anymore because you give everything to a third party. So in my opinion, it should be always a good relationship between the customer and the third party to give the customers a chance to understand what we are doing. And of course, this is already discussed, how safe are my data? Yeah, learning in time of crisis. Yeah, this is also, of course, a very personal opinion I have here, but I'm not alone with it. So I'm here, of course, in organizations represented, and I have a lot of discussions. And as a VDI, this is a collection of German engineers, and we are discussing about it, and ASIM. And at the end, at minimum here in this environment I am around, we see, of course, that there are big advantages of the cloud. And we see, of course, also that there are disadvantages of the cloud. And we believe that in these times, a mix is a correct solution. So companies should have enough know-how to act on their own. They should have third parties which are more or less neutral in between the big cloud providers and end customers. And this is at the moment also that what we are offering to a lot of our customers, that we help them to go in the cloud, but we guarantee that this is documented so that it's possible for the end customer to reflect it, to understand it, to build up own resources, and to be able to, I would say, keep the head on. Ask your questions, because I got a message. No? Okay. Yeah, so I don't know my time. Am I already too late, or is it in time?
It was nice and you were within time. Really appreciate your participation in this conference as a speaker. And we touched upon a very vital aspect, which is data and different models of how do we manage it and things like that. So, are there any questions?
Yeah. So, Mr. Vector, good afternoon from India.
Hello.
Yeah. Hi. First of all, thank you for sponsoring this conclave.
from ITPS, and we're very grateful. My question was, are people in Europe as excited about analytics as they seem to be in India?
Yes and no. I think here in Europe, a lot of people do not even think about it. That's the worst information I can give you. So I think, but this is normal. Human beings do a lot, and then they give a lot of their information, of their private information, to their smartphones, and then of course to the big players. But okay, if we talk about industry, then of course here in Europe, this is most of the most important topics. We are knowing that we will have in the future a very expensive energy. So we need to invest a lot in computer integrated manufacturing to reduce our costs. We know the political situation, and there's of course an idea to go from players like China to other players, for example, like India, to have here a more or a not so, I would say, complex political relationship as it could be with other like China, yeah, where we don't know what happens between China and Taiwan. And these are, of course, here a lot of discussions how we do reorganize it, how we do reorganize our production logic. Yeah, this logic chain, which was in the last year built up in right in time, just in time, everything was there 10 minutes more or less before it was used. This, of course, is no longer working. So here, this is a chance for us to step in, to develop new concepts, to use the big data for analysis, to give information, for example, that this and this part will be delayed. This would lead in your production chain that this good could not produce in this planned time, but you can perhaps produce something else with similar configuration of your machines before. This is the topics which are now discussed here, to be more flexible, to use the data in a much more efficient way. And that's one of the reasons why we see in this collaboration with you here a big advantage, because we have here not so much students, unfortunately, in technical environment. So this is something that was missed here, in my opinion. I was always thinking about that with a crying, with tears in my eyes, because most of the students do are now things here like, okay, it's also important to know the finance and insurances, but technical engineers are really rare here. And this is the chance we have in this collaboration to do this analysis, to use our power to develop here new software concepts and then to go on the market with it, especially from India, I think, to Europe. The other way around at the moment, I have not so much ideas, but from India to Europe, I see really good chances with your
Okay,
results.
so quick second question. So with Europe's falling population and your not so happy experience with migrants, so obviously, I'm sure Europe would be looking at artificial intelligence to probably automate many jobs. And so are they working in that direction where you want to have less and less human intervention in many jobs? Is that the direction Europe is taking?
Yeah, this will be, but I have not a fear that this will lead to a high unemployment, because on the other hand, we have new expansive markets like alternative energies, and we have also a lot of planned activities in our management of our environment. So I think it will be a move from work to produce something to more work to organize something. And of course, not everyone can do this step. I think there will anyway be enough jobs around. But you are right. This is a consequence with computer integrated manufacturing. We see good chances to bring processes independent from the country structure to other countries, and not only looking on the lowest salary, we can then look on the better qualification. And therefore, this is a big chance we have. And I think this is the way Europe will go. It will be painful for the next years, but afterwards, I think we will be back again. Yeah, you're right. It will reduce the work on each work item. This is correct. Yeah, that's a consequence. But the quality will increase engineering, work will increase, and these people which are then left over, they will get other parts of work in environment, things, or in other processes we have to set up to save our Earth, for example.
Thank you so much.
Okay, so I thank you too. It was a pleasure to talk to you. So I hope that I could give a small picture of Europe, and you are heartily welcome. If you come, I will show you Europe.
I'm looking forward to meeting you in Austria.
That would be great. We are in Vienna here, so I think it's a great town.
We invite you to my wonderful city. It is the futuristic city of India and Asia, maybe, Bengaluru. So please feel free to come and talk to us physically.
I will come back to this. Yeah, thanks a lot. I will listen to the rest of this and wish you a nice day.
Thank you, Mr. Victor.
Thank you.
Thank you.
Bye-bye.
So once again, thank you to Mr. Thomas for his valuable insights on data protection, big data, how it is handled, classified and managed, and also the bit opportunities of in Europe he spoke about. So analytics is everywhere and we are witnessing it from morning. So now to give more knowledge on how analytics is applied in healthcare sector, we have here with us Mr. Sahil Maksud, Principal Data Scientist at Happiest Minds Technology Limited, with 17 years of diversified experience in software engineering, AI, and businesses. He has experience in multiple domains like EdTech, consumer electronics, media, healthcare, insurance, and marketing analytics. We welcome you, sir.
Good afternoon all. Thanks for having me here. I think it has been good session so far. And personally, I've learned so much today. I think what I could learn in months, so much of the experience has come together. So what we will do, I think keeping time check in mind. So when Professor Alok reached out to me, so we thought there are multiple ways in which I can go through healthcare AI. We can take the 33,000 feet view, or we can go with the kind of case study that Happy has done. So what we have done is keeping time in mind. Case studies maybe we can do a deep dive later, but we'll do 33,000 feet view, high level view, how the industry looks like, what is happening, and also we'll take the case study successful example while we are going through. So the agenda wise, we'll cover the market trends and value pools, how market is shaping up in the healthcare, and how technology can help here. And then we'll take the core player pain points, right? We have the payers here, we have the providers, hospitals, what kind of typical and how AI can help there. So that will take. And then the last but not the least, we'll take the how create the data-driven AI-enabled health. So that will be the agenda. So I'm jumping to the trends. I think that trend-wise, looks very promising. The kind of technology you can see, it itself is the market size is increasing, for everything, right? I'm not going to read all about that, but AI, big data, wearable devices, and they are all kind of, building blocks for digital health, right? These are very competent, and digital health itself is, going to be very big market. Even today, it's 16 billion. And market driver, again, these all market drivers, plus, there is a model change happening in the business model change happening in the.
This market size is in India, right? Or
no, this is all over. This is all over.
268 billion.
260 billion. Right. And so though other things looks very good, but there are few restraints, that cybersecurity, privacy concerns that you have heard about GDPR and everything, right? So those things kind of restrict data. That is a restraint. And challenges that we see, though we have heard a lot about it, AI can do that, data can do that, but still the results that we want to achieve, we are far from that. We have done on the ancillaries, we have done some automations, right? We have done data extractions. We have done the kind of claim prediction in the when I go to payer segment. We have done the patient intelligence to some extent. But if you ask about patient outcome, can I predict this guy is going to be heart failure in certain time? Those places where the core values required still we have a long way to go. Maybe we'll reach sooner or later, but the direction is correct. But we'll also cover what are the challenges, why the adoption is slower than we expect to. So we'll cover that towards the end of it. Again, I'll continue with trends, but I think the important part to understand here is care delivery. Again, these are also trends. But if you look at I think in a care delivery there are so many. Even the video conference, if you want to have doctor earlier, we have to always travel. But in COVID time, doctor also have become flexible. So COVID has triggered some kind of digitization, and after that, I think we are seeing much more. Not only healthcare, our industrial segment that we work as in introduction. We work in multiple segments in Happiest Mind, right? So we are seeing a lot of growth in virtual care delivery, and I think the care delivery is the core, kind meat of the healthcare, right? That's one of what it is. Preventive care, I think the preventive care is booming like anything. Everyone preventive care. I have seen last January, very sad that one of my friend passed away with cardiac arrest. We never had any indicator. So can someone something could be done here? That's the key. And preventive care is not only, as Dr. Shubhra Ghosh was also telling that, they are making sure that people drive slow. In the same way, preventive care is important for payers also, insurance company, because if someone reaches the bed, they have to pay a huge bill there, right? And if someone, we have worked with 2 companies here, right, who buy the patient vitals, they're able to figure out that this guy is on the risk. So then they tell the alternate therapies, or maybe go to doctor, start exercise and all that, right? So those kind of things can really help, right? And remote monitoring, AI-based diagnostics, they are healthy trends, and they are ultimately gonna be, the part of preventive healthcare. So that's the preventive healthcare. On operational R&D, I think workforce shortages, I think we all know that everywhere it is, healthcare specifically, in overall it we see, but in certain segments like geriatrics, right, for old age care, we hear that there are 5 million cases of Parkinson, dementia, and all over the world, but the doctors are very less, and they're not choosing that field because being a heart surgeon might be more rewarding, right? So can AI or data help there? Can can it augment the doctors, right? Can that is a thing to see. And drug discovery, we all understand. We have seen multiple things. Even in the COVID time, I heard that drug discovery was done by the GAN network. They started with that, and then they kind of started clinical trials after that. So these are the 5 value pools in the healthcare. Again, I'll just quickly go through. I'll not go to each item underwritten. Care delivery, I think the first one. Wellness, disease and disease prevention is second one. Screening, diagnosis, finance and operation, and R&D. So 5 segments primarily. And again, as we are discussing, the main focus is slowly coming to this wellness and disease prevention, as previous slide also were telling. But again, even the care delivery, the how to therapies to be more effective, can adherence be brought in, right? Now, if you look at certain places in the care delivery, for example, depression issue, right? If someone is having depression, what doctor will prescribe you some medicine, and because ultimately that medicine has to kind of produce the dopamine or some hormone in you so that your depression level are lowered. But doctor will never be able to know how much dopamine you need. He will give you some quantity, and then 15 days he'll call. Are you feeling too excited or still depressed? If you're feeling depressed, he'll increase it, right? But think about how effective the therapy could be, or even the adherence management. If some kind of headphone is given to you with the EEG waves, and it can monitor that, okay, you're feeling more happy, your medicine can be immediately changed. So that kind of value AI can add here. So I think that will go on. I think I'll just quickly rush. But one thing before I go, I think which I want to mention here is, I think the main challenges that we see, apart from these single challenges, right? The patient 360 itself is a big issue, right? Morning, KNB server was telling that data modeling is really difficult. Again, Renuka told it's not so easy, that you bring the data and things will work. So patient 360 itself, we are working with at least 4 to 5 customers where we're building the master data management, and data has to be. And when we say patient 360, what does it mean? For example, I go to Kaveri Hospital in Electronic City. Under my name, my wife's name is also registered, my son's name is also registered. And then they have made names like Sahil and Divyam. In other hospitals, Divyam also, right? And with her phone number or with some other phone number. So to create a single record, to know about me all, it's very difficult. So how we do? We are working on that with MDM solution, with fuzzy logic, with AI, data cleaning, right? So this patient 360 itself is a big thing to achieve. Then the integrated view is not there. Things are in silos. One department, marketing department has its own AI engine. Your core delivery will have its own AI engine. So all that things are fragmented, right? So I think these issues are prime issues that we are dealing with now, and we're making a progress in that direction. So I'll move next slide. So now if you see the core player wise, right? The core players, we see providers, right? The hospital, hospice, labs, all that, right? Again, the same inability to know about patient 360, which I was telling previous slide, inadequate care, inability to track outcome, episodic care. I think episodic care has still remain. We are speaking about value-based care, where you kind of do a contract with the doctor, and where you can say, okay, you will be taken for full year, full year, let's say, right? But that's still long way to achieve, because for that you need to have the full patient 360, as I said, right? And then you kind of you need to figure out what are the risks, right? If I know the risk, then only I can give them the kind of package, right, which will come under value. Again, that is the one aspect of value-based care. There are more there. And then again, in the patient way, which I was telling about my friend, we are always into reactive care. When we feel pain, we go to
Sir,
doctor.
can I ask you a question?
Please.
So, do you have, are there technologies where, say, if somebody is a diabetic, it must be there, I think, intuitively, I think it's there, and then their sugar levels are either rising, and it automatically passes a message, and then something is strapped onto you and it fires in.
That should be possible. I have not heard about this solution, but theoretically, definitely yes. If
there are solutions for continuous glucose monitoring and
also intervention.
So there are a couple of companies which have already come up with that solution. Is available.
Monitoring.
Because my again, my pet theory is there are a lot of people out there who need treatment of the mind, putting it mildly, which we're not able to monitor. Maybe some of these devices can help out in those areas.
Correct. Definitely. I think this IoT plus the analytics, that's what it achieves. IoT devices we are speaking about that, as Srinivas also mentioned, these devices already exist. So I think that is pretty much possible. So I think these are the few pain points for the patient, and again in the pharma, drug efficacy beyond the clinical trials, longer time to longer time for the drug discovery, targeted medicine, inability to do for demand forecasting. Again, demand forecasting looks very simple, but if you look at the changing scenarios, for example, I may say that today my sale is, let's say, 100 million. So next year it will 110 million, because that's my rate, 10% every year I'm increasing. But what about price elasticity? What about the competition launching the medicine? So we, from the happiest mind, we kind of have developed one solution which is simulated demand forecasting, where you can add a lot of elasticity, degradation rates, and all that, by which you can actually make the demand forecasting also very interesting, and you can take care of multiple fundamentals, because otherwise demand forecasting pretty much time series, right? Which you can build the model based on the rate of increase and all that. And again, payers, as we said, increased payout and all that, I think which already has been discussed. So I'll just skip that. Pharmacies, they want to have the insight of the buying patterns to build the demand. So that's what they are looking at. And policymaker specifically, the population health management and health outcome cycles. So that's what they're looking at. So if you see now here, right, what AI can do, the screen point for providers, right? We want to get patient single record, which I mentioned in the previous slide. We can have the adequate care, which we discussed about in the depression disease already, right? They measure the outcome from the patient data, and again, IoT devices, as we're discussing, diabetes example, which you already put up, right? So I think that kind of thing, again, personal experience. If someone is coming to hospital of particular, he needs a wheelchair, it can be pre-arranged. So all that, based on the patient data, we can do. Again, remote monitoring, we all know adherence management is also possible with AI, and wellness intervention also goes hand in hand there. So, and again, pharma industry, again, if you look at the way we have seen that as we said the real world evidence why it is required, because mostly when drug in clinical trials, at that time we have a limited set of people in the student, and again you can't do a drug trial on certain diseases, right? How it is performing, that's the real world evidence where you can collect data. Again, you have to make a way for that to doctors to collect the data and see how it's happening. So analytics can really help in that time. You can track the patient outcome, whether the drug is working. So that's where it can help. Again, trial site selection, you can find which trial site is better. You can put the propensity models there. Faster drug discovery, GAN models. I think I already spoke about the COVID time, how the multiple companies like Pfizer and all that, they use that to kind of find the initial fail fast approach with the GAN models, and they finally discovered few vaccinations there. I'll skip other of them. Yeah, preventive care, I was telling which we already we're working with one of the company in insurance segment where we're building the preventive care, where we are suggesting as of now the map table, right? That these are the ways if someone goes to these kind of vitals. So can you suggest the preventive care system so that with AI you can build, again you have to collect the data, you have to understand that how his vitals are behaving, whether he falls in the A category, B category, or C category, which kind of treatment he needs. So all that is possible by AI. And fraud detection in, I think in payers, I need to speak about payout forecast. Again, depending on how his vitals are, right? Can I find out that when he will need payout, right? So again, it's a major thing for payer when they make a payout. So they can make their the finances in different way. We work with one company who wanted to keep their finances in certain way, like you have FD and the different kind of deposits. Even this company manage their funds in that way. So when they find that next month I'm gonna more claims, so they will accordingly manage their finances there. So auto claim processing, I think that's a pretty much AI and RPA example, which is already working very well. I think customer 360 demand forecasting, I already spoke that, which is already applicable in pharma and same thing in pharmacy. Policymaker, I think we understand policy, population health tracking. You know about COVID, in India, how we're tracking, how who is vaccinated. I think that's one of the example already there. Risk prediction, again, policymakers are interested in. They're also interested in regulations, but yeah, nothing much has been done there on from the AI front.
Second one question. The patient data that we are talking about, master data management, is it happening at a central repository all across, or is it private players? If I go from say Fortis to Apollo or vice versa.
Generally, each company is keeping its own master data, and master data can be around patient. It could be around product, right? Patient could be a master, because in the healthcare industry, patient is named. So we are saying patient single record, right? So you can do that. For MDM, there are solutions like Informatica already available. We have built up the kind of ground trucks for MDM also for certain reasons.
So like this Ayushman Bharat portal, I don't know, there was some app.
I think insurance no, I have a question.
Yeah. See, talk about it. See, what is happening is healthcare data is going to be a federal managed system. I don't think it is going to be a privately managed system.
It cannot be, because it's just like the US.
It is not just like India and US. It's all messed up. One thing, one advantage that European countries have is, for example, in earlier on, Captain asked a question: is Europe working more towards analytics? The biggest advantage that Europe has, I worked in Nordics for many years. Biggest advantage is they have a centralized health data management system where every other hospital, 86% of hospital in Norway is government owned, and even 14% of private hospitals, they have to share data with the centralized health management system. It also means that the health journal is what they call is developed and maintained by the government or the government owned organization, and the access is given to the patient. For example, there is Tom who is in Norway. If he has to go from a general practitioner to a specialty hospital in Oslo, he can open his tab. He can say, okay, I want to give my data access to this specialty hospital. Even though everything is owned by government, the power of exposing his data is given to the individual. So that is how the healthcare system is built in Europe. in many of the countries.
Similar to NHS in UK.
Yes, similar to NHS. So
Canada also.
In fact,
India
India,
is government owned actually.
when COVID was happening, right, with Aadhaar linking, the data was going to government, right, that time.
No, in fact, you are sharing Kaveri hospital experience.
Right.
It is surprising given that we have Aadhaar.
Right.
And why the same record is not available elsewhere.
The people
Can I
that
just answer
entry,
that?
private players
Aadhaar
are not
is
given
given
access
this
to Aadhaar.
The Supreme Court has held that I have a right to privacy. I don't need to get
See, but if you want certain things, you need to implement. For example, you have HL7 and HIPAA Act, okay, related to healthcare.
Right.
Patient record is private. That's why, as I said, patient will have to enable. But patient data mask is useful for pharmaceutical industry, healthcare as a whole. So you can't say in the name of privacy, won't let data happen, right? If this is something we can argue about, if we make what is required optional.
Big topic. In fact, sure.
So I just wanted to ask you, but much of what Sahil presented is, tracking of patients, collection of data and things like that. Right? Is there some real intervention where people's health improves?
yes, yes, it is happening.
How far are we from? How far away are we?
I'll answer that question. About I remember 2009 and when I was in Norway. There was a company which had built a fantastic analytical software. If you had exposed the patient population data to that software, it would tell you with the data that it has got how many people are pre-diabetic, how many are normal, how many are already in a certain XYZ stage, and what is the kind of intervention that you have to make. So we were able to give the entire country data access to them in 2 weeks' time. So they were able to analyze and they were able to come up with a plan, and we were able to integrate with the health journal, that is the Norwegian health journal system which patient accesses, to give training material to patients on or people, not the patient person, to what level is diabetic this thing is and what kind of treatment that he has to take. There was a lot of educational things that were shared. But then we also realized that in countries like India and America, even if we give 10 years time, we will never be able to give the countrywide data to that company to come up with the analysis. So are we able to get a better outcome of the technology that is available? Yes, provided we have a sound system that can support those initiatives. Today, many countries have, many countries do not have. This is at a population level. Now, you should come to an individual level. There are a lot of AI systems that we are building as part of the edge computing, which goes into medical devices, which help in aiding minimally invasive surgeries in operation theaters. This is helping a lot with this problem.
Yeah, and another example I was giving was from the payer perspective, where they are kind of able to monitor that your vitals are things like that. So rather than go to hospital, I started going to numbers, right? So even there, the recommendation system is built up based on what kind of therapy you are using, the ABCD example, right? So where you lie, based on that, they kind of give you kind of treatment therapies and all that, right? So yes.
Are we looking at reduction in healthcare cost?
Not really. As of now, we need to cover the small selection. I think the reduction in cost may be coming now, but if you go 5 years back, reduction of cost was the prime thing which we want to deliver AI. But now we want customer experience, better outcomes. That's what it's leading to. Though that will also come when you're kind of automating certain things, right? But again, in my opinion, automation is not gonna kind of shipping jobs. In today's time, it's not pure automation, not pure AI. It's now human and AI working together. So it's like human and a wife. For example, machine learned something wrong. Right now, doctor is looking at. Doctor will say, no, machine is wrong here. But AI detected. So then, machine will learn from doctor. But now it can't learn from one doctor. It will look for the 5 doctors. 5 doctors will 3 of them are saying that this is I've detected incorrect. So it will learn. So human bias and machine bias now is being kind of combined. So that's the now trend, which we are calling decision intelligence in today's time. That's also kind of trend.
From what you said, it's good to have national level health record. because your sample is much bigger than having isolated records.
Correct.
But then private hospitals are going to object to it.
See, there has been some kind of those things, but slowly government is also coming together to maintain that records, like sir mentioned, right? But now, you think about when COVID started, right? That time we had very less cases. Though you have record, but you finding symptoms slowly. Then whatever we are learning new, we are taking that, right? This three doctors said this kind of symptom is COVID, right? Two said it's not COVID. Maybe I'll go with. So machine is also continuous learning. So
Just to add to what he said, man, it is not the private hospital that is going to object. In Europe, northern part of Europe, decided 10 years ago that it is not the private hospital who is supposed to decide whether to share data or not. It is you as a person. You have to decide whether you have to share your data with central government. You know what I'm saying? So if you say yes, private hospital, they do not have any authority because you are the owner of your test data, not the hospital.
So can we have Sahil continue the presentation?
Yes, sorry.
I'll take
Just one question. I think this is similar to what Captain asked, right? I think when you look at data-driven AI, it's disrupted many industries, like getting you Ola, Uber, and everything, right? And getting you Paytm. What has it done to the healthcare industry? What is the disruption?
Disruption, I will know whether to call it disruption. As of now, in my opinion, it's helping. It's augmenting as of now. Disruption, I don't know what we call disruption. Disruption means, less doctors are required, the way we treat. Some of things have happened.
Disruption is a change in the way we do things.
Change value,
You
change
see,
value.
one thing is that what we call as health care, actually is sickness care. Much of our healthcare industry, correct?
Which part of the value chain has been impacted by
that could be the opportunity for disruption also.
Like,
in fact, I was looking at the BRICS, amongst the BRICS nations, Brazil has got a per capita health expenditure of around $947. India is the lowest, $75, out of which 70% is private and 30% is public.
Most people can't afford it.
Yeah.
And in Medicare is cheaper.
No, these are very good questions. I think, I think so. I think now we're getting into how to make AI enabled or data enabled healthcare. I think a few things, which if you go from the bottom, now what is happening is I was saying earlier that all these, departments, if you in the hospital, in the payer segment, they all have different models. Some of the companies have taken a step where they have the common data platform. Everything is kind of systemized. Every layer is there. But as of now, it's in silos, right? When I say it's not a generic statement, but we have seen in many places, right? People are consolidating data, and MDM is being built up, right? So the foundation looks like this. We have data in the bottom, right? And a data should be clean. Data platform means, if you have multiple systems like CRM system, ERP system, EHS system, lab systems. So all the data has to come in one place, sit in data platform. Again, the system will still be there, but data will keep coming in so that we can have data in one place where we can analyze data. Then comes master data management. We already discussed patient single records. We took Kaveri Hospital example earlier. Data quality is a key. Sometimes missing values are there. Spellings are written incorrectly. Data duplicates are there. How you kind of get rid of that. Data governance very important. Data should be discoverable, accessible, and all that. There should be policies around data, who can access what and all that, right? So that if this is not there, right, above the trust will not be there. No, anyone can do anything with data, right? And then last but not least, as you said, HL7 standard and all that, interoperability, FHIR standards, that makes sure that if that is not there, your payers, pharma, all of that can't share the data. If I'm speaking English, because everyone understands English, right? I start speaking other language, you will not understand. Same way, interoperability will be making sure that. So once we have this foundation, we can think about trustable AI. I will not speak more about it. I think next session is all about that. But the main part is, you can't use, data in the malpractice way. You can't use certain features. For example, maybe the race and the ethnicity you can't make into model which is being preferential statement to some patient, right? So that has to be taken care. Even in the one popular model, not in the healthcare, but in the recruitment, what we saw, the hiring model was giving the bias to white versus black, right? So that became a big issue, and that was taken out later. So that trustable AI layer will make sure. And above what you see is kind of the AI layer where you have to model deploy feature stores are there so that your models can be used across. Your data can the feature what you do in one place you need not to replicate it, right? And features are also become kind of become AI catalog or kind of the foundation of trustable AI. Then you have training, distributed large data coming up, distributed, you have multi GPUs, Spark kind of system where you can train the system and ultimately deploy. And then now the part is, if you want to really make the system very strong, it should not be like a POC model, right? You are looking at the model which scales, which kind of works always 65 days, 24 hours. For that, you need to make sure that you have to kind of look at the drips. If there was symptom example, which for COVID, because when COVID came, people are learning what are symptoms. Everybody, there are so many videos on YouTube, right? What are symptoms? So can that drift kind of model can understand when drift comes, it should continuously go automatically and retrain the system. So system is always running. So that kind of becomes the kind of foundation. And after that, we have enablers, right? Again, the first enabler is patient data, patient history, which we spoke already. Second is next generation, how my staff is performing, whether I know my service gaps. So all that will come here. Asset analytics again, from the diabetes example, which we took already, right? Where we are kind of able to get the, or maybe variable devices, we can get the data, or from the medical machines, we can get the data. And once we have these three things ready, then you can think about how care delivery will be looking at, right? On care delivery, I can get patient data, right? I can know from his vitals, he'll come to hospital. From next generation enterprise analytics, I can know how much operations I'm ready at, how many doctors I have on that day, how much load will come. From IoT devices, from remote monitoring, I can know that possibility that these many patients will come because their vitals do not look good today. My care delivery can be planned in much better way. In the same way, you'll find certain things here as well, right? So that's the core idea. Now this is the picture where we want to be.
I'm really I really want to apologize to you that you have so much content.
No worries.
Really left. Okay. But I think we had a great time with Sahil and many other interventions by Srinivas sir really helped. Okay. And I would request you to please come to our campus.
Elaborate here.
Very interesting. So can we have a round of applause? Interesting session, responsible and interpretable AI. It will start sharp at 3:50 p.m. So we will finish the IT and come back. You want to announce something? Thank you so much. And please, sir, may I invite Siddharth Agrawal, please, CEO of Innocential, to hand over the memento to. Thanks a lot. Thanks a lot. Apologies again.
It's very interesting because I think healthcare directly impacts all of us.
Absolutely.
I think we need for one day workshop.
Absolutely. No, he was associated with Dhananjay Sagar. So we have a break now. No, that'll be.
Second floor.
ठीक है बाद में It's all in the that shows that there is a real interaction going on.
I was had some question for this topic.
Many like
very important. Actually, what it is was like learning happens in industry.
Tell us how you know reach there, sir.
I have learned one thing. I never started from textbooks. I started with problems first.
Shankar sir.
That's all.
Professor Shankar is one of the architects of this conclave.
Oh,
Sir, okay. Yeah. Sessions. Again, now it's pre-press again after 2 more sessions. Yes.
Right, sir. Come for tea. Come, sir.
Yes, sir. No choice. We will probably be there. Join.
Come, we'll go.
Coffee.
So she actually, when she is announced, no one would have given. We don't know, no, but it's okay if she announced. It's better to give it. Then she has announced already.
How good.
And
But the best.
even Hina also, she came with the. So she would like to.
But this stock I don't think will be over before 50.
They will be there. Those who came in bikes, they will be there. You can leave that.
I'm worried about that.
Worried about them now.
Yeah, because no sir, here after 4:30 you not get vehicles 4:40. Yes. ಅದಕ್ಕೆ ಕಾಲೇಜ್ ಬಸ್ ಅಲ್ಲೇ ಹೋಗ್ತೀನಿ ನನ್ನ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್
Because Saturday, it will not come till 5:30 to go. You can have tell the bus guys. They will not
maybe
get
keep you till 5:30.
you have to tell them that.
Very nice.
You put extra bus.
But extra bus.
How many of us?
You say VC is part of this.
Five of us, no?
Madam, you have to say VC is part of this session.
Madam, not five, four of us.
Bus sir, it is not. Make the bus wait.
Today it's raining, so Pavitra ma'am will also come. Today it's raining, so Sunday sir also.
So Sanjay sir, I think he brought his bike.
Rains. Sanjay sir, if it rains, Sanjay sir may also be our guest in the bus.
I don't know.
We have
Abhijit sir also comes in the bus.
You can tell that Harish that we're having a function and we will be late. They wrote.
Yeah, we had to once get the bus back.
We'll tell Rahul sir.
He will.
He the last person to tell actually.
Why do you say that? Say, why do you say that? That he is the last person.
Well, the cat. We do not want to.
Hey, by the way, we still haven't made that announcement about Ernst and Young.
Sir, bus chapter.
What's the official? He has the ENY mail come officially. ENY.
They've shared. It is shared.
How many have got from our
77.
So make a noise about it.
They will. Today is they are
Tell it
busy.
to the whole world.
Yeah. I want to sit here, that side and sit.
You know,
I think Sanjay sir also came in.
Yeah, but I will also leave with you.
Yes, sir.
The company only has
one person.
Please, at least call it after the one guy comes. Data line is
it will come here for every specialization Yes, this is starting. Yes, sir. Otherwise, students will feel it. That's visualization of it is starting. So then visualization. Yes, sir. Look at the statistics of last year. This is starting. Maybe these students will be awarded to that particular.
And next year you also have 125.
Okay.
What you said, you know that. It's a fear.
I had very little experience.
Problem statement is conclusion. Correct.
Two objects, key major findings. Major findings.
I think Dr. Srinivas. So Dr. Srinivas, can you hear us?
Yes.
Good evening, everyone. I welcome you all back for our evening session. Explainable artificial intelligence is a set of processes and methods that allows human users to comprehend and trust the result and output created by machine learning algorithms. Explainable AI is used to describe AI models, its expected impacts, and potential biases. To share much more in detail about the topic, we have with Srinivas Padmanabhuni, AI Together Leader, India. PhD in AI from University of Alberta, Edmonton, Canada, specializing in AI. Prior to PhD, he secured his BTech from IIT Kanpur and MTech in CS from IIT Bombay. His areas of interest are AI, machine learning, software engineering, cybersecurity. Earlier, he was a principal research scientist and associate vice president at Infosys. Dr. Srinivas Padmanabhuni was awarded as a title of eminent engineer by the prestigious and renowned organization of Institution of Engineers. We heartily welcome you, sir. You may take over the session.
Thank you. Thanks for the opportunity. Very apt conference for everyone. So I hope my presentation is visible.
Yes, sir.
It is. So what I'm going to talk about is something which is very relevant in the today's environment, especially when AI is getting mainstream. AI is being used for business applications. We've seen lots of talks since morning on different domains like insurance, like agriculture, etc. So what I'm going to talk about is something which is, you can say, at the forefront of today's world, in the AI world. It may become mainstream in the very near future, but definitely this is something that's going to be at everyone's, you can say, doorstep very soon. So we all know about AI, right? What exactly is AI? AI is about the concept of being able to display intelligence like a human being. And when you talk about displaying intelligence, it's about three things. One is sensing, where you control acquisition of data from different sources. It could be from X-ray images of patients. It could be from sensors which are coming from a driverless car, or it could be coming from your sales data, which is coming from inside, or it could be coming from a voice which you're listening to, like an Alexa. Then you analyze and sense patterns from that data, which is what is the whole core of what you call as machine learning. Then after taking that, you have two paths. Either a human takes an action, like a CEO taking an action by analyzing the sales data onto what strategy you can take. Or you can have autonomous system taking an action where the enabling agent inside the AI, like in a driverless car, will take the decision after analyzing the data for patterns. It will take the decision. So if you see, there are three parts: the sensing, where it is data in, then there is pattern extraction, and then in response to that, either a human does action or the machine does autonomous action. So whenever you look at any AI applications, treat it from these three lenses: data in, pattern extracted, action either by human or by a machine. But what is the underlying technologies, as you can see, right? It's about the pattern extraction is the core, that's the brain, that's called the machine learning. Then data ingestion, which is coming from the different sensors. What kind of data? It could be structured data, it could be image, video data, which is what we call computer vision, or NLP, or text mining, which is what we call text data, and speech processing. While, I'm very gung-ho about this whole area of AI, but unfortunately, AI is plagued with several incidents of failure, several accidents. In one case, a pedestrian lost life. In another case, a hiring tool had to be withdrawn because it was gender biased. In another case, a security hacker threat on a public chatbot caused it to be withdrawn because it was poisoned with, abusive data. In some cases, the model itself failed in the field. But if you see what it does cause things like loss of money, loss of reputation, loss of life, and most recently, we also seen compliance issues because of these reasons, where AI is becoming more powerful, and we need to also bring in control so that we can reduce the possibility of failures and accidents. So if you look at the whole idea of preventing this, there are two dimensions. One is what we call as explainable AI, which is basically the emerging field of being able to formulate the possibilities of being able to explain the decisions which AI systems have taken. It could again be two types, where we have interpretable, which are simpler AI models, which can be interpreted by human beings, or you can have aid to more complex models-based decisions, where you provide explanations post facto after the model has taken decision. We'll look at some of these aspects in detail. Then the other aspect is we are looking at how to mitigate the risks related to the withdrawal of AI systems in the field on account of lack of responsible behavior, or lack of adequate testing, or lack of adequate governance. And that's where we broadly look at it in three dimensions. One is security or adversarial attacks, privacy breaches, then bias and fairness. All three are extremely important from human values perspective. So we say responsible AI is a superset of the broader requirements for all this. Explainable AI is a subset of it. So let's look at what it does to even definition of something which we all understand from ISO perspective of what a system quality means. But what happened is, in the context of AI systems, the quality heads of different standards groups have come up with different additional quality requirements. Like we know AI is expected to display intelligent behavior. So agent which is displaying ability to learn, it can provide natural interaction like a human being, it will provide transparency of choices. If you see transparency of choices, that's all about explainability. Can you provide transparent mechanism into the way the AI system is working? So the idea is, it is because we are entrusting more and more mission critical systems like healthcare systems, the recruitment systems, transportation systems. We are entrusting many of them to health AI systems. So we need to be able to provide intelligence at the same time with transparency. Then we have morality. That's where ethics, privacy, these come into account. So when you talk about responsible AI, it is a broad umbrella which covers around these three dimensions of morality and transparent intelligence, and something which is like emulating human person, is basically looking at empathy and looking at end user perspective in mind. So given that even the quality people are talking about bringing these kind of accountabilities to AI, think about that's the future. You cannot have those days when anybody, any big tech could come and just use anybody's data without proper permission, violating all rules of the law, and then do some havoc with the data and make money from it. And also in that process, violate every rule of the law of the land. That is what is happening in the reality of the AI with the big tech systems today. So the biggest movement which happened in this direction is this concept of what we call as transparency in AI. When I say transparency in AI, it's about bringing a pre-facto or post-facto explanations to the AI decisions. So as per OECD AI, the regulations are coming up where we say AI actors should commit to transparency and reasonable, responsible disclosure regarding them. So what they should do, they should provide meaningful information appropriate to the context, consistent with the state of the art, to foster a general understanding of the system, to make stakeholders aware of the interactions with the AI systems in the workplace, to enable those affected by an AI system to understand the outcome. To give an example, the recruitment tool by AI, if it is denying probable recruitment to a candidate, it should be transparent. It cannot be just that whims and fancies. I've trained this black box algorithm and taken a decision. Or somebody has rejected a credit card because of historical data being biased towards typical white male, and you happen to be a minority male and you have rejected because the model trained was unfair. So it's very important that we need to also understand information and the logic that's served as the basis for the prediction or the recommendation for the dish. And that's where explainable AI comes in. So as you can see, unlike traditional systems which are rule-based, AI systems behave differently because they are all basically bound by probabilistic metrics like accuracy and aggregate measures. So basically, users are asked to trust a model, which is usually a complex black box scenario. But the principle we want to follow going forward is trust but verify. And then another important category, which is what is coming up in view of the different accidents and oversight, is the regulatory compliance, which wants better visibility into the rationale of AI decisions. That's example EU AI Act. And today, in fact, there's a huge movement even in US with NIST drafting regulations on this. So what we need is we need to have tools that can be able to answer the question, why the system did what it did, how will it behave if it is a different kind of a scenario. So that is where the explainable AI starts to come in. There are different approaches. Some of them are model agnostic, black box, doesn't matter what the model is. Some other model specific, like they use the actual structure of the model which you are using and using that to create the explanation. So there are two schools of thought. The first school of thought is what we call as the concept of interpretability. Interpretability says, please don't use complex algorithms which you cannot explain. That means even if it is not the best of the best deep learning neural network, state of the art transfer learning, I won't care less. I would be interested in being able to be answerable to my credit card customer whose credit card I've denied, to be able to tell him what rules was followed and why it has denied him the credit card. So that is where we have examples like decision trees or linear regression, just simple models. Then we have external tools, which are post-facto explainability models. That's where a lot of work is happening, where given the current model, which may be very complex neural network, but we should give a tool to help explain why it took the decision it took. That's where the concept of external tools which are coming up for explainability. That again, you can see there are different approaches, black box approaches like LINE, which do not take any advantage of what the model structure is. It's a black box. Or you can call about model specific, which understand the structure of the whole network, come and work with traversing the whole structure of the model and create explanations. So let's look at example of interpretability. The interpretability is about a simple model like decision tree. It's a decision tree, which is a very simple machine learning model. It may not be as complex like neural network, but it looks intuitive. It checks easily for unexpected results. So what you can do, you can think of this kind of a decision tree as a set of rules. Like if it is overcast, it's going to rain. If it is rainy and it is not windy, it will not rain. That's the kind of example rules you can derive from this kind of a decision tree. Then coming to example of the black box model explainable rules, things like LIME has become very popular. The LIME tool are based off algorithms are very simple. They take any classifier, it could be black box with neural network, black box with decision tree, black box with random forest, doesn't matter. What it does is it tries to generate new data set from within the existing test data, and then tries to find out predictions of the perturbed data or the new generated data on the decisions the model takes, and then it tries to plot the sensitivity of the perturbations with respect to the original data. And in doing that, what it does is it gives a very nice idea, like what is the focus the actual model is looking at. So for example, if you look at this particular example where predicted is cat but actually is dog, see the structure of legs resemble more like a cat. Or if you look at the concept of predicted cat but actually is dog, the head region which is it focusing on, it's basically making it classify like a cat. So this is what the explainable AI is talking about. Across domains, this is what is the technology which is coming up, which is what we call as the concept of explainable AI. Now coming to the other aspects, right? What are the other aspects in responsible AI? We need to talk about these aspects in equal importance. If you remember the example I gave of AI failure, Amazon tool, recruitment tool, which was found to be biased against a specific gender. Or very recently, there have been examples of resume tech companies in US which have been found to be biased against certain ethnicity. Maybe it's not their fault. It's because of the training data that is available, which probably belongs to majority class or some kind of a majoritarian data, which has not been properly stratified and sampled so that it represents the society as an equitable manner. So what happens is basic issues like fairness and ethics are violated if you don't put proper guidance and proper tests in place for AI/ML systems. So given that the model produced by any training actually reflect the data used to create the model, we need to ensure that data collection process is fair, representative, and unbiased. Even if it is not, while providing input into the training process, you should make sure that it is sampled with equal priority. So we need to ensure that the generated model is represented to the population without any bias. And today, so much so that all the responsible AI initiatives from governments across the world are very clear that they will not allow any big tech or small tech to deploy a biased or an unfair model. But sad part of it, let me tell you, the sad part of it is we are so enamored with technology that when we see a large language model like GPT coming at our way, which can generate plots from stories or something which you give it a keyword, it will generate a picture. We are so enamored by these technologies. But let me tell you, they are the ethics bombs waiting for explosion because they have been found to be royally violating every ethical principle that is there out there because all of them have been trained on real world data. Real world data is definitely not biased. So we should be careful about big tech, big AI. A lot of excitement about story generation. People can create great 3D images from simple textual descriptions. All that is great. But let me tell you what is the harm. They may be using data of somebody without anybody's permission. And that is where it is important to understand privacy, bias, and fairness are very important. Bias is a very important part of fairness. Thorough training data, which is represented of all classes, is very key for all the training requirements for data. Testing for fairness should be part of the process. So if somebody is failing the testing process, you just do not want to allow it to be going to the deployment. So corner cases for underrepresented classes should be given disproportionate sampling to give them similar levels of right. And constantly monitor the deployed model for bias or drift. Because what happens is, as language changes, uses shift, biases and prejudices are discovered, make sure that the algorithm is revisited, retrained on new data, and you deploy an unbiased and fair algorithm. So fairness is the cornerstone of responsible AI, and testing for fairness should be a through process before, after deployment. Testing on data, testing on model, both become important. Now coming to security, this is again a very, very dangerous phenomenon. We have a new hacker in town. The hacker in town is called adversarial attack. The adversarial attacker use attacks like, fool the model into misidentifying, misclassification of the current data into a wrong class. Though you have a face detection, let's say, you recognize your face with that, but the fool will try to create a morphing layer before that, and will try to create a possibility that you may not be allowed entry because the model has been fooled to not allow entry. Think about the situation like this. And imagine out there how many AI systems out there have been just deployed without the security testing. And that is the scary part. Even though we try to educate several big companies, small companies across the world on importance of testing for security, for fairness before deployment, but I think the data scientist community is a very, very close-knit. They don't want to listen. They're not open to feedback. And so I think I want to use every occasion, every forum to guide them that the need for testing security, testing for fairness, testing for privacy violation is very important. Because before governments come in and make your revenue zero by just pulling it off, you better be responsible. That's what is my, guideline. So what we're seeing in adversarial attacks is very simple transformations on the image are able to fool the models. And when you do that, for example, you look at here, the adversarial examples, all images on the left column are correctly classified. But you put small changes, small additional pixels on each of them. All the images on the right side are categorized incorrectly as ostrich. You can't see the difference. It's not visible to eye. It is about small transformations which are done on the image transformation. And that is what is called adversarial attacks. So it's a very difficult world out there. There are new category of hackers in town. You have to make sure that the model is not deployed without having gone through a security test. And then last but not the least, the biggest cornerstone and a lot of debate happening across the globe around privacy. So what is privacy? It's about you governing the way your data needs to be used. So what happens is, as AI evolves, it magnifies the ability to use personal information or personal information in ways that can intrude on your privacy interest. And it may cause exploitation of those personal data. And that is something which is not necessarily a good thing for each of you. But luckily, today, there are rules and regulations coming in place to handle the data privacy regulations, which will be applicable on all AI, ML, and data-related models. So we have regulations like GDPR, which place data restrictions on data and model preparation, and data privacy requirements, which are precursor to AI model privacy. So at model level, privacy inference attacks need to be detected and minimized. What is privacy inference attacks? These are a group of hackers who are not security hackers. Their only goal is to uncover private information from the models. And that's what they succeed. And if that happens to have leaked PII data, that means your model is actually leaking, what it should not be legally leaking. So if you look at GDPR, what they're talking about issues on data privacy like data stewardship, which is basically, duties of fairness, which could basically talk about militating against the use of personal information that is probably unfair to them. Like if your gender information is causing you a problem related to hiring, that's not accepted. Data transparency, which is basically you have the right to know how the information you're given is going to be used, which basically means algorithmic decision taking, which is binary, which is blindly taking your data and going and creating models is a no-no. And then data governance rules that prescribe the appointment of privacy officers, which is basically a idea of, it's not about, talking about only after some whole analytics has been done. It's about privacy by design. Can we have a product planning so that it is not just about during the model, preparation, but right from data collection, then data exploration, then data preparation, then modeling. At all stages, you have privacy, built-in privacy into the whole ML and AI process. So rules on data collection, sharing should be also reducing possibility of aggregation of data. Aggregation of data is a very dangerous thing. The raw data at the first level may not give you the private information, but when you combine 2 and 2, you may get inferred data, which may be leaking some private information. There are several examples of aggregations leading to loss of private data, right? So it is important to understand that all of these become very important in the context of ML. That's what the EU AI Act and all of these are talking about, is coming to terms with a new kind of AI, which will be more responsible, which will be ethical, which will be unbiased, which will be secure. And that is where we talk about the whole concept of responsible AI being a desirable state. And when you talk about responsible AI being a desirable state, it is definitely a long way to go before complete realization. Lots of new laws are coming up which are mandating responsible AI, including as late as last week, NASSCOM released the blueprint for responsible AI. And explainable AI is also mandated in verticals like healthcare, resume tech, financial credit modeling decisions. It will also help reducing accidents in AI. It's been a new area like AI security, privacy-aware data mining, and ultimately new quality attributes need to get added for verification and validation and testing of AI systems. So what I would like to mention is ultimately the goal of this whole topic is that we should include responsible AI practices in all AI solutions, all AI products, and all AI-related development scenarios. So, as I said, we need to be aware of the dimensions of responsible AI, namely privacy, ethics and fairness, and security. So that is just a small list. As we speak, the EU AI Act is even coming up with even more rigorous definitions, because for them, anything which involves human lives is of highest priority. They have categorized the things into 4 levels, for example. Some they're okay, saying we'll let go as long as you are showing some explainability. But some they said you can't even take it into production. For example, anything which tries to go and do a face identification in the public without the knowledge of the person is a no-no. That's absolute no-no, because that's a gross violation of the basic fundamental right of the person. So with that, I'd like to show a brief of this product called AI Ensured, which is what we do in terms of explaining all kinds of AI models. So you get an idea of what explainability means for different kind of scenarios. So I'll just show you a screen, which is basically going to tell you what is the meaning of explainability. So here is an explainability of the concept of, an image classifier, which is looking at actual, supposed to be predicting elephant, but it has predicted giraffe, because the surrounding areas, the green areas, is where it has focused on. So what is explainability given you here? It has given you a debugging way to debug the model. And that is what explainable AI is all about. It will give you a mechanism to explain the data and give you some kind of an explanation of why the model has predicted the way it has predicted. So same thing continuing on, I want to show you the security attack vector. This is something which is very dangerous. Actual image, which was the class 3 horse, but you see small perturbations, which is the adversarial perturbation, and you see that it has predicted a wrong class. This is the kind of adversarial attacks we're seeing in the real world. So what we need is a way by which you can test the systems and improve the model. And the proof of the pudding, we can show you that if you do it right with proper testing and retraining with respect to the corner cases, we can actually show that here is an example where before model, the class it was predicting was wrong. But when we took testing and when we tried to look at the retraining with respect to the corner cases we generated, it behaves correctly. That's why testing for identifying the attack vectors and then retraining the model with those attack vectors in mind is very crucial to bringing security to this. And then lastly, I wanted to show you something which is very surprising, which is what I call as the inference attack. See, I only gave the model to the attacker, but the model attack from inference perspective has inferred the training data from the model itself. And that is what is scary, where you say that I've given the model, I'm not giving the data. Is that good enough? But point is, there are attackers out there who are willing to, reverse engineer. And imagine if PII has been leaked into that. That means that you are definitely liable for all the typical legislations which are governing the whole prospect of what we call as maintaining privacy. So all in all, three important things. Explainable AI is going to become mandatory in all AI projects as we go along. Second, security, privacy, and fairness related testing has to become mainstream as part of data science lifecycle. And in fact, it's also a way I would like to educate all complex algorithm guys and data scientists and all the complex AI scientists, right? They better come down a little bit and let their systems be audited. It's no longer like the high ground they can take that their algorithms have done great work. It's no great shakes, because business ultimately has to be answerable to government before doing harm to people or to individuals, right? And then lastly, we need continued research on responsible AI on dimensions like AI security, privacy aware data mining, more explainable AI systems, and the business implications thereof. And with that, I would like to stop here and hope it has given a new dimension to what you're being here. Thank you.
Dr. Padmavani, this is Anand. Excellent presentation, very insightful. One question on your last statement, I've been thinking about that, asking you. Question is, when you say mandatory, so when you say this, is it internal compliance, or there will be you think there will be a regulator eventually, and because if there are going to be external regulators, then it can't be one regulator for all kinds of domains, right? So how do you?
So what I'm seeing is there are two levels which are happening. One is like the governments themselves coming up with prescriptions which may turn into actions, like EU AI Act. NIST is coming up with a Responsible AI Act. Even Department of Defense is working on some Trustworthy AI Act, etc. That is one thing. But the second thing is also about each organization appointing some kind of a best practice officers like data privacy officers or AI ethics officers who will be mandated to go through and audit this model. So I would say it will be carrot and stick. Stick is going to come to some extent, but it may not be possible to do 100%, because I don't think all governments have that much wherewithal to appoint auditors or something. But what may happen is they will open up, scenarios like if you see pharmacovigilance in pharmacy, right? What happens? It's an open complaint scenario where anybody can complain about any allergic action or adverse reaction. And the pharma companies are supposed to voluntarily disclose. But is that enough? But what happens is FDA has a project Sentinel where they look at social media and analyze what are the adverse reactions reported. So we'll have a combination where governments will try to look at public disclosures and then some amount of voluntary effort from government. So I don't think it's going to be like a stick which will come in as enforcement on every there. But if some end user gets affected, then it's going to be a severe reaction. That's going to come. Those days are gone when big tech have their free day and it'll be like, use any data for anything and do anything.
Yeah, but I just have one more question.
We are actually behind screen. So
I have one question, Professor. That is, when you said explainable AI, where the AI has to say how it arrived at a certain conclusion, what is the limitation? Does it have to say the source of data, accuracy, authenticity, the methods used, algorithms, or where does it really end?
So today, the situation is, like I showed you, right? It is very focused on what part of the image is the focus of the current, algorithm, which is why it made the decision. So if it is a set of columns, it will tell you which features in the columns have given more weightage. It could be at an example level, local, or it could be at a global level, which are the features. So it is at that level, but people are working on even going to the level of, can we identify those rules from the original data, which are underlying, for that particular application. So as I said, this is still a work in progress. Current word is, can you pinpoint the part of the image or part of the input data or the part of the text, which are the input keywords, which are responsible for this particular decision. So that is the current state of explainable AI, but it is working towards getting more and more, what you call, extraction of probable explainable rules.
One last question.
Next. Mr. Ganesh is there. Thank you, Dr. Srinivas Patramuli. Nice seeing you again.
Thank you so much, sir, for giving us such a good explanation about explainable AI and how the underlying technologies will work and areas where AI is becoming very strong and very responsible, and about the ethics and about the biases. So it was a wonderful explanation. We thank you again, sir.
Yeah, so I request everyone to follow our YouTube channel on AI Ensure. We have a flagship product, first of a world kind, for auditing AI models for trust.
Sure, sir.
This analytics conclave for morning, we have been listening to various speakers talking and giving us more insights about analytics and their roles in various sectors, how it has grown and spread across the world. Now, let's invite our next speaker, Mr. Ganesh Mani, who is an adjunct faculty at Carnegie Mellon, USA, who will spill the beans on data and analytics in emerging economies, its opportunities and challenges. Sir is a global executive and thought leader with a deep experience helping produce as well as consume AI responsibly for health, wealth, and wisdom. We welcome you, sir. Over to you.
Thank you. Delighted to be here. Thank you, Alok and Siddharth, for inviting me. I'm assuming everybody can hear me okay?
Yes, sir. We can hear.
It's always tough to be the last speaker. I'm sure all the eminent speakers before me have covered everything, but hopefully there are a couple of new thoughts in here. That's my Twitter handle. I'm not that active on Twitter, but available on LinkedIn as well. Let me see whether I can scroll through here. Having a little trouble with the, okay, here we go. So this is, speaking of grand challenges, this is an article we came up with last year in AI Magazine. You can look that up. What we came up with as a potential mantra, if you will, is of the people, by the people, with machines, for the people. Sort of harkening back to Lincoln. With respect to machines, we mean things that many would consider sort of useful, efficient, etc. We went through a number of, the motivation for the article was Professor Raj Reddy, Turing Award winner, who was a mentor and a colleague of mine. 30 years ago, he had come up with some grand challenges for sort of the next 30 years. And so it turned out that, a lot of them are still open. For instance, accident avoiding car, I think we're halfway through the journey. There's SAE, the Society of Automobile Engineers, which defines the levels. Levels 1 through 5, we're somewhere between level 2 and 3 currently, and I think maybe stuck a little bit. World Champion Chess Machine, that was one that was completed pretty quickly. Translating telephone, I think the form factor may need a little bit of work, and some of the low resource languages may need some work, but I think that's pretty relevant to the emerging economies, and I think a lot of progress has been made there. Now, let me see here. I'm continuing to have trouble with the slide scrolling. I think we're good here now. We should be able to go forward. Speaking of challenges, so for the next decade, instead of 30 years, we came up with some new challenges. I won't go through all of them. I broadly think about the world as being made up of 3 spheres, right? We all seek added health, added wealth, added wisdom. So when you sort of bubble that up at the economy level, at the policy level, those are some interesting ways to think about it. With respect to health, are there automated tasks within a nursing home? With respect to wealth, or there are agents in the background that can give you financial advice? It already has your data on an opt-in basis. Can it negotiate now that mortgage rates have gone up dramatically? They're going to start dropping over the next few months. So is there an agent behind that can provide you a loan at the interest rate that you're looking for without you doing additional paperwork and so on? And wisdom is very important. I know you folks at DSU span all the 3 spheres: health, wealth, and wisdom. With respect to wisdom, the amount of information is growing geometrically. The average quality of information is coming down, right? And also the half-life of knowledge is shrinking. There are new developments every day, every week. Just in AI ML, I've been reading that there are 5,000 papers now being submitted into archive every month. Nobody can keep track of it, so you need curation. You need a lot of interesting ways to use AI in the wisdom sphere as well. There are some interesting challenges. For instance, we put down winning the New Yorker cartoon caption contest. I'll show you a cartoon later on, but those are things that would be interesting for AI to solve, because that solves a lot of interesting sub-problems as it does that. Other people suggested some challenges which are very interesting, for instance, around climate change, pathogen resistance. I was talking to a physician acquaintance of mine after the article came out. He said, you didn't address special needs. How can AI help special needs individuals? I think he had a family member who was very interested in that, for instance. Now, these sort of challenges, act as a North Star for youngsters in the audience, for researchers to decide what sort of things to work on next. There were also a number of co-contributors. Frank Chen and Andreessen Horowitz talked about teaming. I always say the new definition of AI is really augmented intelligence, so it's sort of congruent with that. Ken Stanley at the bottom from OpenAI, he talked about open-endedness. Can you have an AI system that's really at a meta level thinking about open-ended problems and solutions to them? So that's sort of an interesting feature to imbue into any system. I teach a class around grand challenges and AI and emerging economies for the global audience. So I had a number of guest speakers in the class at this go around. So a few folks I want to highlight in their work. This is remote sensing and some of the agricultural decisions. Professor Catherine Nekalembe, who's from East Africa, but also is involved at the University of Maryland. She's got a number of interesting things based on satellite images, based on drones for ag tech, for deciding how the land is being used. And it can also be used to impute climate change. So if you have images that were from a year ago, from a few years ago, you can see what sort of erosion has taken place, or after an extreme nature event like it happened in Florida, right, recently, and so on. So very interesting applications for remote sensing around disaster management, ag tech, etc. This is a survey paper from a colleague of mine, Professor Fei Fang. If you Google AI for social good, then Fei Fang, you'll sort of find it. You can see that over the years, the number of papers in healthcare and transportation with an AI for social good motif has been increasing. Another speaker was Sandy Pentland from MIT, who's sort of a founder of the Connection Science Lab there. This social media, as well as how the world is connected, both in terms of information, people, other things, the network effects. They're looking at that as part of the Connection Science Lab. He talked about data potentially as being a means of production. In the old days, if you remember Econ 101, it was land, capital, and labor, right? Now, can you think of data as being one of the factors of production, either as capital, or I think for many of the businesses we focus on, land is becoming less important, right? A lot of things we're doing now via Zoom, a lot of the digital businesses, so data becomes very interesting. Some people make the data as oil metaphor. There's also this whole push towards digital public goods. We talked about digitization. Kanwal Singh from the Gates Foundation, who's been involved with the India Stack and really taking India Stack and putting it to countries like Philippines, Morocco, etc., both from a payments as well as digital identity perspective. CMU Africa just had the conference on digital public goods. I didn't attend in person, but there were a number of interesting speakers. You can again look that up on the website. Switching to sort of this health, wealth, and wisdom spheres, if you will, we use AI quite a bit for second opinions, right? So here is the lion saying, "I'm ready for a second opinion," one of the famous cartoons, if you will. And this is what I was saying, we chuckle at easily. Is it also something that, an AI system can easily recognize and explain to somebody who, for instance, may not get the joke and so on. So here we have, these are all the FDA approved systems by anatomy. They've been tagged in terms of whether these were tested in a multi-site format and so on. I was involved as a second reader for mammograms, one of the earliest FDA approved systems by the name of a company called iCAD now. This is a more recent list. You can find it on fda.gov. So on the right-hand side, you'll see the matrix. I don't have everything on screen, but there are actually now over 500 systems, and a lot of them have a radiology or cardiovascular focus. Somebody on LinkedIn, Jan Bager, just converted this to a graph to see which are the companies that are active in this space. So GE Healthcare has about 42 of the FDA approved systems. Likewise, there's the site grand-challenge.org that has systems listed from Europe as well. There might be a similar list for things approved by the regulators in India. So I think this whole area of using AI, ML data and analytics for healthcare is booming. The regulators are involved. So for entrepreneurs, it's not a straight line to revenue, but it's sort of interesting, especially some of the more recent ones, and the pace is picked up, right? These are everything on my screen was approved, I think, in July of in 1 month in 2022 by the FDA. And generative AI is big. While I was waiting for my turn, I put in the prompt data analytics conclave in Bangalore, India, right? This is what the Crayon system generated using DALL-E Mini. as you can tell, it's pretty realistic, right? It might look like the room you're sitting in. This also opens up new careers like a prompt engineer, right? How do you put in a prompt to generate the images you want and then manipulate it in Canva or Adobe and so on? And then what data is it using, right? For instance, it might be using the data science masterclass that Sid Sarab and I organized about 5 years ago in Bangalore. There's the late Dr. Jaime Carbonell, there's Marco Grabelnik from Europe. We discussed a lot of national policies, workforce reskilling, and so on. But this is the kind of data I think Crayon's potentially using. And at that conference, somebody asked about, was the Trump administration here, also known as the tariff administration, if you will, which was looking at the provenance of metals, provenance of goods and services. You know, they said, is the provenance of AI important? So I wrote an article called Made in India AI, appeared in the Business Standard shortly thereafter. So as I thought about it, it seemed like a data science project can be broken down into three things, right? It's the data, it's the domain knowledge. How do you manipulate the data? What does it mean when you have a certain metric you're trying to predict or optimize? And what are the tools that you're using? So the tools tend to be more widely available, egalitarian. Somebody in India, somebody in China, somebody in Mexico has access to the same tools. It's the regional flavor of the data and the domain knowledge that's going to sort of show you how powerful the system is and whether it's brittle and so on. So pay attention to the regional data, the regional domain knowledge and so on. That was one of the things that came up with it. And also speaking of data, there's sort of regular data, like in the stock market, there's data that comes out of the exchanges, price volume primarily. There's data that the companies publish and have to submit to the regulators. It may be every quarter, earnings, other information about the company, but there's this whole field of alternative data that's emerging. This is a publication that's coming out. I think Taylor and Francis is publishing it, Handbook of Alternative Data and Finance, gentleman from Europe, Gautam Mitra is spearheading it. I have a chapter in there along with a few people. This is really a data. We talked about remote sensing, sort of, can you look at footfall in a mall? Can you look at the number of cars in a parking lot of Walmart? Can you look at credit card transactions and so on, right? And over the pandemic, there was a lot of focus about alternative data because the traditional backward-looking data wasn't working anymore, right? A lot of the machine learning systems became brittle because they were trained on historical data and the data changed dramatically, right? We had 3 sigma, 6 sigma moves in some of the data. So some of the alternative data can let you impute ESG type of things. So this was 2019 and the left pane, the carbon dioxide emissions from aviation so dramatically fell off as we stopped many of the flights and so on in March of 2020. This is a new data stream here. The TSA is the airport checkpoint. So they started publishing data around how many people are going through the checkpoint every day. It turned out to be a very interesting proxy for economic activity, if you will, here. Likewise, seated diners from OpenTable, which is owned by Priceline. As you can see, things dipped almost 100% because all the restaurants were closed and then it started picking it up. But you have to bring in some additional nuances, right? You need to know what the weather in Pittsburgh is, which tends to be cold as opposed to sort of a Las Vegas. So as you can see here, or Miami. So Miami sort of picked up in terms of the restaurant seatings well before Pittsburgh, which is in light blue, or Washington, D.C., which is in this sort of dark canvas color. Likewise, some of the Airbnb and remote secondary hotels or housing sort of picked up before some of the traditional hotels and air travel and so on. So alternative data is becoming really interesting. This is a recent study from The Economist. It says, if you look at the night lights, right, that can be a proxy for GDP or economic activity again in the whole region. But then depending on whether it's an open democracy or whether dictators rule, you can see there's a big difference between what's published by the government versus what's implied by the nightlights and so on. There are some folks in India, actually friends of mine, xkdr.org, they have a paper on normalizing the data using lights in Mumbai. Ajay Shah, Susan Thomas, and others. I have the link here. I think they were speakers at the previous masterclass that we organized. Again, speaking of alternative data, this is sort of an interesting data stream from the Biden-Trump election. The election night was very confusing, and even when you woke up on November 4th, if you looked at all the news articles, turned the TV on, people weren't sure whether Biden was in fact winning. This is a graph from the betting markets that morning. The betting markets had already decided that the Biden contract was at 75 cents, the Trump contract was at 25 cents. So there was a lot of volatility overnight, but this alternative data stream was giving a clear signal early morning while the pundits were still a bit ambivalent. Likewise, this is from the recent Brazilian election. So you can see that, the issue was whether they're going to go into a runoff, right? Or is there going to be a second pass in the elections? And if you can look at the Google Trends data, that was showing Bolsonaro to be neck and neck or ahead with respect to the search alternative data stream against Lula. So this sort of data would have pointed out to a runoff being more likely and so on. So now again, so one of the things with respect to a technique standpoint, we talked about alternative data. Novelty detection tends to be sort of an interesting technique. So as streaming data comes in on the top left, you have a constant event. You have sort of a potentially new event that's forming. So this could be financial data, it could be network data. I know the previous speaker, Dr. Srinivas, talked about network effects. So this may be a new node perhaps. And this bottom left-hand side is sort of an obfuscated event, right? So somebody trying to perhaps do something under the cover of a normal event and so on. So based on some of these quantitative calculations, you can try to recognize which regime you are in. Or is it a growing event? So we actually, for the funding agency, took 3 different data sets. One was around money transfer. Again, there might be money transfers happening. Here you have to report anything that's over $10,000 that's sort of moved from bank to bank. So people do a lot of $9,900 transactions. We actually took all the hospital admissions just after SARS. This was done about a dozen years ago. So all the hospital admissions in the state of Massachusetts, we looked for a rare disease like bacterial meningitis. We found a cluster of young people. So it was an approximate match query. It so turned out that afterwards, if you did a Google search, it was the track team at Northeastern University. So a couple of them had gone to a different hospital. A couple of them had gone to Brigham and Women's. So the reporting structures weren't there to sort of make them interesting enough above a certain threshold. But if you do queries like this, you can try to get an early warning system for the next pandemic and so on. It was very interesting that we found something interesting that was then targetable back to a news article about the track team at Northeastern University and so on. So that showed you the physical cohesion. They had trained together, and when they got sick, they went to the different hospitals. Likewise, risk management tends to be a very important task that you can solve. You traditionally have high volatility in emerging economies, not just with respect to markets, but with respect to data, processes, etc. This is some work actually on the left screen. A high school mentee of mine did around digital assets and modeling their volatility using some of the traditional techniques going back to the Garch models, which actually Rob Engel for his Nobel Prize did some work with UK inflation data. We are in that same regime again, it feels like. And this is something interesting on the right pane, forecasting volatility using swarm intelligence. So this is a set of humans coming together and using a platform, and the underlying assumption is much like collectively bees and ants and so on make interesting collective decisions. Can humans come together aided by a platform? So we modeled a lot of volatility in assets like Bitcoin, tech stocks, and so on. So that can again be used in the emerging economy regimes for doing some interesting things. We're also moving from traditional science to machine science. A few years ago, one of my colleagues who came up with the superhuman poker framework using game theory, they appeared on the cover of Science. Now, the cover of Science used to be reserved for a new element or perhaps a new cure for a disease, but it was sort of interesting that some of these game theoretic bits-based formalisms were being featured. Now, journals like Nature have come out with newer journals, Nature Machine Intelligence, where that's focused on, but the fact that science was transitioning to machine science was interesting to me as well. I don't have time to go through all the nuances. If you think about the different building blocks, atoms, bits, and cells of the world, there are implications with respect to friction. Cost of replication is near zero if it's a digital good. Likewise, velocity of innovation, and so on. Let me see, there's something in the chat here. I think Anup has put in a feedback form. Yeah, so please fill that out, folks on Zoom, as well as people in the audience there. Let's see. So this is, I think the previous speaker covered a lot of the ethical issues, so I won't dwell on it, but this is a gentleman who was wrongly accused by a facial recognition algorithm, so we need to be careful about that. And I have a nuanced perspective on facial recognition because here we have the Second Amendment rights. A lot of guns are causing trouble, even with the police and so on. So facial recognition should not be thought of as either or technology. It's what the substitutable technologies are, what other technologies are. So it's a more nuanced conversation. Likewise, when you, I talked about atoms, bits, and cells. When you get into the cells regime, this is some hue and cry from the last few years about the China's CRISPR twins with the genetic engineering that's going on. So ethical issues become paramount, especially in cells and so on, because they are irreversible. We talked a little bit about ESG, but this is an acquaintance of mine, Ricardo Vinuesa from Sweden, who published this a couple of years ago in Nature. There was a meta study looking at all the studies using AI in the service of the UN Sustainable Development Goals, right? So it turns out that it's a bit nuanced. It's not that AI is helpful in all cases. There are some negative impacts of AI as well because of, again, the differences between sort of the digital haves and the digital have-nots. You can create further exacerbation of the Gini coefficient or the access to technology tools, which then affects your economic well-being and so on. Another example is the large language models. The large language models are generating some interesting text, but then they also consume a lot of electricity and so on. So that becomes a nuanced example as well. So I think I want to end there with this quote from Alice in Wonderland. This is the Red Queen telling Alice, now here you see, it takes all the running you can do to keep in the same place. If you want to get somewhere else, you must run at least twice as fast as that. I think that's probably a good message for the youngsters in the audience. So I want to stop there. I've covered, I think, a lot of ground. Just wanted to give you folks an overview and take some questions.
Which one?
So you have to repeat again.
Which one you want?
Should we be buying cryptocurrency? Is my question, Ganesh. What are you?
I wasn't able to hear, but now I can hear lightly. Is the question, should you be investing in crypto and digital assets? Is that the question?
Yes. Based on your AI experience, what you're seeing, you showed us some AI predictions of crypto. Based on that.
Right. So I think, again, I don't want to put any. The unanimous.ai folks have come up with a thing called cryptoswarm.ai. You can try to take a look at that. They're actually launching that in the next day or so. That's a token you can buy, and you can also then get access to the intelligence of the crowds around crypto. So that might be something you may want to either partake in or at least monitor. So we did some correlation analysis, right? They said even gold is not rallying strongly in this sort of environment. And people were saying crypto is sort of the millennial gold, right? So the correlations have been very time period specific. Bitcoin is acting more like a fintech asset, if you will. So I would say, if you're ready to buy risk assets, you may want to look at digital assets, but digital assets probably have a really small sliver in your portfolio. But given where the macro environment is currently, there might be values in some traditional assets as well. So it's a very nuanced answer. The jury's still out with respect to digital assets, but I think there are some very interesting use cases. And I think there are some very interesting use cases for blockchain as well. So.
No, he didn't say yes.
You didn't say yes.
No, you didn't say yes.
There's no yes.
Dr. Mani, I have a question for you.
Yeah, go ahead. Go ahead.
You talked about AI-enabled devices. So is it related to edge computing? Would you say that?
Yeah, so edge, it's the, in fact, when we had this discussion with Sandy Pentland, right, he talked about this sort of federated learning and some sort of edge computing. It's the mountain or the Muhammad, right? So you need to get the data to compute, or you need to get the compute to data, right? Because there are these privacy issues and so on. So federated learning, some of the edge computing can help with less data sharing. So I know Dr. Srinivas talked about the privacy preserving computation and so on. So there's no free lunch. You can maybe get a win on the privacy side, but the edge tends to be sometimes a little weaker in terms of, some of these things, the large language models and so on for retraining.
What I wanted to figure out was, if you have that edge AI capability, then your responsiveness will be better, and it is distributed processing. So that's what I was trying to figure out. Is that is
So,
like
yes, so for certain applications, it definitely does make sense. So if you're a surgeon, I was recently in Africa, and so it turned out that the Intuitive Foundation people were in there as well. So they were doing skills training for surgeons and so on. That brought up another meta point around skills diffusion being a little different from knowledge diffusion, right? But to your point, I think edge computing definitely has a place. So machine learning systems, there are two phases, right? There's sort of the learning phase, and then there's sort of the behave phase. The behave phase, some of that, the fast inference can be done on the edge for some mission critical applications for sure.
Thank you so much, sir. It was a
Thank you for listening, and carry on.
So, Professor Mani, next time you are in Bengaluru, please do visit us. And at Dayanand Sagar University, it will be a pleasure to have you physically here.
Absolutely. I was just there about a month ago. Let me see when the next trip will be. But
next time I'm at Carnegie Mellon, I'll bump into you. Of course. Thank you.
No, there's a lot of interesting, even if you look at sort of the rankings of universities, right? I think the center of gravity is shifting to Asia. So delighted to see a lot of interesting educational efforts, not only on your campus, overall in India as well. So very, very interesting.
Thank you. Thank you. Thank you.
Thank you so much.
Thank you.
Now, I would like to thank Professor H.N. Shankar sir, who is constantly supporting us in terms of moving forward in the field of analytics with his vast experience and networking. As a token of love and gratitude, I would like to request Professor Alok Chakravarti sir to please present the memento to sir.
No, I didn't expect this special honor. Thank you. Better accept.
Yeah, you deserve every bit of it. In fact, I will talk about it in my thank you note.
So Alok, RT has what's 5 minutes.
Okay, sure.
You can leave.
No, it's okay. Let us invite this sir. Yeah. Thank you, sir. Thank you so much. Sir, please follow.
So, yeah, good afternoon, everybody. So, I think many of you might have heard me when you were joining your course, or in the course of some of the discussions we had. So, I want to just highlight a couple of people who have come to this forum. One is Srihari. Please.
Can you please come to the dais?
Srihari is the founder of Tibble, which is an analytics company. So if any of you want jobs, you know who to go to.
All promises.
I want to meet him. Job is different. I want to meet him.
So I wanted unfortunately this forum went on a bit too long. Otherwise, we were going to have a panel discussion where we could have had both Srihari and my long-time friend and CIO, ex-CIO of Airtel, Chakrapanni. Yeah, you need another conclave. Because Mr. Chakrapanni was the CIO of Airtel, of Tata Sky, and many other companies. He also has a startup, so if you need jobs, you can approach him too. Both of them have immense experience in the industry, especially in the data area. And I think one of the things I would like Srihari maybe to talk a few minutes about is, I think a lot of people spoke about AI, right? But I think what Srihari talks about is how data engineering and how data itself contributes to AI rather than, yeah. So Srihari, over to you, and then to Chakra.
Yeah, sure. No, I promise you that I won't take more than 5 minutes. And it has been a long day for all of you.
want to take an example from today, right? So all the sessions. I happened to join you folks a little late from 3 o'clock onwards. If you take the, what did you derive of all the sessions that have happened, right? That's data gathering. There were some disconnects, there were some longer than what we wanted them to be. There were like some bang on 5-minute conversations that have happened, so on and so forth, right? So why I wanted to take that example is that what we have started believing in something called as data-centric AI. So when you start the journey with this pie in the sky, right? So this we want to solve all healthcare problems of us, all wealth problems of us, and we all want to become wise, to quote some of the things that I've said. No, it's a pie in the sky. Right? So we've got to be a lot more realistic on a day-to-day basis, right? Which is what is referred to as the data-centric AI. What do we have to start with? What's this little thing that we want to solve for the next quarter, right? So things like that. It has to go in an iterative mode. Most of our customers, right, when we deal with that with them, the problem is how they are defining that, right? Which came out in some of the conversations today. Right? So, I'm assuming some of the students are here, right? So, I came for you folks too, right? So the thing is that it's all our responsibilities. All the people here with the gray hair. It's our responsibility to how to deal with it going forward, right? Not get carried away with this big talk, which has come up in some of the conversations, how it ends up being a talk and then not the reality. Some of the questions that have come up with, there were some skeptics in terms of, can it even be predicted, right? So it started very early in the conversation, right? So not that one version is right and the other version is not right. They're all, unfortunately, they're all right. Because that's the complexity that we are dealing with. There are pockets in which this has been working. There are many pockets where it is not working. So for the younger folks, how do you deal with this? How do you deal with this very difficult to get your head around the concept type of thing, right? What's this predictability? What is this AI type of thing, right? So in short, what we refer to as the data-centric AI. At a later stage, we could have more of a discussion with everybody on the data-centric AI. Just like how this session needs to be, it has to be a very interactive, the need versus what data is required, what's data telling you, what does it mean for the business, again bring it. So what we refer to, Girish, my partner here, we keep talking about the loops, like the feedback loops, right? It has to be closed, it's a closed loop, and then that has to go on and on, right? In short, that's what it is. I want to take 2 more minutes to talk about an important aspect. Out of all the sessions, my favorite has been on the responsible AI. Wonderful thing, right? So, I've always believed in what was discussed in that one. But when the way it has been put across in a very structured fashion was very beautiful. What I want to share with everybody is that the quest for this so-called, the machine has to solve everything for us. The algorithm has to give answers to all my questions type of thing. Is it even possible? Right? Do we want to make it happen? Right. So where should we stop? Right. So and that's the point I want to leave you folks with, is that human element. Right. So I don't know what to call it. Right. So it's not just the intelligence of the human being. Probably that can be replicated. Instinct. Right. So any other words? Right. So
intuition. Humanness.
Humanness. Right. So humanity, or whatever that one is called, right? So creativity, some of you folks would call it creativity, but more than anything else, like there's something that was valuable that has come out of that one. There is the kind of the word that you've used. Do we even care for each other? Or do we care for other people? Empathy, right? So many words, right? So how do we come up with an algorithm for that? How do we quantify that?
I mean, Blink is one such example. Malcolm Gladwell.
Yeah. Okay. Right. So in the how do I put it? Do we even need to solve that? Is the question, right? Why do I need an algorithm for that? Right. So again, not to get into this debate of like cultural differences and all those things, but there are cultures around the world that actually, with no data, no quantification, no scientific evidence, you just say that, hey, be good. Right. But there is a business plan.
What 120 years back, when the Luddites burned the steam engine, the same argument was pushed forward. Any way you slice that onion, we are much better off today than we were 100 years ago.
Scientifically.
Even otherwise,
yeah.
Healthcare has improved,
yeah.
Education has improved,
yes.
People don't slaughter each other anymore to the extent that they were slaughtering each other. Yeah, unless there's a nuclear exchange in Ukraine and Russia, we don't know. So I think getting a little mixed up.
Yes. So, so
just one point I wanted to inject in this. Joseph Kekuler, got the structure of benzene. He was struggling all through his life, and in dream he realized a snake eating another. And he got up with the structure of benzene, it proved right, C6H, right? You can't explain, no logic, but he has just been thinking about it. And in his dream, he thinks of one snake eating another, comes out with C6H. How can you explain that?
Yeah.
Only humans can do that.
Yeah. And that time, there are a lot of classes that have come out. Yeah. Right. So the intuition part that you're talking about, tying that state. I'm not saying that we shouldn't pursue
if AI can solve our healthcare issues in India, I'm all for it.
My question is,
human mind has to give the final decision. It cannot be that the machine tells you that you have cancer, but then doctors will have to analyze that.
Say 300 years ago, maybe many people did not know. They thought the moon was a planet. If somebody had said that 1969 Neil Armstrong is going to walk on the moon, they would have laughed at you.
See,
right?
Coming to what you mentioned.
So no, if a machine thinks for you, so far it's not thinking.
It thinks for you, but finally the human has to decide. For example, IBM Watson.
Why are you so categorical that the human must
because
decide?
they couldn't detect cancers.
We don't know.
Watson didn't fail. No, it failed because
we can actually have this discussion more at length sometime.
Yes, this is that. This is not to say that. So what
the communities did the work together.
There is the systems have to be developed in such a way that how do you the human contribution of that one right now, the way they are being designed is that now how do I build a technologically sophisticated system and then making it like not addressing the human aspect of that, right?
I think people are pretty cognizant of what are ethical issues. For example, Google threw the Google Glass out, right? When it was sort of crossing certain boundaries, the self-driving car is in a bit of a plateau now because people are still concerned as to what human beings still are in control. But I don't like this categorically to say machines should not think for you. We don't know. Maybe that will be good. I can see many people don't think for themselves in any way.
I know. So let me just try to state the difference. I think you guys are not saying different things. You're just saying that machines should not think for you. That's not what he's saying. He's saying machines don't feel for you. That is the difference.
But actually that's not true. For example, today there are experiments where you can park a lot of sensors in your head and they can actually feel emotion. They can sense emotion and channelize it to whatever, right? And maybe they can replicate it. So we are going down that path. you can actually have a machine which behaves perfectly like a human being, maybe 25 years from now.
We don't know, it may happen, Captain, it may happen, but then finally the human
No,
element cannot be ignored.
I don't like that one.
Human
I
element-
don't like that, but we don't know. We don't know.
As of now, human element cannot be ignored because
So why
final
you so,
decision making has to be
without,
human.
without knowing, you're very categorical. Let's leave it open.
Okay,
So actually, I just thought I'll wait.
Yeah. Chakra is going to be.
Yeah, actually, I spent all my life in telecom, 2.5 decades. So whenever I speak, or wherever I speak, people ask me, hey, what about 5G? What is it, data analytics and stuff like that? For a period of time, I was just, when I was sitting with Arvind, when 10 years back, we were handling around billion records, 500 million subscribers, each person making 6 calls a day. That was the retail calculation. When we started it. Okay. And today it is, I think, 6 times, 7 times an hour. Connecting the dots and coming to the point, if someone had asked you a question, maybe even 7 years back or 5 years back, hey, in the India, I was also listening to one person from Norway. In India, okay, if the transportation industry will get revolutionized, we would have said no. Today you have a Uber, you have Ola. Same question. In India, at some point in time, if someone had asked you even a few years back, how much of a credit card you use, how much of a Paytm or phone pay you use,
so for example, you say,
so
for example, 4 years back, if somebody would say that, say Professor Mani could speak to us from Carnegie Mellon, nobody would have thought so. Or Thomas Spector could sort of ship us 500 euros for this conclave from Switzerland, and nobody would have thought so. But today we are placing students with him, right? So there are
possibilities.
Possibilities. I don't like finality. I don't like this is wrong, this is right. No, I don't think so. I don't think
not that. I think here's also part I want to tell you about. So you need to have, actually there are 3 parts. First, it looks like an engineering. One is the device, Samsung, some Apple, some today Apple watches, which send the data back to healthcare data and all that. That's part one of it. And second is a carrier, which is your 2G, 5G, how inexpensive it is in India to talk, Probably if you travel across the world, no, if I can say Uber driver or a taxi driver will talk that much as an Indian Uber driver talk. If you drive for 1 hour, just assume 45 minutes will be talking. Okay. What I was just saying was one is the device, another is the carrier. Second is I was just coming to what Shriyati was saying. Data and process maturity. That's what probably is an Indian brand, Do you call the process as a contact or a touch point, or where you generate the data and then how do you gather that? I'm sure we are doing quite a lot of things. I'm sure we will do it. There will be that explosive point what Arjun was telling. We will be there. I think even the healthcare also will be something like Uber and or like Paytm.
The one point you said, data comes from measurement. There are certain many aspects you can't measure, but still they influence. How do you address? Of course, that is beyond.
That's where actually the data science works. What you can measure, I mean, in a very simple statistical word, either you extrapolate, interpolate, or predict, or you guess, right? I mean, in a human language, That's where exactly the data modeling, whatever you call it, data engineering, data sciences, they all come. Actually, Einstein really didn't go there and measure that, light will bend near black hole or whatever. You can measure it today, the telescopes and all that. That's what exactly you do with A data. I'm just focusing. B on modeling, okay, and C on your predictions and all. I'm sure.
We should have another conversation.
Yeah, absolutely.
To understand exactly.
More or less around
I'm sorry, we couldn't accommodate more time.
That is the spirit of this entire conclave. That it's not. There is no finality on anything. We have to sort of discuss,
to continue,
understand, interact.
No,
there are so many point of views.
No, Alok, unfortunately, we couldn't give more time.
Absolutely. So
for a round.
And no, I have these to play.
No, this is a great forum.
Let us change it to analytics continuum.
Yeah,
because it doesn't have breaks.
Yeah. Sir, thank you so much.
Thank you so much.
So thank you, everyone. The expert knowledge we got today was of immense importance. And sure, the experience and the exposure which we got on analytics and its application and its real-time application in various sectors will help us in our career tracks. And yeah, of course, it made the difference in the knowledge what we had earlier and now. So we can say that DSU always focuses to inline their students to be updated with the technological updates, and especially in business analytical platforms. And this conclave is the best example for that. So I would like to thank our college, Anand Sagar University, once again for such a great opportunity. Now it's time to conclude, but before that, I would like to invite Professor Alok Chakravarti sir to propose vote of thanks.
Thank you so much. And I promise I will be short. One of the best compliments today I got from Srihari, which is that in a business school we are talking about AI, analytics, data science, machine science. So I think there are so many elements which need to come together. So I will be short. It all started with a brief conversation with our dean that can we have this, and as it always pans out, he sort of gives it a look, and then comes back and yeah, why not? And I'm so grateful, sir, for helping us and supporting us in getting this done. Somewhere Professor Shankar chipped in, and the size of this entire thing grew because of you, sir, because ITPS got involved, Arable Labs got involved, you brought in Data IQ,
Thompson and Lily. Never see the Thompson and Lily.
I'm being data driven here. Let's not get emotional. I'm being data driven here. So the credit where it is due. So there are several things that Professor Shankar has brought in here, and we are very, very grateful. So give him a big round of applause. Sid got involved, and he's a disruptive guy. I can promise you that. Even at night, he was before he was taking his flight, he was giving some inputs, and sir knows me that I get anxious very fast. So anyway, but it all panned out well. You might argue that we can in future have less speakers or less whatever. So there are so many takeaways to how do we improve this thing. But I think you guys actually made it. It was initially targeted at only students, but then with the participation of industry folks, I think it grew to another level. There were various types of discussions. I'm so glad that it was all possible with so much of diverse participation. I would like to thank Imtiaz and your team, IT infrastructure team, Mahadev. This kind of the connect that we got for the virtual speakers, that was awesome. The student committee which got formed for this, actually you guys actually conducted this, okay? I'm proud of my IT specialization students also, both major and minor. I will not take sides, but yeah. And there are so many faculties here. There is Dr. Pavitra, Dr. Jayashri, who have supported us big time, and Dr. Abhijit. Yeah, I mean, how can I forget it? It's, so many things. So it was all a teamwork, and I'm so glad that it all happened. Thank you all, and let's have, as you said, analytics continue. It was a very short. This one, had I known maybe a week earlier, we would have planned the shift. Thank you so much. Anybody has anything else to say? But at least we can have some Can we have a photo opportunity, please, with all the faculties first and all the industry folks? Sir, please. Thank you. Thank you, sir. That's all.
Thank you.
No, no, I said faculty. Everybody. I said everybody. Please.
Sir,